Okay, now let's look into the functions of the various dimensions that are available in the AutoCAD menu. So towards this, we have two different ways of specifying this in the GUI interface. So one thing is, here you can see that in the menu bar, we have this dimension menu, where you can see the various menu that are pertaining to the dimension. You have the quick dimension. Then in linear segment, you have the linear, aligned, arc, length, and ordinate. Whereas in the angular, we have the radius, jogged, diameter, and angular type. And then again in the dimension line, so whether to start the dimension based on the baseline variation or to continue the dimensions, and then define what's the dimension space and break is. Then also additional annotation commands pertaining to dimension, that is multi-leader, specification of tolerance, then specifying the center mark, then inspection dimension and jog linear dimensions are there. And then we also have oblique dimension and also text that are placed onto it, like what is the position to it, how it is aligned to the dimension space. Next, specify the type of the dimension, then override and update of dimension and reassociate. So these are the various dimension commands that are available. So likewise, you can also view that in the annotate tab. In annotate, we have this dimension segment, wherein we have the quick dimensions here and other dimensions categories are positioned here, and all the what we have seen in the dimension toolbar is available in here. Also, you have this extension bar to specify the same. And also, as continuing, we have the center mark and center line, and then multi-leader line, and again leader variation is where we have this. Also, in this home tab itself, within the annotation tab, we have an option to specify the quick dimension or other linear dimension categories. So these are all what is available in your ribbon and menu bar. So likewise, in order to call these various dimensions, when you type in DIM, you can see the various prompts that are available. We have the generic dimension, then dimension linear, radius, angular, diameter, and so on. So all that are pertaining with the DIM command all operates on the same dimension command. So let's look into one by one now. So to start off with, let's draw rectangles here of some arbitrary dimensions. So now let us invoke the dimension linear, the first command of us. So it is called by dimension LIN. So towards this, there are two methods of specifying the dimension linear command. It is the first one to specify the origin points of the extension line by picking the points. The second way is to select the object directly, wherein the associated dimensions are specified based on the selected object. So we'll go of the first method one, that is the selection of the origin of the extension line. So here we have to specify the first point of the extension. So if you can recollect, in the dimension sector, we have seen like the starting points are here, from there's a gap, and then the dimension extension line is drawn, within which the dimension is marked. So we specify the first point and the second point. So now this first and second point can be taken in any order for a linear one. Now the third point is specified to position the height of the dimension line. So based on a text, based on the object that you work on, you can position it accordingly. So our third point was here. So now you can see that the dimension has been marked up, and you can see that the arrow heads are well defined. We have the extension line with a gap between it, and the text, that is the dimension line, positioned right in between the dimension. So this is the first method of specifying the linear dimension. So now the second method is selecting the object. So before going on to that, we will also see what are the other subsections that are available when we are taking it. So when invoking the dimension linear command again and selecting the first point of origin, then we have additional commands by that can be invoked or seen using this command line. We'll call in that again dimension linear. So once we select the first object and the second object here, So here, before pressing on the third point, you can see the options that are available. The first one is the multi-text, multi-line text. Next is the single line text, that is positioning the dimension in an angle, or horizontal dimensioning or vertical dimensioning, selecting between those two, or rotated base dimension. So you can choose any one of this. So suppose this we have to choose for the horizontal type, then we have to press on H, so that now from those 2 points that I have taken, it will try to push in the horizontal way. That is, we are overriding the dimension. So this kind of thing will be useful when we are looking for a chamfered edge or so, wherein we have to vary between the horizontal and the vertical dimensions. So the next command what we have is in the dimension line, linear. So here we have the, again we look into the M text command. So that is, if we type in the text option, then we can override the dimension by typing the text. So let's say that this is going to be the height of it. So typically what we are doing here is, so now typically we were specifying the horizontal distance, and hence the dimension has been positioned from the first origin point to the second origin point in a horizontal manner, and without specifying the dimension width, we are overriding it by using a text. So this M text is used to define a multi-line text, whereas text will define a single line text. So these are the two differences. So also one thing is, like when we call in the M text option, it will display the in-place editor, the text editor that we have seen. So wherein we can edit the dimension text, that is control the height of it or the font style of it, the bold, italics, alignments, those things what we have seen in text all applies to here. So then in order to add a prefix or a suffix, then we have to enter the prefix or suffix text before or after the generate measurement. That is, we are overriding this. So let's look into that command now. So for accelerating my PC, I'm deleting it out. So dimension linear is called, and the first point and the second point. Now let's select it to be vertical, and now in vertical let us select it as a M text. So now you can see, based on this positioning of the cursor, we can either define the text to be the prefix or suffix state. You can see when you click in the left or the right button, it jumps before or after the dimension. So suppose you can see the height is going to be the prefix and mm is going to be the suffix. Then you can see that the prefix and suffix is added to the dimension line. So in this mtext command also you can add in the control codes or Unicode character strings that we are seeing in the text command, that is for the diameter symbol or whatever symbol is called for. You can specify those individual characters, special characters using this control codes. So again, to edit or the text, then you can double click on it. So now it will call for the text formatting tool again. So now you can edit the text what you have entered here. So this is the mtext command. So whatever style you have already selected, that will apply to the command line here. So next, again, the other command is the text command. So this acts in similar line to the mtext command. So here, when the text command is called for, we can directly customize the dimension text in the dynamic input sheet as well as the command prompt. So now let us say it is not 268.48, but rather let us say it's at 250. So now you can see we are overriding the dimension with a text that is fit into. So this is how your mtext and text command is going to vary. So next we'll look into the angle command. So towards that, let's construct a chamfered element. So for chamfering again we'll call the rectangle command, but with the input specified for chamfer. Let us say the chamfer distances of say 10 mm on both the sides, both the lines. So now facing the rectangle here, you can see this 10 mm and 10 mm is on this angle here. So let us call the dimension linear again to specify the variation here. So now let's specify that like we have to measure this two chamfer distances. Now we can see that for these 2 points, the default alignment has been now taken as vertical. So now in order to override it, if you click on horizontal, you can see now we are getting the horizontal one. But suppose if you want to change the angle of the dimension text, then we can call in the angle command, and now we can specify the angle. Suppose if the text has to be rotated by 90 degrees, now you can see in the same horizontal command, the text alone has been overridden in this way. So by this we can realign the dimension text alone so that it will improve the readability of your text. So this is the aligned angle way of doing it. So now let us say go back to it and specify as a 0 element here. So this is one way of doing it. Suppose if you want to measure not the horizontal and not the vertical one, but rather the rotated variation, that is we want to measure this dimension, then that is affected by selecting these 2 points and then specify the rotated linear dimension option. So here again the angle of dimension text is asked for, so we can specify say 45 degrees. Now we can see that the rotated angle for this linear dimension is positioned here. But do recollect that one of our basic rules of dimension is that the dimensions should never cross each other. So suppose if you are arrived at this stage, then you can alternate the text by dragging the handles so that you can alternate the position, or you can vary the distance accordingly. So this is important, like how you position your dimension and select them. So this is a quick overview of the dimension linear command that we have seen. So towards that, the second mode of selection was the selection of the object. So we'll also look into that. So we'll invoke the dimension linear, and for selecting of object, you can either right click or press in enter. So once you do that, it will look for the objects that need to be selected. Suppose if you want a quick dimension this object, then click on this. So now we can the automatic first and second extension point origin are specified based on the type of object. Suppose this is a line or an arc, that is in this case. So the line or arc endpoints are used as the origin for the extension line. So the extension lines are always offset from the endpoints by the distance that we will specify in the offset from origin in the lines and arrow. So that we'll look in the next style when we are looking at the dimension style dialog boxes. But likewise, if the dimension linear and select object is done, then suppose if for a not for dimension linear, but this object selection is done for a circle, then the diameter endpoints are used as the origins of the extension line. When the point used to select the circle is actually close to the north or south of the quadrant point of the circle, then a horizontal dimension is drawn. When suppose the point is used to select the circle is the east or west, then a vertical dimension is drawn. So this north-west eastern quadrant refers to the architecture way of approaching this. So that you can try it on your own and see how this dimension linear command is overridden for a circular element. Likewise, for polylines or other objects that can be exploded or that is constituted by single individual elements, then only the individual line and arc segments will be dimensioned. So this is about the selecting the objects for dimension linear through the select object command. So next, in this line, we also have instead of dimension linear, that we can invoke the dimension aligned command to do the same objective that we have seen earlier with dimension linear. So here again, when you invoke the additional menu, you can see that we will get the mtext text and angle command for this dimension aligned. So this is a particular case set of the dimension linear command. So now going next for a circular element, the radius or a diameter. So towards this, let us select a circle here and a circle here. These are two of different arbitrary dimensions. To dimension the radius first, we'll call for dimension radius. So once this is done, it will ask for the selecting the arc or the circle. So if you select this circle, you can see that the center point is directly placed, and then based on our positioning of in this case the second point, so then you can position your dimension of the radius. So you can see that the dimension radius command is prefixed by the R symbol that denotes that it is the radius. So also you can see that when the 90-degree position is exceeded, the text alignment also varies. So this is one feature of it, and also by placing your positioning the point either internally or externally, you can control this positioning of the text inside here. So once that's done, you can see if the dimension is placed outside, the arrow is pointed inwards, whereas if the dimension is placed inwards, the arrow is placed outside. So this is for the dimension of the radius thing. So next, suppose if we are drawing an arc here, suppose let's say we'll call for a fillet of these two surfaces, specifying the radius as say 8 mm and the trim is on. So in this case, when you specify the radius for dimension, you can see, suppose if we position it internally, there's an extension that is drawn so as to continue the arc position. But remember that this is not a part of the drawing, but it's a part of your extension line. This is your extension line that is placed to position. But this is kind of misleading in a drawing, so always ensure that this is placed in a relatively readable position that does not confuse the originating point of this drawing. So this is about the dimension radius command, and subsequently you have the dimension dia command for the dimension of the diameters. So here again the input requirement is an arc or circle. You can click on that. So likewise you can position it either inwards or outwards, and you can see there are two opposing arrowheads to specify the diameter, and this will include the dia symbol as a prefix. So this is about the dimension dia command. So also we have one more command, because in this case, suppose if you want to highlight the center point, then you can call for the command called as dimension CEN. So this is the dimension CENT, dimension center. So once this is done, center mark is placed within the circle. So this will be easy for positioning your datum references or datum points if called for from this circular element. This we'll see in the next session in tolerancy. So this is your dimension center command. Next, likewise, we also have the dimension angular command. So this is used for the angular dimensions between the two lines or 3 points in an arc. So towards this, let us construct an arc to visualize. So to start off with, we'll start with the center point of the arc and the start point and the end point like this. So for each of it, we'll remove these dimensions. So now you can see that we have drawn an arc. So to dimension this arc, we have to use this dimension angular command. We'll go with the first method, that is selecting of the arc or the circle or line. So do remember this angular command can also be used for the line that we have seen earlier. But now we'll focus on only arc and circle. So selecting the circle, you can see that the endpoints are directly considered and the angular between those endpoints is considered for this angle. So this is typically the angle between the start and the end point of this arc. So likewise, when before specifying the third point on the drop down menu or in the command prompt, you can see the additional options mtext, text, angle are available. So this is the usage of your dimension angular point. So one more option what we have here is the quadrant command. This is a very useful tooltip in the dimension angular command. If you want to specify this angle outside of the extension line limits. So let us quickly see this with an example here, and specifically in a linear line command to showcase this. Suppose if we have an angular component here and you want to specify the angular dimension between these two lines. Okay, so here we can specify this. Suppose if we want to position this in a different quadrant, then we can specify which quadrant you have to position it. So based on this, we can extend the dimension line that is required. That is, with this dimension, we are positioning this outside the dimension line extent. But this is not possible if we do not specify the dimension line of it. You can see here, when we move on to here, it switches to the next dimension. Right. So this is where you can use this angular dimension in the quadrant segment to retain the same dimension intention but position the dimension text elsewhere outside the defined quadrant. So this is the use of the dimension angular command. So next what we are going to see is the baseline dimension. So baseline dimension, what it does is it refers to a base dimension, and then the other dimensions that we keep on selecting will be continued from that base extension line. So this we'll look at with one example. So let us plot a line. So consider step kind of an object. Okay. So now let us dimension every one of the steps from this base reference line. Towards this, first we require to have the initial dimension set in place by the linear or aligned or angular dimension. So we'll go with this the dimension linear command. So once that's done and placed, now you can set in the next dimension with this as the baseline by dimension base command. So once the dimension is already available, AutoCAD considers the previous set dimension for reference. So the previous dimension is already referred to and that extension line is already taken. Now we can put in the second point, followed which the third point can be placed. So and so on and so forth. So this is the application of the dimension baseline. So what here we are doing is the baseline dimensions are going to be multiple dimensions measured from the same baseline. This is going to be the baseline. So continued dimensions are always referred from this baseline and measured from this end to end. So always the prerequisite for this is to have a linear, aligned or an angular dimension that is already in place. So suppose in this current session of drawing, if there is no dimension was created, then you have to specify the base dimension that to be selected and then perform upon. But when the previous dimension is linear, as in our case, then from the next point it directly considers and places it. So based on your requirement, you have to collect. So the main concern here is the base dimension is going to change based on the first dimension that you have taken. Suppose if you have dimensioned this segment and then continue the dimension baseline, then from this either this way or this way your dimension will go in. So it all depends on the first point of dimension that you specify for the previous dimension command. So this is your dimension baseline linear command. So along with it, we also have an extension to this. We have this. So here when we prompt it, we can select a different command. So suppose if we select this as the baseline, we can see you can modify the base reference line. So this is one way of doing the dimension. Now we can see that the dimensions are selected if we go in the opposite direction. Select the same dimension baseline. If you have a base dimension as an angular dimension, then you can continue with this similar to your linear line. So let us follow one popular AutoCAD example that you might find, that is uh, measuring the slots that are placed along a arcual length. Okay, so let us just quickly draw it out. So let us draw some element like this and then draw on an arc. So the center point of the arc is here and start point and the end point. Okay, so let us use the extend command. And this, right? So now let us place a circular element here and let us use this array path command to mimic this element in this array and say 4 elements with some arbitrary distance like this, so that it's equally spaced, right? So with this, let's look for the angular dimension. So let us go back to the angular dimension command. So here, if we want to measure the angle between this circle and this circle along this arc length, then by default when you select these two circles, it selects this point and hence you can't measure the angle of it. So towards this is where we use the vertex command. So also recollect that you can quickly recall the previous command by clicking on enter, so it directly takes the previous command. So now into this, let us specify, press enter again to select the vertex. So now remember the vertexes requires 3 points for measurement. First is the measuring center point for that vertex and then the start and the end point of the measurement. So for this, in order to measure the angle between these two, the vertex point is going to be here, and then the first angle endpoint is this center and second angle endpoint is this. So now you get the angle of it. When you go for dimension baseline, so you can see that the previous angular command has been taken here, and now we can continue your baseline dimension from here. So this is the use of dimension angular vertex for specifying an arcual element and also using the dimension baseline command to continue the angular dimensions. So next what we have is the dimension continue, wherein it's similar to this, but instead of taking the baseline, it continues from the originating dimension. So let us come back to this point dimension and let us dimension on this edge to differentiate between them. So let us use for the dimension continue option CO. So from this you can see it is referring to this point. Okay, so now let us start off with this. So let us put a dimension linear 1, the first dimension here, and then let us call the dimension continue. Now you can see the dimensions are continued from the previous endpoint, and that endpoint is considered as the start point here. So we'll go about for the same in dimension angular and see how it's positioned here. So let us position in this way to differentiate between this. So now going for dimension continue. Now you can see that this gets continued from this line. So this is how the dimension baseline and dimension continue is going to vary. Then again recollect like how we are going to give the dimension annotation onto the drawing. So it gives the designer as well as the inspector ways to analyze the key design. So the thing is, when you give out a baseline dimension, then it means that this surface, this feature is going to be of prime importance for them, and all other feature boundaries are referenced from this feature line only. So this is the information that you are trying to say in the dimension baseline command. Whereas in dimension continue command, what you are saying is the each and every dimension is going to be controlled, and hence whatever the endpoint is, it's also a critical dimension. So each and every facets of this feature needs to be controlled. So this is how differentiating between a baseline and a dimension continue modifies the pretext of measuring the feature at the end of the line. So you need to be very careful of how you give out the dimension. It's not on the ease, but rather how to measure it on the end of line or during inspection. So next we have the ordinate dimensions. So these ordinate dimensions will measure the horizontal or the vertical distance, that is the x or the y distance from an origin point. That is what we are seen as the datum. So this datum we'll look in the next week session, which during this tolerance part. The datum is something like a reference from which you have to start the measurements. So for example, if you are locating a hole or a search, so you refer to one such reference planes and then do it. So that is called as a datum. Suppose if in this diagram you see, if you want to ensure that the location of these features are have to be controlled, then we have to use this dimension ordinate features so that we eliminate errors by maintaining the accurate offsets of those features from the datum. So in order to call this function, we have the dimension ordinate DIMORD. So when prompted, it will ask for the feature location. So considering this feature, and we have to locate the center of this hole, then we can select this feature point. So once that's done, you can see that based on the movement of your cursor, it changes for the x and y coordinates. So what it means that this point 270.54 is the x coordinate distance from the datum plane. So currently now the datum plane is considered as this the local UI. So from this point it is 260, whereas on the y-axis it is 386.17. So this is done with reference to this plane. So by positioning it, you can vary the mark the datum plane. So if you do not want to do it, and if you want to make the datum plane fix the datum surface, that is you want the datum plane surface to lie on these two axes, then you have to move your global reference here to here. So that can be done by modifying the coordinate system reference point, that is the user coordinate system. So in order to do that, you can invoke that by the UCS command, user coordinate system. So now it asks for switching of those points. So now as ortho mode is on, we'll turn it off. Now we can see that the datum is extrapolated from its original surface, and now you can specify the new origin of this datum. So let us position this at this corner edge so that the x and y axes are aligned with these two surfaces. So once we fix it, then it also asks for the rotation or the intercept of the x-axis. So we can click on enter or select the point on the same line to retain it. Now you can see that this user coordinate, you can see this the coordinate system has disappeared from here and has moved on to here. So typically if you refer some datum plane here, it will go in the negative direction because this is on this quadrant. So now having said that, we have moved the UCS coordinate. Now let us call the dimension ordinate command again and then position this. So now you can see that you have the x and y feature modified and it references with this plane. So by this dimension coordinate, you can dimension the critical features with reference to the datum plane so that they can be controlled during the production or machining process. So you can see that this is a part of a leader line. So the leaders will look into the next part. But here as in leaders, you can see that there is this jogged portion of this leader. So in order to eliminate this, that is if you want to have it in a straight line, then you can invoke the ortho mode F8 so that it is perfectly 90 degrees to the point. So this is your X and Y datum plane. But right now we have just picked a feature point and then selected. So alternatively, what you can do is after selecting the feature location, instead of specifying the end point of the leader, you can specify it, override it as an X datum or a Y datum. If suppose we select the X datum, only the X datum point will listed and you can position it accordingly. So if you want to position in this way, and then you can change the angle or the text content using these commands. And if you want to go for the Y datum, then you can go for this. So this is the dimension ordinate feature. So next we look at the dimensioning of an arc length. So earlier what we had seen was the dimensioning of the arc end-to-end reference point using the command dimension angular. So with dimension angular, we measure the end-to-end angular dimension between those 2 points. Now we'll measure the arcual length. So towards this, let's just construct an arc. So considering this as the start point and the center point as here. So consider this as the arcual element. So then invoke the dimension arc command DIM-ARC. So now once you select this arc and then position this extension line, you can get the arcual length. That is also highlighted by this symbol that highlights that it's an arc length. Whereas if you invoke the dimension angular command and if you select the same arc and such, it denotes the angle between the start and end points of this arc. So this is how you can use the variations of this command to dimension your component. So based on the requirement, suppose this feature is required to control the arcual length of the feature, then you can reference it using this dimension arc. Or if the endpoints are of critical and they have to maintain at a certain angle, then use a dimension angular command. Again reiterating, whatever critical dimensions that you want to measure or control is what we have to dimension on the drawing. So far we have seen the major dimensioning techniques. So let us quickly review them. So in this dimension tab, we have looked into the linear dimension, align dimension, arc length, and also ordinate. And we have seen dimensioning the radius component, diameter, and angular. Also with this baseline type of dimension and continuous dimension. So now let us look into slight variation of this dimension to modify the existing dimension to suit our requirement. That is, so first we'll start off with jog dimension. So there we have a jog radius or a jog linear. So this is like modifying the existing dimension to suit to the current view that we have. So that is your jog dimension. Then controlling the spacing between the various dimensions, that is done using dimension space. And suppose if the dimension runs through the object, if you remember our rule is dimension should not pass through the object and it should not cross each other. But if there are some cases when the line actually crosses through, then you can use this dimension break to eliminate any crossing with the object. You introduce a break to the dimension extension line. So that is the function of this. And then we have this jog linear dimension. Then also next additional thing is like for inserting any inspection dimension. So we'll look into these sections now. So first to start off with the jog to radius dimension. So jog radius means that it will measure the radius of the selected object and displays the dimension text with a radius symbol in front of it, just like our normal radius limit. But the difference is that we can alternate the origin point of the dimension line to any specific location. So this is going to be used when, suppose if you are going to dimension this object, wherein my paper space is just going to be here, that is the center width out of the scope of this layout. Then in those cases, if it's difficult to dimension the part, then we can use this jog radius dimension, so that the origin point, instead of here, the reference is shifted to a convenient location. So towards this, so we use this dimension jog command. So on selecting the R for the circle, it prompts for the center location override. That is, we specify the new center. So suppose this dimension needs to be referred from this point, then you can see from this point, now the radius goes for the second. So it asks for the dimension line location. Where should that dimension, the text should get located. So in this case, like say if it goes on 3, the next requirement is to specify the jog location where this jog should go in. So suppose if we are pressing it here, now we can see that this object is referred to from this point. So this is your jog radius dimension, used in cases where the feature is extraordinarily large and does not, its origin is not covered within the given layout. Then you can use this jog radius dimension to convey that factor that it is a large dimension object. So likewise, we also have the dimension jog for the linear segment. That is, suppose consider a very large line. Let us look into this example here. See, the total distance here is around 150-160 mm, okay, but suppose these are in meters, okay. So in that case, or the scale is very large, so in that case we cannot dimension those parts. So what we can do is, we can create a jog linear dimension, jog linear line, so that to jog an existing dimension. That means that, see, this dimension, let us say this is of large units, okay. So in that case, if I'm introducing a jog, I'm clicking the dimension line. Now next specifying the jog location. So once this is done, you can see that it is modified. So it means that there is on the drawing, the physical distance might be say only 5 centimeter, but rather here it denotes a longer range. Suppose it is like say 5000 meters, okay. So this is how the true distance between this dimension length is a different value, but we are overriding that with using this jog linear dimension command. So this is to use for specifying unmeasurable quantity on the physical drawing. So alternatively, we can also remove a jog line. So you can invoke the jog dimension line. So on the dynamic option, you can see this, there's a remove option here. So once you click on a previously jogged line, you can remove this jog command. So this is an adding or deleting the jog line. And suppose if we want to modify this location of the jog, you can select this and then use this, the dynamic input object, the grips, so that you can modify the location using this grips. So this is the optimizing the jog location. So this is about the jog linear. So likewise, you can also invoke jog angular command. So dimension jog angular. Now this introduce the angle of this jog line. So currently 45. This you can override. So this jogging is used for a linear or the radius elements. So this is about jog lines. So next we look into the dimension space to improve the readability of the text. So consider this part. You can see the when we are demonstrating the baseline dimension, the continued dimension, you can see that that's an overlay of the text here, and it hampers the readability because here the text and the arrowhead are interfering with each other. So typically what we will be doing is, we will be selecting this and using this grid to modify the location. So instead of that, we can use this dimension space command to alter the dimension spacing. So for that, the first requirement is to select the base dimension. So once that base dimension is selected, next requirement is select the other dimension to space with reference to the base dimension. So now you can select all others. So upon selecting it, click on enter. So now it asks for a spacing value for this dimension line or an auto command. So by default you have this auto command selected. So when you go with this auto command by clicking on enter, you can see that the dimension lines are equally spaced, and this height of the spacing is determined based on the height of the text of this line. So based on this text height specified in this dimension style, that will get multiplied twice, so that the resulting height between these two lines is the twice the height of this dimension style. So this is your dimension spacing. So alternatively, you can also space by your user specific value. So suppose if we want to keep this spacing to say 5 units, then it will get aligned. So I think the values are already in 5 units. Yeah, that's it, because in dimension style height, suppose if you double click it, you can see this, the dimension height is 2.5, so twice that is 5. So that is why we already have got the same dimension height. So let us go ahead and say a differential height of say 8 now. So now you can see that the spacing has been increased to 8. So this dimension space command can be used extensively to make sure the dimensions are very well in readability, because at the end of the day, the production specialist and the inspection specialist should be able to easily understand the dimensions and drawing intention. So this is the dimension of the spacing of the dimension element. So next what we have is the breaking of the dimensions. So this dimension command, the break command, will break the dimension or the extension lines whenever they intersect any object or other dimension. So supposing we have a line, that passes through this object, something like this. Okay. So in this case, so this overrides or rule of dimension that this dimension should not pass through any object. So in this case, we can invoke this dimension break command. So with this dimension break command, we have to select the dimension which passes through this object, and then select the object to break the dimension. So this is the object for the dimension break to happen. So once selected, you can select this object and see, because this was the selected line, and you can see that there is a break introduced between this line. And likewise, when you selected this object, this has been introduced as a break. So this is what, okay, so there is one more line here. So let us remove this. Okay, so that was a part of our object. Yeah, so now it's very clear now. So what happened is, the dimension extension line has introduced a break so that it does not interfere with this object. So this is your dimension break command. So suppose if there is no object and this object has been removed from its place, so let us move this object here. Now you can see that the break command automatically closes it. So this is the auto break dimension break command. So inside this dimension break, we have a facility to add or remove the break line and also multiple intersection of the dimension break commands. So this command can be extensively used for dimension line as well as leader objects, and it can be applied to the linear dimensions, either aligned or rotated, or angular dimensions, all the radial dimensions, that is radius, diameter, jogged commands, and arc length dimensions, ordinate dimensions, and then also applies to multi-leaders, that is in case of the straight lines, or Ligus leaders that goes for straight or spline lines kind of thing. So this is what the usage of your break command. So dimension break. So you can see as this dimension is already associated with the dimension break command, whenever there's a object in its place, the dimension gets break accordingly. So next what we have is the specification of the inspection dimension. So inspection dimensions vary from our normal dimensions by specifying how frequently the manufactured parts should be checked to ensure that the dimension value and the tolerances of the part are going to be within the range. So instead of adding a separate note, that the number of frequency of inspection can also be included in the dimension line itself. So these are related to tolerancing. We'll look into the next part, but right now let us use the inspection dimension command to specify how frequently the given dimension has to be measured. So that is invoked by the command dimension inspect. So this opens a dialog box that has the following options. The first is to select the dimension that wherein the inspection details have to be inserted. So once done, then what is the shape of the box that is denoted? So either the round or angular or an enclosure or none. So and then what label needs to be specified. Suppose if we have different numbers of the inspection dimensions, then you can label each and every one of the dimensions for quick reference. Then you also specify what is the inspection rate for that dimension unit. Suppose if the inspection rate is 50%, then it means that that given dimension should be measured 50% of all the components produced. That is, if you are producing 100 components, for 50 of those samples, you have to measure this dimension. So this is what information is conveyed through this dimension line. So towards this, let us select this dimension. Suppose we are selecting this one and click on enter. Now it prompts back this dialog box, and let us go with the same the frame for this inspection dimension as round, and we'll introduce a label, say this is label A and with an inspection rate of 50. So the dimension text is replaced with this dimension inspection frame with the label and the inspection rate. So this is your inspection dimension. So next we'll see now the other part of annotation, that is the leader lines. So in leader lines, what is the typical type of leader what we've already used is the radius dimension. Okay, so this is a typical representation wherein this leader means that you are extending the feature reference line and then specifying an annotation text to it. So that is going to be your leader. Suppose you are saying that there are going to be, okay, so it can be well explained here. So you want to explain that this radius hole is of 4 times in number. 4 numbers of these holes are positioned along a pitch circle diameter of so and so. So that information, that annotation text is positioned as a leader. So let's see how it is invoked. So you can invoke the command by the lead line. So that is called for the leader. So once it's done, the first requirement is to specify the start of the leader point. So suppose we are referring to this hole. So consider click on here. Our next requirement is to specify the next point of that leader. So once that point is specified, and then it further asks for the next point, or when you click down the downward button, you can see what are the other options that are used for the specification of the annotation or the format. So when you click on annotation, then it will ask for the first line of the annotation text. That is, you start typing in the text that you want to mention. So suppose you say like 4 times of hold. So the next line of annotation is nothing. So once you click on that, then you can see that the leader line has been created with this landing. Landing means the leader has been extended below this line. So this is how you position your leaders. So going into the other commands of leader, will invoke the same way. The first point, then second. Alternatively, you can keep on extending the number of points that you have based on your settings. So next, clicking annotation. Instead of specifying the text, you can also look for the other options of the text annotation. So when you click on that, you get these many options. That is, you can either specify the tolerance that we'll see in the next session, or you can copy already a text that is available elsewhere and place it onto here, or refer to any blocks that are available, or no text, or use the M text. So by default, we will be having the M text. Suppose if you use the copy command, so it will ask text object to get copied. So now when we click on this, that text object is copied here. So this is what your leader line goes in. So as you can see, the leader is an extension of the specification. So it's an object. This leader is going to be an object that comprises of the arrowhead and then attached to different splines or the straight line segments. So in certain cases, when we have only a short horizontal line, that's the hook line or the landing, so then it also connects the leader frame as the leader line. So this is about the leader, and next is we also have the format of this leader. So when you specify the leader after specification of the first and the next point, in here you can specify how is going to be your format of the leader line. So whether it's going to be a straight line or a spline, and then how the arrowheads are going to be denoted. So suppose if you select the spline lines, so then you can see based on these points selected, you can opt for a spline definition. So clicking on enter twice completes the leader line segment. So you can insert one more line here and go for a straight line, but again we can specify how the arrow should be, whether it's there or not. So if you specify none, you do not have an arrow. So you can see that this here in this leader we have specified the format as none, so we do not have an arrowhead here. So this is how you work around the leader line. So next option what we have is a queue leader. So this queue leader command is used to quickly create leaders and also leader annotation without specifying each and every time the annotation or the text command and all. So when we click on quick leader, it again asks for the specific point, the next point, and placing it. So once it's done, it will ask for the prompt that is pre-entered here. So now it is asking for the text width prompt. So suppose if your text width is a requirement is 1, and next what type of annotation it is. So by default it's M text. So I'm using the same command and then closing it out. So what we need to say here is we use only those properties that we are going to use in the leader in the queue leader command. So by queue leader command, we can specify the settings that is available. That is, in the setting you can see that we have 3 tabs, one for the annotation, one for the leader line and arrow, and also the attachment. So going by one, so in annotation type, we can predefine what is the repetitive annotation that we are going to use. An M text or a copy of an object, tolerance or block reference that we see in the leader. So based on this, when selecting that, only that command will be repeated for all the leaders that we are using this queue leader command. For this M text, what are the M text options? So what should be done. So whether it should prompt for the width of the text, and then should it always be left justified whatever the location is, and also it has to be frame has to be placed around the multi-line text annotation. So suppose if you are referencing a dimension, then you can use this. Then again, whether the annotation should be reused. So then if we click on that, whenever we specify the leader, then after all this annotation properties that we use will get replicated. So suppose if you go for a tolerance block, then this goes off. This is applying only for the M text. And so this is how you can, override the leader settings for the repetitive command that you have to fasten your leader line dimensioning option. So next, in leader lines and arrows, you specify what type of line segment you are going to use, either a straight or spline, and then how many points should be listed, because the original leader line has an indefinite number of points. That is, as you can see here in this example, you can keep on specifying the points, but rather you can also control how many points should be having, the first point, the second, and third. So once you click on that, the number of selection points requirement terminates, and then it goes for the input command of this annotation. So next, you can control what type of arrowhead are you going to use, and next, what is the angle constraint to it. So the first and second segment to constrain it. As we looked into the dimensional technique rule, so we have to follow 30 degree, 60 degree, 45 degree rule. So based on this, we can control the angle of the leader that is going to be placed. So finally, the attachment will specify how the text is positioned. That is, in case the text is on the left side or on the right side, whether on middle of top line or middle of the bottom line. So how this is all done, and then also a requirement to whether underline the bottom line. So once the options are specified in this Q leader menu, the same can be replicated fastly to all other commands that we have. So this is about the Q leader. So next, what we have is a multi-leader option. So multi-leader is invoked by mlead command, that is the multi-leader. So we'll quickly go into the description of it to understand it. So what we're doing is, once the multi-leader command is selected, it has two prompts to either to specify the arrowhead position first or the leader landing first. So if you specify the arrowhead first, you can see that the pointer has modified, and now it requires to specify the leader head position. So we will start off with this, and next it asks for the leader landing position. So once that is done, it directly goes for the text option. So until this point, it is similar to a single leader point. But how it can be used is that in the annotate tab, you have this leader segments, and here you have additional option for this multiple leader. So here you can see you can add an additional leader to an existing multi-leader object. So you can select this, the add leader object, and now you have to select the base multi-leader line. So this is our multi-leader, because this will not get selected to a normal leader line. You cannot select this, but whereas if you select this multi-leader line, this gets enabled. Now you can see that from the landing point, and another leader line is extended, and so now you can keep on replicating that requirement line repeatedly, and then terminate it by clicking on enter. So what it does is, for the same annotation text, we are referring to multiple objects using the same leader line. So this is your multi-leader command, the usage of the multi-leader command. So alternatively, we also have the remove leader option, so that you can remove the leaders that is not required to be done. So alternatively, that is, we can also cycle between the add leaders and remove leaders. So when you click on the enter, you can remove the leader specification. So this is about the multi-leader line, and so adding to this multi-leader, you can also look for the options. So in this options, you can specify what are the leader type, how the leader landing should be, and then what is the content type, the number of points for the leader, what is going to be the first angle and second angle. So if you specify the leader type, you can select whether it's a straight line or spline line. And in leader landing means should you continue this extension, delete this. So that is your leader landing. And next, the content type, whether it's going to be mtext or block. And then what are the maximum number of points? Now it is 2. You can modify it based on the requirements, and then specify the first and the second angle of your placement. So this is the dynamic input settings for your multi-leader line. So this is about single leader, few leader, and multi-leader points. So in this leader segment, we also have an option to align the leader line. Suppose, because you can see there are 3 different leaders here, single leaders, we can align it using this the align option. So you can select this line and then select the multi-leader option and then click on enter. So now it will ask for the reference to align. So we can either make the leader lines parallel, or we can specify the spacing or use the current spacing. So suppose if we specify this point, now we have distributed it based on the selected point reference. So likewise, if we make the leader segment parallel based on the selection, you can do. This is an extension of, but suppose if you are going for a different leader lines for single command cell. So let us ignore this and let us consider individual leader lines but called in the multi-leader mode. So we are invoking the M leader command cell, leader 1, okay. So consider this example. Now you can use this align command to select these multi-leaders to view the difference. So now if we make this segment as parallel, so once you click on the screen with left mouse button, you can see that the leaders has been positioned parallel to each other. So the other option is to specify the spacing between them. Suppose if we specify the spacing as 8 and then click on the screen again. So now we can see that the position with respect to the first leader line is specified, and then you can specify the direction of the spacing. So now the spacing between the text is controlled using this align command. So this is how you again control the readability of the text. Next we have one more command, which is collect the leader lines, but that is getting applicated onto the block segment. So that we look separately in the upcoming session. Before going to the dimension options, we have one more thing called as an associative dimension. So if you can recollect the association property that we had used in array, in similar way it applies here. So it means that the dimension gets associated to the geometric objects. So this will be useful when we are going to scale any object or not. So you can see how this associativity is going to vary. So let us quickly draw one rectangle. Okay. So here we measure the linear dimension. and then also we will measure the dimension aligned. Okay, so now let's use the dimension break command to break this. Okay, so now we have this dimension break. Now let us use the scale command to scale this object from this point and say we are scaling to this. So now you can see that the dimension has increased here accordingly based on the size. So it means that the dimension has been associated based on the point. But as the reference point alignment is strong, so let us just remove that for consideration. But you can see that now the dimension is in the associated node. That is, whenever the scale is increased, it has been associatedly the dimension is automatically oriented to the position. So this is called by the dimension associate command. So when the value is set to 2, then it means that it is an associated dimension. So now when we override the system variable to 1, then it means that we are making it to be non-associative. Okay, so now let us redo this dimension to verify the non-associative dimension. So towards that, we have to update this dimension associative command to 1, and then we have to reassign this dimension because earlier it had called for the associative dimension. So now scaling it out. So now you can see that the dimensions are not associated with the subject. So always remember that as it's a system variable, if you do not update this, then it would not reflect in the drawing. So only after updating of the system variables, the properties will get updated. So this is the about the dimension associating. So in certain cases, like we have to change or modify the dimensions. So what we are seeing here. So if suppose the dimension association is already mentioned in the previous one, and we do not have any new dimensions, then in this case what we can use is we can use the dimension reassociate feature and then select this object. Okay, so now what we are doing is we are reassociating this dimension to this object. So this is a step-by-step process for dimensioning the thing. But anyway, we have to make sure that the system properties to get updated to the required association or required properties to it. So whenever we use this dimension reassociate option, we see that there's an X mark coming to it. So when moving that associate market, now it gets associated with this object. So now when we look into the association command, you can see that it's now updated to 2, and hence we had reassociated this. So whenever you again scale down or up, now as the properties of this association has got updated. So this is your associative dimension. So next we look into the modification of the dimension properties, leader properties, and editing the dimension line. The first thing is the dimension edit command used to edit the type of dimension. So here when you click on the dimension edit, you get 4 type of options. That is, you either come to the home, requirement of new dimension position, rotate or oblique. So here when you click on home and then select this object, click on enter, so it moves the rotated dimension back to its default position. So suppose if it's this position. Okay, so now we use the dimension edit command and click on home. You can see now the dimension text gets realigned to its original home position of it. So this is your home thing, and suppose if you want to modify the dimension text, then you can go for new command and select the object and specify the requirement. So now then select the object where it has to get overridden. So now we can see that the existing dimension text has been updated using the in-place text editor. So next option what we have in dimension edit is the rotate option. So we can rotate the text angle by the requirement. So you specify the angle and then specify the dimension of this. Now you can update this. So if you want to re-update to the original dimension, then you can specify the angle of 0. So now it will get realigned to its original text. Next we have the, in dimension we have the oblique option. So that is used to adjust the oblique angle of the extension line for linear dimensions. So this will be useful for any dimensions that are already conflicting with other features of the drawing. So this either this oblique feature can be called upon, or you can use this feature so that it refers to the same angle, but instead of overriding onto it or using a break command, you can change the oblique angle of this text so that you get a better readability. So this is about the dimension edit option. So next what we can see now is the modification of the dimension style. So that can be invoked by the dimension style command. So here, as in the text style modification, we have a similar window wherein you can specify the dimension style, add or delete the existing style. So the current style is ISO 2.5. So you can modify it by specifying the modify tab, and into it you have the several tabs for modifying the dimension segment. The first one is the specification of the lines. So whatever changes you do to the various segments here can be viewed upon in this preview. So first off, in the dimension line segment, you can modify it by reference to the block for color, line type and line width that we look in layers in the next sections. Then you have an option to extend the line behind the text and then specify what is the baseline spacing between this. So suppose if we want to have a 5 unit, then you can click on it and then suppress the dimension lines. That you can see here by this editing here. So it means that what part of this segment, the dimension line 1 or 2, controls this extension line. So this is one thing. So next we'll look into the extension line control. So here we can suppress them or modify them based on this colors, and then again extension beyond this and offset commands are also available. So this all controls the lines, that is both the dimension line as well as the extension line. So next we have the symbols and arrows. So where we can control the arrowheads, we can have variation between the first arrowhead, the second arrowhead, and also with respect to the leader, and specification of the arrow size and how the center marks to be positioned in case of in circles or so, whether it should be a mark or a line, and what is the dimension of it, and then how this dimension break should be positioned, what should be the distance of the dimension break, the gap, and next in case of arc length symbol, whether it should be preceding the dimension text or above the dimension text, and in case of radius jog dimension, what is the jog angle. Okay, so next is in case of linear jog dimension, what should be the jog height factor. If you recollect the symbol, what should be that height factor, the text height factor for that. So all this information is covered in this symbols and arrow command. So next is text command. So in this text, you specify the text height, the text color settings, and then how the text is to be placed. And if you also select this draw frame around text, you can use for referencing this so that these are reference text. And then the text placement, whether it should be centered or above or outside, okay, or so whatever standard you require to, you can put in, and the position of this horizontal lines, where it should be. You can have a view at this preview here to see how it is going to reflect to you. And next again offset, what is the offset from the dimension line, the separation length, and then what is the text alignment, whether it should get aligned with the dimension line itself or it should be in the horizontal position, okay, or ISO standards. So this will all get controlled for particularly the leader lines or aligned text. So this represents the requirement that you want to do. And next in the fit option, whether how to fit this dimension text into it. So whether to make the best fit, or you first fit the arrows, or you position the text, or both the text and arrows, or always keep text between the extension lines. So by this you can control the positioning of the text and override the existing setup. And then again it goes for the text placement where it should be, okay, in case of leader lines, and then the scaling of the dimension features, and then fine tuning, that is when selecting the using the manual selection of the text position or the dimension line extension line commands. So this is the fitment of this line. Then specifying the primary unit for this dimension lines. For linear dimension, it's in decimal system with this precision. And then what is the separation command? So suppose if you do not want to have a comma but rather a point command, then you can verify it here. Then how the dimensions should get rounded off, and are there any predefined prefix or suffixes to the command, and then the scale and requirement for suppression of zero in the leading or the trailing edges. You can explore each and every one of it based on the requirement. And again specification of the angular dimensions. So next, specification of alternate units if there is a requirement in that case. So it means that for the same dimension you also mention it like mm or inches, or those two kind of alternate units you can specify using this. And then finally this tolerance segment where you can indicate the tolerances. This we'll look into the next segment, but predominantly we'll look into like unilateral, bilateral tolerances. So that you can go here, specify it, and specify the upper lower values so that it will get included in it. So the thing is, once you update this, all the commands will get updated simultaneously. So the tolerancing was specified, so all this was updated, and the angle, the specification all got updated here. But rather if you want to just apply to an individual thing, then you can double click on this, or you can select this extend the dimension line, and then go for the quick properties to modify the individual segments. Okay, so instead of doing for a global level, so rather one thing is quick properties, or then going for the properties tab. Here you can modify for this specific dimension alone. You can specify the dimension positioning lines and all those things. So this here you get all the options that you have seen in the dimension style command, but this will get applicated only to that specified dimension. So suppose if you have different tolerancing option requirement for different things, then you can use this individual properties menu to update this. So this is about the dimension style command. So next, so in single leader we had observed that using the setting commands in the dynamic input we can update the options. So in multi-leader we'll see what are the style options that is available. So the initial style manager is similar to what we had in text and dimension style. So once you go on to this modified style, you have the leader format, the leader structure, and the content within it. So here again it's similar to the single leader thing. So you can specify what is the arrowhead, what is the break size, and then in leader structure how many leader points and all the things. So this is like the overall global settings to this multi-leader. And in content again, like what is the default requirement for that multi-leader, and in case if you are going to go for a default text, that you can specify here. And what is the text style, the text color, justification of it, the leader position, all can be control with this style command of this multi-leader. So in case if we go for a block, that will look into separate, but we can see that the leader option, multi-leader option get updated accordingly. So this is about the modifying the dimension settings, the leader settings, and particularly the multi-leader settings. So this concludes the dimension segments that we have seen. So we have seen a lot of dimensioning parameters. We have looked into linear dimensions. We have looked into angular. Then specific commands like jog dimensions. Then modifying the dimension space, breaking the dimension space, and then looking into leaders, multi-leaders, few leaders, that is quick leaders, and then modifying the settings all. So you can explore each and every one of it and look into the alignment of each and every segment. So how modifying the options can improve the readability of the text. So do explore each and every one of it for different diagrams, different drafting requirements, and then update your learnings. So thank you. Welcome back to week 7 of this AutoCAD course, and as a continuation from the previous week, we'll focus on the tolerancing techniques that are applied in the geometric dimensioning and tolerancing. So these 2 weeks, that is previous and this week, we're focusing on the quality part of the drawing, which will ensure that the product function stays good as per the requirement from the production line till inspection and the final application. So what is tolerancing? So just have a look at these 2 images. So the top one is a unique painting that is drawn by Mr. Vincent van Gogh, that is the Starry Night. It's unique because there is only one that exists of this kind. Whereas in below, you can see this is a snap from a Logitech mouse that has some standard dimensions that is going to. But the below image, that is the mouse, is a mass-produced object. That is, so many millions of mouse has been produced and consumed, whereas only one artistic painting has been done. So when we go for mass production, how to ensure that the product stays true to its function? So that's where your tolerancing kicks in. So in this real world, nothing is going to be absolute or perfect. There is going to be some amount of variations or differences in the component. So the variations will be determined by what manufacturing capability that you have, and what's the level of inspection, what's the quality of inspection that you have, and what's the capable dimension that it can measure through. So based on that, your tolerancing is going to get controlled. Also, you need to ensure interchangeability between the parts. So previously we have seen that this GD&T came onto scope during the World War II when heavy requirement for interchangeability is. So currently what interchangeability means that once you start using a product and suppose there's a defective part in that assembly, then you call for a replacement of that part, not the entire assembly, right? So that newly machined part that is going to be shipped from the production plant or the service center to you has to have a perfect fit to the existing assembly and still deliver the intended function. So that means all your products that you design and produce need to be interchanged to ensure the life cycle of the product gets continued. So this will ensure that it is suitable for mass production, and it will ensure repairability, and also will ensure commonization, that is, you use the standardized parts across different applications to keep your inventory levels to the lowest, inventory variations to the lowest. So putting all together, this tolerances means the allowed variation in the size and geometry of the part to ensure that you comply to the interchangeability and also ensure you have the sufficient manufacturing capability as well as inspection capability. So it's nothing but the difference between your maximum permissible size to the minimum permissible size. So this band is what you call as a tolerance. So typically if you design a component with a very low tolerance, then it calls for special manufacturing methods. That we'll see for in the upcoming slides. So when you call for special manufacturing methods, so it also increases your cost. So it means that higher the tolerance, lower the cost, and lower the tolerance, that is, the lower the bandwidth, that is, it is very precise, that goes your highest cost. Why? Because this cost involves the production cost, it involves the inspection cost, and also the rejection, that is the failure cost, because you have to own the failures. If suppose a product doesn't clear the given tolerance, it is rejected. That material has to be scrapped. So that is the cost of failure. So all this thing is embedded into your overall cost. So what does this tolerance denotes? It denotes the dimension variation. So thereby it conveys the design intent of the object. Next, it can also be denoted as a general note as a manufacturing method denoted to the entire page. So it's a general note stating that all the components produced in that page, in that drawing, has to comply to certain tolerance band. So it's a global tolerance that is performed to that page. Alternatively, you can also specify in the drawing title or in the tolerance block. It means it will apply to the entire component, entire drawings that are applied to it. So it's called a block tolerance. Because in a typical drawing, it might consist of different pages, each page focusing on separate components. Whereas if you apply to the title block, it means that you are applying to the entire drawing, all the components, the entire subsection, assembly, everything. So always keep in mind this tolerancing, the limits of tolerance should be finalized in the design stage itself, considering all the capabilities that you have. What is the manufacturing capability, what is the inspection capability, what is the life cycle of the component, how frequently you have to interchange or service the parts. All these factors need to be figured out in the design stage itself, and this tolerancing must be keyed in. It must not and must never be designated in the production stage. So this is the brief about the tolerance. So now moving forward, like how do you specify this tolerance? So let's go back to this. This is a normal circular element, that is the base element that we are considering, wherein we have to mention what is the base dimension and also means the tolerance. So by mentioning the tolerance, you could recollect it's the allowed variation in the size or the geometry of the part. It means that we need to know what is the maximum permissible size and what is the minimum permissible size. It means that we give a minimum boundary to it and also maximized boundary to it. So it means this circular shaft element can lie anywhere between these two surfaces. So how are we going to control it? How to denote it? There are two different methods by doing it. It means the plus or minus tolerances, or again the plus or minus tolerances specifying in a different methodology. So how do you do that? So first is we call this a bilateral tolerance. So in bilateral tolerance, you mean that your base dimension of 50 units dia of this circular shaft elements can vary between plus or minus 0.005. So if you consider this in mm, this means it's in 5 microns. So it means that this 50 mm dia shaft can vary on the upper side by 5 microns and on the lower side by 5 microns, and it is equally distributed across the base, and hence it's called as a equal bilateral tolerance. The next way is the unequal bilateral tolerance. That is, you specify two-sided tolerance, but they are not equal. So that is, on the upper side it can vary until 5 microns, and on the lower side it can vary until only 2 microns. So this is bilateral tolerance split into equal and unequal. So next what we have is unilateral tolerance. So unilateral tolerance means that you specify the tolerance or allow the variation in only one side, either in the maximum or in the minimum side. If it lies in the maximum side, it means it's a unilateral plus tolerance, whereas if it lies in the minimum side, it's called a unilateral minus tolerance. So moving on, the plus or minus tolerances can also be specified by limits. It means that you define the hard bounded variation with two specifications. So that is called two lines plus limit tolerance. It means that you directly denote what is the upper bound and the lower bound. So here the same unequal bilateral tolerance represented in the plus limits way means that the upper side it is 50 mm with 5 micron dia, and the lower side is 49.998, that is 2 microns for the lower side. So here you define the hard limits. So alternatively, you can also specify the minus limits. It means that the lower side is controlled first and then the higher side. This also we can see by specifying what is the material condition, that's the GD&T modifier that we'll look later. But this is how the minus limits are specified. If in case of minus limits, then the lower side will come on first and then the higher side. So this is the minus or plus limits. defined by two lines. Alternatively, they can also be defined by a single line, that is this same tolerance defined in a single line. It means the plus limits in a single line. Likewise, these minus limits specified in a single line considers this. So the same plus or minus tolerances can be defined in different manners. So moving forward, let's see how and what are the different key terms that will help us to designate between the tolerance sizes. So how to specify those tolerance sizes and how to determine what are the interactions between the components. In this figure, there are two major components. So one is your basic shaft, that is a typical shaft, and next you have a hole here. So these two are interacting or interfacing elements. So based on this, several dimensions have been defined. So let's look into one by one. The first thing is the size of the shaft or the size of the hole. So what are the various techniques or terms that are used in this definition of this size? So first is the nominal size. So nominal size means that is the general identification that is used to refer the shaft. It is expressed in a decimal system of dimensioning. So earlier you could see in the previous slide we had mentioned that the nominal size of the shaft was to be 50 mm in diameter. So that is a general identification or base identification that you use to define the shaft or the hole. So next what we see is the basic size or the basic dimension. So it means the theoretical size based on which the limits are derived for applying the allowances or tolerances. So there is very subtle difference between nominal size and the basic size. But basic size always refers to the theoretical dimension that can be used, but the nominal size is used to denote the base reference as a general identification technique. So next what we have is the actual size of the component. So this actual size is the final measurement of the actual part, that is the finished part. After machining, after the production processes is done, what is the output component that you have? So now you have three different variations of the sizes, that is you have the actual size and the base size, and to refer to the component as whole you have the nominal size. Next you define the limits based on the tolerances that you have. So the limits basically determine the extreme possible or permissible sizes that is allowed between the actual size lines. So we call it as a max limit and then a min limit. In max limit, the maximum permissible size that is applied for the basic size. So this 50 mm dia, you refer to the shaft as a 50 mm shaft, that means the nominal shaft. To apply the tolerances, you need to have a basic dimension, and this basic dimension is again 50 mm, and for that basic dimension you say that the maximum size that is possible is say 5 microns. So 50 plus 0.05 is going to be your max limit for that shaft. Next, min limit, you compute the minimum most size that is possible for the basic size and then apply to it. So based on your max and min limit, you determine the tolerance zone. Here you can see from the variation, that is the minimum size versus the maximum size for the shaft, this shaded zone denotes your tolerance for this shaft. Likewise, your hole, your upper and the lower limits of the sizes will determine the tolerance zone that is allowed in this hole. So these term what we covered was the size and the limits. So next, for the same image of this shaft and hole, the next key term is the deviation. That is, what is the algebraic difference between the basic size and the hole or shaft size of the actual part? Because earlier we were saying about the limits that are allowed based on a drawing, but here for your deviation we measured with the actual component versus the theoretical component. So for upper deviation, we say that the difference between this basic size versus the permitted maximum size that is allowed, and that constitutes your upper deviation of this shaft, and it is denoted by ES in angular bracket for hole and in small letters for shaft. Likewise, for the lower deviation, you consider the algebraic difference between the basic size and the permitted maximum size of the part. So for hole, it is EI in caps in angular bracket, and for shaft it is small letters in EI. So what is the actual deviation? The algebraic difference between the actual measured size versus the basic size. So again, going by, the tolerance denotes the limits that you can operate on. The deviation measures what is the deviation that is from the actual component versus the basic component, that is the theoretical component. Next, you classify in base of the fundamental deviation. That means that you either choose between these two deviations, that is, you choose between the upper or the lower deviation to define the position of the tolerance zone with reference to the zero line, that is the baseline. So it means that you either choose one of these to control the tolerance zone boundary wherein you have to measure the variation. So by selecting these, you select the fundamental deviation wherein you have to control your part. So as we said, the zero line is going to be the line that is drawn through the top generator of the basic shaft. So it means that the basic shaft, the bench shaft, actual shaft and max shaft are all aligned together at the bottom, and a straight line is drawn through the top generator of the basic shaft. Through this line is considered as a theoretical line which has no deviation. So suppose if it's drawn in the horizontal way, all the deviations above the zero line are positive and below are negative. So this is how we designate the positive and negative with respect to zero line. So why there are so many terms like the basic shaft or the basic size and the zero line, all those things, is because we are fixing references from where you are considering the tolerances or the deviation. So these are the key terms that you have to see. What we have seen was the size, the limits, and then now the deviation. So moving on, these features, these terminologies are going to get applied to the features of the object in hand. So what do you mean by feature is that it's a general terminology that is applied to a physical portion of a part. That is, it either refers to a surface or a hole or a slot. So it means that in a component you identify different features and then apply control to it. So what is the feature of size? So it means that this feature of size will refer to a cylindrical or a spherical surface or a set of two opposed elements or opposed parallel surface that is going to get associated with a size dimension. So this is called as a feature of size. So let me repeat it. So this feature of size is going to be a cylindrical or a spherical surface or between two opposed elements or opposed parallel surfaces within which you are associating a size. So based on that, you define your features. So this is the feature of size. The next important terminology is your datums. So as we said earlier, you need to have some references from which you can measure the component. So wherein this datum will come into play. So these datums are derived from the datum features. It can be either planes or points or lines or axes. So theoretically, they do not exist at all. They are reference features. So they are completely perfect. That is, they don't have any variation at all. And hence, these datums are used only for simulation purposes. That is, only for references purposes. So these datum feature simulations are commonly used for connecting the origins of measurements for either location or orientation or profile or runout. These are all references to from which the variations are measured or controlled. This datum feature is a part feature that contacts a datum. The datum plane or the feature it's in contact with the datum feature. So let's look into what the datum reference frame is. So datum reference frame elements actually exist within a framework of three mutually perpendicular intersecting planes. So these are the virtual reference frame that will help denote the datums. It means that you define a primary plane, a secondary plane and a tertiary plane that will call for references from which the datum of the feature are referred to. So this is the use of a datum reference frame. So typically you can call it as your X, Y, Z planes from where you are referencing the datums of those features. So if you could see here, in this primary data plane you have 3 points of minimum contact, whereas in the secondary datum there are 2 points of contact, and in tertiary datum you have 1 point of contact. So based on that you can choose how many reference frames you want to based on your component. So as we said earlier, in order to measure those datum, you need to have some planes or datum features that can be used for simulation. So the simulation is going to be accomplished by positioning the specifically identified features of the object in contact with the appropriate datum simulator planes that we have seen earlier in a stated order of precedence, that is, which is first. So based on the order, you refer the object, so that you are restricting the motion of the datum reference plane. So these specifically identified features are called as the datum features, that is in associated with the simulation features. Let us look by example. If you could see, this is your object, and for that object you define the datum feature that is as the surface of this object. In order to measure the surface of this object, that is the datum feature, you construct an imaginary datum externally, that is going to be your datum feature simulator, wherein you measure how the object is going to be here. So for this datum feature and the datum feature simulator, you have a common datum axis by which they are aligned together, so that the final objective is measured. Suppose if we are measuring the maximum allowance or the maximum clearance for this object, then this is how the datum feature simulator is used. This simulator can be emulsified by a component that is typically called as a gauge. So this is a highly controlled component, this gauge, that is used for inspection purposes. So you can call it as a go or no go gauge, wherein suppose if you are measuring the exterior surface and you are controlling using your gauge as an internal component, then this is based on the higher limits. You can qualify this feature as either go or no go and then reject it or approve it. So this is how this datum feature simulation is going to be used to control the limits of your object. So parallelly, this can also be applied to other surface. Suppose if you want to measure how this surface of this object going to behave, then you have to have a reference frame wherein the feature of this surface plate is highly controlled. So from there you can measure the variation of this plate. So this is what is called as a datum feature simulator. So next, associated with the tolerancing is the two terminologies, allowances and clearances. We look into those two. So allowances means that it is defined as the intentional difference that you allow in the components, so that the maximum material limits of the mating parts are defined. It means that allowance is the minimummost clearance, that is a positive allowance, or a maximum interference, that is negative allowance, between the mating parts. So allowance is calculated by the MMC, that is the maximum material condition of a hole, and the interfacing part, that is the shaft, its most maximum most condition. So in these conditions, what is the intentional difference that you are allowing is called the allowance. So this we'll look into example later stage, but now focusing on the definition for next clearance. This is similar to the allowance, but here you define as the loosest fit, that is the you look for the least most condition of the shaft and the hole, and it will control the loosest fit or the maximum intended difference between the mating parts. So here we have seen two terminologies, that is allowance and clearances. They are used interchangeably based on the type of the assembled objects. So let us look in. So what we have seen is allowances and clearances. These are going to be used for defining the assembly features. So in terms of assembly, we have to mention how well the fit of the components is. So in order to determine the fits of it, let us consider these two examples based on the previous thing. Let us consider that for a given object, for a given hole and a shaft, the maximum tolerance that is allowed is 0.3, and the allowance, that is the maximum material mating condition between those two assembling components, that is the shaft and the hole, is 0.2. Do remember, this tolerance is going to get applied for the individual components, whereas the allowance or the clearance is going to apply for the group of components, that is to an assembly. So towards this, we can define the fit of those components in two methodologies, either keeping the hole as the reference, that is the hole basis system, or keeping the shaft as reference as the shaft basis system. So in hole basis system, what we are doing is, the fit is arrived by associating varying shaft limit dimensions with a single reference hole. That means that the whole dimension is kept as constant, whereas the shaft limits are varied to determine what is the deviations are. And again, so for the single reference hole, the lower deviation, that is the fundamental deviation here, is 0. That is, the minimum limit of the hole is equal to its basic size, which is taken as the base for computing all other limit dimensions. So if you recollect the form, the key terminologies, what we said was, we define the deviations, wherein you can also go for a fundamental deviation, wherein you choose either one of those deviation and apply to the basic size. So here the basic size is going to be your hole, and hence in this hole basis system your lower deviation is going to be 0. That is, the minimum limit of the hole is equal to its maximum size. So let us look with an example here. So we have a hole and a shaft. So as we said, here this hole is going to be as a reference, and hence we are going for the minimum limit of the hole is what is taken as a reference. It's going to be considered as the basic size of the hole. So for this hole of 50 mm dia, the tolerance is 0.3, the maximum tolerance. So assuming this is the lowest size, that is 50.2, so this is going to be the minimum limit of the hole. So with this condition, you apply the tolerance, that is the maximum limit for this hole is going to be 50.5, and then based on this, you arrive with the allowance, that is with the base of this dimension 50.2, you apply the allowance to determine what is going to be your maximum and minimum sizes of your shaft. So it means that for the 50.2, for allowance of 0.2, your shaft is going to have a maximum size of 50, wherein you taken for the lower side is the from this 50, because it's absolute, you can't consider this dimension at all. So you have assigned the maximum most possible condition of this shaft based on this hole basis system and say it is 50 only, and then you apply the tolerance for this component, that is you allow the variation of 0.3, as you have already specified the max limit of the shaft, so the min limit is going to be 49.7. So this is how your hole basis system is going to act on. So moving forward for the shaft basis system, just you revert the references. So here you consider as a single reference shaft. Based on this, you vary the hole dimensions. And again, for this reference shaft, the upper deviation is going to be 0. That is, the maximum limit of the shaft is going to be equal to its basic size, which is taken as the base for computing all other dimensions. So going by the definition, again the same reference. So for the same dimension, as the shaft is taken as a reference, so this is going to be the reference base condition 50, upon which you apply the tolerance. So this is the maximum size that is allowed. So you go on to the negative side, that is a 0.3 defined as 49.7. So next, based on this definition of 50, that is the maximum limit of the size, then you apply the tolerance, the allowance variation is 0.2, and hence the minimum most size that is allowed for the hole is going to be 50.2, and then applying the tolerance to it is 0.3, that is 50.5. So this is how your hole and shaft basis system is used to applicate the tolerances and the allowances of the assembly so that the intended function of the mating parts is met. So based on these, what are the different types of fits that are allowed? So let us take hole basis system as reference. So here you can see that we have shafts and the hole with the basic size and so on. So there are three different types of fits that are permissible or allowed. That is, we have a clearance fit. So what means by clearance fit is that the largest shaft that is possible is going to be smaller than the smallest hole. That is, considered in this example, the largest possible shaft that is allowed by your definition is going to be still smaller than the smallest hole. So it means that there is going to be a positive allowance here, and it's always greater than 0. So for this shaft, if you see, the largest shaft dimension is going to be 12.48 mm in dia, and the smallest hole is 12.5 mm. So it means that you still have a allowance of 0.02. So So this is going to be a clearance fit. So in your shaft basis system, again, if you see here, if you are fixing the shaft as the base, and then if you see the largest shaft is going to be smaller than the smallest hole, and hence the allowance is going to be possible. The terminology is the same, but based on your references, the references of the shaft dia and the hole dia is going to change. So you either stick to the hole basis system or the shaft basis system when you design a component. So next is your transition fit. So in transition fit, it means that the allowance is going to be negative and the maximum clearance is positive. The parts may be either loose or it has to be forced together. So let us part this thought a little bit. Let us go into the interference fit first. So here in interference fit is an opposite condition to the clearance fit. It means that the smallest shaft is going to be larger than the largest hole. That means for this shaft, the smallest most dimension that is allowed is going to be still larger than the largest hole that is possible in the system. So typically it means that you cannot fit the components together using normal condition. That is, the maximum allowance is always going to be negative. So that means that there is going to be an interference to it. So here you need to take special manufacturing processes. Suppose that means that you can either heat the component that is going to have this hole so that it becomes enlarged, that is, it enlarges greater than this allowance, maximum negative allowance, and wherein this shaft can be fitted in. Alternatively, they can cool this component, this shaft, in order to shrink and then fit it. So typically this interference fits is going to be used in a varying in different automobile components. For example, if you take the gear assembly in your gearbox, there you have your interference fit. Then the wheel hub assembly, there again you have your interference fit. So based on the application, it is going to vary. That is, if the object can rotate freely into it and is just a transitional element, then a clearance fit can be used. But if there is going to be a strong lock of the relative motion between these two components, then you need to have an interference fit. But that's where you have an intermediate between these two, clearance or interference, that is the transition fit. So it means that the allowance is negative and the maximum clearance is positive. So they can either be as a clearance or as an interference, that is, they may be loose or it can be forced together. So it either fits between these two based on the condition that they have. So for these conditions, you can arrive at two different varying parts. That is, if you take in a condition of a minimum of shaft and the maximum of hole, that is, if you see in the largest shaft, that is the max shaft. Okay, let's come here. Yeah, the smaller shaft, the minimum shaft and the max hole. In this condition, if the clearance is going to be maximum, it's going to have a transition fit. Whereas if the interference is going to be minimum, that is, the allowance is going to be minimum, that is the negative side, then it's going to be an interference fit. Likewise, this condition where the max shaft and the min hole is considered, if the clearance is going to be, or the interference or the allowance is going to be minimum, then it's a clearance fit. Whereas if there's going to be a maximum interference between these two components, the max shaft and the min hole, then it's going to be a transition fit. So this transition fit, based on the application, you can vary, or it fits between the clearance and the interference fit. So this covers the different types of fit that your sub-assemblies are going to hold. So how do you represent the fits and where to use which fit? Let's look into one by one. So typically this is how you define the fit. So you go for two different types of basis system, that is the hole or the shaft. So for all internal dimension, that is the holes, you have your basic size and then you define the tolerance zones based on it. That is, you define the clearances of the allowances of this by using two denotions. The first is the character, if it's going to be a capital one or a smaller one. So the first letter is going to be your fundamental deviation, that is the position letter, it defines that. Next, based on the numerical system, this defines the tolerance grade based on the fundamental deviation. So Then when you assemble these two together, that is, you assemble your hole and the shaft, you go by the base dimension of those two and then define the fit for the hole H8 and for the shaft F7. So what are the types, how it can be defined based on a hole based system? Let's look into. So this is a typical mapping of how it can vary. So this line is going to be a basic size line, and then on this side you have your hole, and in this side you have your shaft. So based on that, you go by grouping together of your shaft. So here in hole, for H11 you have to pair up with C11. That means your hole tolerance is going to be H11. So the C11 is going to be your shaft tolerance. So based on this, you define, based on these conditions, you define the maximum most clearance that is available, and then minimum most clearance is also available. So based on that, you can see the different nomination, the pairs of nominations that we use to nomenclatures to define the variations. So here, until this zone, let me just zoom out. From this zone is going to define your clearance fits, whereas this zone is going to define your interference fit. Wherein here you go for your minimum and maximum interference. So based on this, you select what are the components that you're going to select. And then there's an intermediate zone wherein you can see there's an overlap here. Here it is clearly separated between these two and hence a clearance. Wherein here it is going to interfere between these two, that is the shaft is going to be larger than your hole and hence it is positioned here and this is an interference. Wherein there's an overlap between these two conditions here, that's going to be a transition fit. So let's look into examples to each and every one of it. So in the first condition where we see as the H11 and C11 for a hole basis system, we'll refer to only this column for easy understanding. So this kind of combination can be used to define loose running clearance fits. So this is used for commercial tolerances or allowance for external members, that is, there's not going to be any interaction between the components together. It's just as a loose fit component between those two, shaft and hole. So then you can go for this referencing. Next, for this, it's called as a free running fit. So this is used where accuracy is essential, but it's going to be applied for large temperature variations or high running speeds or where heavy journal pressures are exerted. So in those conditions, you go for this free running fit. In this condition, that is a closed running fit. This is required for running on very accurate machines wherein you perform important tasks and for accurate location of the components that is going to be used at moderate speeds or moderate journal pressures. Next, you have your sliding fit. You can see the clearance keeps on reducing, and in this sliding fit, it is not intended to run freely but to move or turn freely and locate accurately. In this condition, you use this. Whereas in the least part of this clearance, you have your location clearance. It's used to provide the snug fitting of the stationary parts. That is, it can be assembled or disassembled, but it has to be fitted by an external component, that is using a snug fitting procedure. So next you have your transition fit. So it again is going to denote in this zone. It either goes as a location transition in the clearance zone or the location transition in the interference zone. So that is, it's used for an accurate location, a compromise between the clearance and interference. Likewise, the same in this denotion where a greater interference is permissible for this denote. You can cross-refer this along this diagram to have a clear understanding like how it's going to be positioned. So next, in this interference fit, it means that in this condition, transition fit for basic sizes for 0 through 3 mm, you go for this 6 nomenclature, wherein the location interference fit is used for parts that requires rigidity and alignment with prime accuracy of location, but without any external bore pressure requirements. Wherein you still go for higher interference, wherein the objects, the steel object parts or shrink fits are used for the different sections. So this is what I was speaking about earlier, and going for a tighter tolerance, more interferences, that is the force fit. So it means that you either heat it out or shrink it or exert heavy stress, that is you hammer that element into the component. So that means that you have to have heavy pressing forces that are required to do it. So in these conditions, it means that though they are two different components, after fitting these, going to behave like a individual single component. So this is how you select upon the different fits that are required to you based on your application. So now let's look into the various tolerance grades that you have to determine. So till now what we've seen is various allowances, tolerances, and based on that what is the different sizes that are going to use. Now we have to determine like what is the tolerance that I can allow for a given manufacturing process. So this is where your IT grade will come into. So this is defined in ISO 286 wherein 20 different grades of tolerances have been defined. So these grades determine what tolerances are allowed or can be specified for a given process. So it means the capability of a process. So based on that, the tolerance can be defined. So the first band, that is IT0 to IT6, it's a very tighter tolerance zone. It is used predominantly for the production of gauges and measuring instruments because you are measuring the variation of a component, so you have to keep your tolerances as tight as possible, as close to your theoretical limits. So this is where the tolerance zone comes in, that is from 0 to 6 grade. Then you have an intermediate grade, 5 to 12. This is typically used for almost all the engineering processes where you define a tighter precision as well as the tighter nominal grades of tolerance. Then a subcategory to it wherein you have grades 11 to 16. It's used for production of semi-products, that is they are still yet to be machined or manufactured to attain the final process. So it's a part of the sub-assemblies. Then you can go for this object. Then again the higher side, that is grade 16 to 18, wherein the controlling of the tolerances is difficult, that is typically for civil structures and so on. And another broader specification, that is IT 11 to 18, that can be used for specification of limit deviations of non-tolerated dimensions, that is the tolerances are not specified. In those cases again you can use these grades. So bringing all this to process and categorizing them to the grade, you can see the variation, that is the typical, the 2 to 0 to 6, okay, these components. You can see the processes that are going to be used here are processes that can result in high tolerances. So this is the lapping operation, honing operation, super finishing operation, cylindrical grinding, diamond turning, plane grinding, and then a part of a broaching, reaming operations can satisfy to the tighter tolerances, that is accuracies going to micron levels. Wherein the next band where we have is the 5 to 12 is a broader tolerance zone. There again you have your this process, the grinding process, reaming process, boring. Then you have your sawing process that you can see a wide variant because based on the different type of cutter, the boring and turning process, based on the different types of cutter, based on different cutting speeds, and hence you can control what's the tolerance that you have. So you have your sawing, milling, planing, shaping processes, that goes until like 15, 16 here, that has a slightly relaxed tolerance because with this process you can't control the tolerances very closely. Next, on the higher side you have the processes, that is extruding, cold rolling or drawing process, drilling, dry casting, forging, sand casting, hot rolling. These all falls under the higher category. That means that the typical differences goes in the order of mm. So how to determine it? So just have a quick go through of it. How these tolerance grades are calculated based on the grade is that, let us see what is the limit that is allowed. So this is the formula that is used to calculate it. The tolerance grade 1, 2, 3, whatever it is equal to 10 raised to 0.2 times of IT grade. Here is where you plug in your numerical grade and then times 0.45 times of cubic root of your diameter, nominal diameter, plus 0.001 times of your diameter. So here the T is your tolerance in micrometers. Next is your D, that denotes your geometric dimension in millimeters, and then IT grade. So based on this table is, it can throw you a little light of what is the allowed tolerances. So if you could recollect the tolerance grade 2 to 6, where highly critical processes wherein you can give a tighter tolerances. So if you go by the basic side definition, that is controlling the D, you can say plugging onto the different tolerance values here, you can get the what is the maximum tolerance within which this object can be controlled. Suppose if you are operating with a smaller object, say with a 3 centimeter 30 mm size of thing, then these processes, the first 2 grade process can control within 1.5 micrometer. So as we go on to higher tolerances for the same basic size, you can see the tolerances increases. So here until IT11 you have like 110 micrometer, then going on further you define in terms of millimeter. That means that for example a 30 millimeter component going for a IT grade of 18 can produce a dimension variation of 3.3 mm. So this means that for this component, that is for 18, generally means that for these categories you cannot go for, that's the control of what is the basic dimension that you can use for. That is for IT grades 1 to 5, that is where you have a tighter controls of tolerance. You typically go for only 500 mm, that is just 50 centimeters. So typically within this is what you control it. You have to look into only this zone. This is just for representative purpose. That is, there is no point of going for a tolerance of, say, with this process of 135 96 micrometer tolerance for this huge dimension. So it typically does not make sense, because if you want to reduce this object, then you have to use a combination of different processes. You do not directly go for this tighter a specialized process. Rather you go for a process that calls for a lower tolerance and then gradually reduce the size. So this is how you have to determine between the various components. Likewise, in the higher zone, these are not used for basic sizes that is less than or equal to 1. Again, it makes sense, like for an object that varies between 80 and 30 mm, then the tolerance is going to be 3 mm. So it's typically used for a process that requires for a very high tolerance range. So let us go back to this previous slide to see typically how the object is manufactured. Is they are initially the tolerance is controlled in the first level by the first manufacturing, wherein you either the forge component, for example if you go for a piston rod, okay, so you go for a forging wherein you initially control the tolerances, that is from a band 13 to 16 is where you have 13 to 16 you can see it lies to like in maximum 30 mm, minimum 3 mm. So in this zone you specify the allowed condition for that operation. Next you go on to the next operation, then that is you go for a planning or shaping operation, then you machine it particularly, then you bring down the tolerance, then you go on to the next step, that is you control finer tolerances here. Then in order to measure this completely machined product, then you go for a gauge that are subjected to this machining process, so that it can control you measure the variances that are very small tolerances of 1 micrometer or so. Your original object might be in the order of 5 microns. So this will constitute your at least a dimension that you can measure. So this is typically how your IT tolerance grades are defined in your standards, and you always have to have in mind. So this is your strong engineering practice that's going to go when you design a component. When you design a component, you also define like what is the process that needs to be followed to do that, and based on the different processes you have to draw your draft your drawings and specify the tolerance according to those processes. So this defines a very good engineer that has a good grasp of this condition. So next we'll look into the various symbols and modifiers that are going to be used in this GD&T terminologies. So this is the visual method of communication to the manufacturer as well as the inspector to indicate what is the limit dimensions, what are the methodologies that needs to be followed to ensure that the tolerancing is attained to. So first what we have is the different types of categories of tolerance. That is what is listed here. So these categories deal with the tolerance of the form, tolerance of the location, the orientation, the profile or the runout. So based on that we have the various geometric characteristics that are going to be controlled, and we have this symbolic representations of those characteristics. So each and every characteristics has specific prerequisites, that is whether datum reference is required or not, and then how it can be applied to the various feature size surface or the feature of size dimension. So whether this form can be applicated or not. So likewise, so this is how you must look into the various applications of this symbols. Next we have the modifiers. It means to say that it overrides the condition of the material. It will say what is the allowed material condition. So here the various parameters that we have here is the regardless of feature size RFS that doesn't have any symbol. Then we have the maximum material condition, least material condition, then the projected tolerance zone, and then unequal tolerance zone, tangent place. So it means that these modifiers go along with the symbols to convey the end objective to the manufacturer as well as the inspector. So we have to be very careful of what to use, and if suppose we are using one of this parameter, then the prerequisite as well as the essential conditions need to be satisfied, and only then it can be applied. So let us look into one by one now. So going forward, this straightness is the part of the form tolerancing, that is you are applying the tolerances to the form of the object. So this is the symbol for it, it's a straight line. So the definition goes like this. An element of a surface or axis is going to be straight line, and hence one of the surface elements is going to be constrained to lie within two parallel surface planes separated by the tolerance. It means that the form of that surface has to be constrained between two planes so that it does not exist. So any line across that surface in that view will be within those two parallel lines. So only then that part is going to be accepted and cleared for. So this is what straightness means. So let us look by this example. So here this is what we mentioned as a drawing. So this is a circular shaft, and in this view you can see that the cross section is going to be plane, and the dimension is controlled with this tolerance specification of straightness, and it's applied to this symbol. That diameter surface symbol is within 0.01. So what it means is that on this surface you draw two parallel lines up and below with this tolerance, because see, your tolerance is going to be 2 plus or minus 0.02. So it means that 1.98 and 2.01 on the exterior. The maximum allowed is the controlled by this dimension, whereas the overall dimension is allowed by this point. So you can see that there's a slight variation between this. So the center line tolerance is what is going to control by the straight line. So within this zone of 0.01 of tolerance within this straight line, the material can lie so as to ensure that the overall tolerance is also not exceeded. So the outer boundary is controlled by this. So you can see that the external is 2 plus or minus 0.2, and over and above you have this tolerance of 0.01, and hence the overall tolerance is going to be, that is the stack up tolerance is going to be 2.03 mm, wherein at this exterior point, okay, so from this point to this point, that is the actual size element, there you are getting controlled by 1.98 only within this. But having applicated this tolerance width of 0.01, you will get that additional 0.01 mm that is getting added to this overall dimension. So this is how the form of this is going to be controlled. So this is how you can see the symbols is going to add on. The tolerance zone will control the shape, the form of this object. So you can slightly go through this command again. This tolerance is going to be the overall size tolerance that is permitted, that is the straight line that is drawn to here. Okay, so this is the allowed variation of that object, but considering the two datum planes wherein the straightness can be the datum reference plane to measure the straightness of this element. So for that the total dimension can vary. For this point the tolerance is acted upon, and hence it is 2.02 mm. So next, moving forward, flatness. It is an extension of the straight line. It's also a part of this form. It controls the form of the surface. So this is the symbol for flatness, and here it's a two-dimensional tolerance zone defined by two parallel planes. Earlier we were seeing as lines, so these are two parallel planes within which the entire surface must lie. So all the surface elements has to be constrained to be lie within those two parallel planes only, separated by the tolerance. So going by the same example here, if we specify this tolerance of flatness here with 0.005 to this overall dimension of 1.00 plus 0.01 mm, it means that you construct two-dimensional plane here. You can see here this element in this view. You can see this is going to be a base tolerance reference zone, and over and above you have this tolerance zone specification of parallel planes 0.01. So it means with this reference plane, this boundary of 0.05 is the maximum allowed flatness plane within which the object must lie. Likewise, on the lower side we have the other plane that you have drawn here. So this is your allowed flatness zone. So only this is your flatness zone. So you can't go below here also. So your base object is 1 mm here. Over and above you have your size tolerance as 0.01 mm. So this is your max boundary, and within this max boundary what can be the form tolerance is what is controlled by your flatness here. So this lies within it. It can never exceed it. The same can be seen in this form also. So this base lines, these two parallel lines is what the maximum allowed variation of this form, and this external height, this topmost, and so this is your maximum material height, that is going to be controlled by your size tolerance. So this is how your base tolerance and your GD&T tolerance symbol is going to play upon. So moving forward, the next form tolerance is your circularity. This is your third form tolerance element, and it's represented by a circle. So here this circularity is a condition on a surface of revolution, that is a cylinder or a cone or a sphere, where all the points on the surface that is intersected by any plane perpendicular to a common axis of the cylinder or cone are passing through a common center of the sphere. In these cases, both the plane that is perpendicular to a common axis for a cylinder or cone or through a common center of a sphere are equidistant from the axis of the center. So for this circularity, all the points on the cylinder surface are constrained to lie within those two circles only. So this is going to be a 2D surface form tolerance. So here let us look with this example. So this is the meaning, that is size tolerance is 1 plus or minus 0.1, wherein the form tolerancing is a circularity with 0.002. It means that the overall size variation is going to be minimum 1.001, wherein the maximum size is 1.01, within which the external, these two circles, right, this surface and this surface, must have only 0.02 tolerance that is allowed by your circularity element. So this is how you control your circularity. So next form of form tolerancing, we have the cylindricity. So the cylindricity is represented by this, so that in circularity you have two tangential elements. So a condition on a surface of revolution, that is your cylinder, cone or spherical here, in which all the points of the surface are going to be equidistant from a common axis. So that is your cylindricity. So this is the extension to your circularity function. Okay, so it extends from 2D to a 3D based form control, which controls the roundness, that is the circularity, as well as it also controls the straightness and taper of your 3D form. So to better explain this, we have a figure here. So the same shaft of base dimension 2 with a unified tolerance of 0.02 on the plus side has a cylindricity of 0.01. It means that this on the overall on both, as you can see, this is controlled in this view as well as in this view, that is in 3D view, because here you have the two dimensions, here you have the third dimension, the two different planes. So with this, all the three planes are covered, which and by which the external boundary is limited by the form of a tolerance zone of 0.01. So this is your cylindricity that applies onto here. So these are the four forms of form tolerancing. So let us go back to this definition once more. So you can see now we have seen straightness, flatness, circularity and centricity. Now these are all applied to this thing. So there is just a difference between here. These two are wrongly represented. Centricity is represented by this and position tolerance by the other symbol. But these four are going to be your form tolerances. So these form tolerances are all can be applied to the feature surface, whereas feature of size dimension, that is a 1D surface, is the straightness alone, whereas all other these two are 2D and this is 3D, and hence is not applied to the feature of the size dimension. Whereas for all these form tolerances, datum reference is not required. That is, it does not reference a reference datum. It can be directly applied to the form. So next what we are going to see is the locational tolerances, where we have position tolerance, concentricity and symmetricity. So we'll quickly look into one by one. So first is the true position, that is located by the symbol, by this kind of your center symbol. So what we are doing by this is that this is the zone, the true position is the zone within which the center axis or center plane of the feature of size is permitted to vary from its true, that is your theoretically exact position. So this is a position tolerance that generates a tolerance zone that confines your center axis or the center plane or the axis of feature. So it is also capable of confining a surface or surfaces within or outside a boundary known as your virtual condition. That means that in this figure you can see this is a rectangular plate that has true holes, a larger hole in here, whereas there are other peripheral holes that are drilled here. So now we can see there is a box that are referenced as we've seen in the GD&T. This we'll look into this is called a feature control frame that we'll look into later. But you can see now this cylindricity is applied to these holes to ensure that the position is controlled by it. So as you can see, it also refers to the datum planes here, and also it defines a material condition here. So what it means is that this true position is applied to this center. This center is allowed to vary only for 0.02 mm of this dimension. This is your true position. So based on this, it can be constrained only this variation. So this is your tolerance zone. Whereas this external whole dimension is controlled by a upper side positive deviation of 0.1 here and here. So this is what controls your position variance. So in essence, this center line that is drawn here in this view, it can vary only within a zone of 0.02 on either side. So this true position is applied to the center or the axis or center plane of a feature of size. So this is how you are applying the tolerance to the location. So next we have concentricity. This is also a part of your location tolerance that is represented by two circles, two concentric circles. So what it means is it is a cyclical tolerance zone whose axis, the axis coincides with the datum axis and within which all the cross-sectional axis or the feature being controlled must lie. So it means that this is going to be geometric control of the median points of all diametrically opposite elements of a figure of revolution. So it has to be measured by a instrument that goes throughout this cyclical zone to measure all the points that is referred and to the median point of all the diametrically opposite elements. So this is normally a very expensive and time consuming process to measure, and hence due care to be taken, and only those critical dimensions have to be toleranced by this concentricity. So here you can see in this example we have a shaft with two different dias. We have a larger dia here and a smaller dia here, and for the smaller diameter shaft of 1 mm plus 0.03, concentricity has been applied with a variation of 0.2 with reference to the datum surface A. So it means that a center axis drawn through this plane can have a diameter tolerance zone of only 0.2, that is this exterior zone, within which all the median points derived from this surface. This is a revolutionary surface. It's not a 1D surface but a 2D surface on this plane. So all these median points along this entire plane should lie within this 0.02 diameter of tolerance regardless of its size. So this is controlled by your datum axis. So this is the datum axis. So this is your surface here within which the axis of actual mating envelope is contained. So this is how you contain the cyclical tolerance of a circular element. So next, location tolerance is where we have a symmetry behavior. So this is denoted by these three lines. So symmetry is the condition where the median points of all opposed or correspondingly located elements of two or more feature surfaces are congruent with the axis or center plane. So it is similar to the concentricity in the point that it is again referring to the median points of reference, but it refers to two or more feature surfaces that are congruent with the axis or center plane of the datum feature. So this again calls for a datum feature here, wherein we have two surfaces here, and this location control is applied to these two surfaces and mentioning that these two have to be symmetrical along with this datum surface of A. So it means that for these two surfaces along this datum plane A, so for this datum surface what is the center plane, and for this center plane this is going to be the tolerance zone of width, and hence these 2 points have to lie within this variation zone so that the symmetricity of this surface and this surface is maintained with this surface. So this is the symmetry location tolerance. So next is the orientation tolerance. So going quickly back to the overall chart, in this orientation we have three different types of geometric characteristics, that is we have a perpendicularity, a parallelism and an angularity. So these three controls the orientation of the feature surface and as well as the feature of size dimension. So earlier in this location tolerance it applies only to the feature of size dimension and not to the feature surface. So likewise in this orientation it applies for both the feature surface and feature of size dimension. And for this orientation tolerance we definitely refer a datum requirement. So let us go back to our slide. So angularity is the orientation tolerance that is represented by this symbol. So what it denotes is that a distance between two parallel planes inclined at a specific basic angle in which the surface or axis or center plane of the feature must lie. So it means that it requires that all the points on the specified feature must form an angle with the datum reference. So this is where your datum comes in. So now in this example you can see that there's an inclined hole drilled through this feature, and hence the angle of this axis of this feature in reference to the datum plane A should be controlled within an angular tolerance of 0.05. So it means that this center axis is controlled within this variation. So you can see that in percentage of tolerance zone we have the 0.05 and that is for your whole diameter of 1, whereas for a whole diameter of 1.01, that is for the maximum condition, then it is the variation is going to be 0.1 and 5, because over and above this 0.1 is where you have applicated here 0.005. So this is how it applies to the different hole, because we have a base dimension here and a maximum material condition here. So applicating those two to here you get the tolerance zone specification. So this is your orientation tolerancing, controlling the angularity of a surface or axis with reference to your datum plane. So next orientation tolerancing is your perpendicularity, where we maintain the median plane or the surface or axis 90 degrees with respect to a datum plane or axis. So this again in similar to the angular plane, all the points on the specific feature must be perpendicular with the datum. So we can look at this section. So this is a perpendicular through hole machined through this element. So here the perpendicular tolerance zone is for size is 0.005 with a maximum material condition, and it applies to the datum plane of A. So it means that with this dia of A, so wherein we have a minimum condition of 1 and then a maximum condition of 1.01 for A, because this again we have two variations. Even for this dia we have the maximum material condition for this datum plane, so that's why we have two condition, and then again applicating the tolerance to that. So for one condition, that is with 1.00, and applicating the tolerance of width here for the whole of 0.5, and then in the other case the whole of 0.52. So in those two cases of dia of this datum plane axis and then whole dia, so for that the tolerance is going to vary 0.005. so here it is adding to it, it's 0.05, wherein here it is 0.025. Likewise in here, for this it's going to be 0.15, and here it is going to be 0.035, that is applied onto this. So this is the tolerance zone that is allowed possible orientation perpendicular to your plane of axis of A. So this is your perpendicularity orientation tolerancing. So next, similarly, we have the parallelism orientation tolerancing, that's represented by two angular lines here. So this refers to the condition of a surface or axis which is equidistant at all points from the datum reference. So again, all the points on this surface are to be parallel to this datum reference within the specified tolerance. So here for this surface should be parallel to this datum reference A with a tolerance zone of 0.01. So if we have a reference plane and here, then the maximum variable tolerance in this is 0.01. So this is a parallel orientation tolerance. So next we have the profile tolerancing. So we have two variants to it: profile of a line, that is 2D, or profile of a surface, that is of 3D. So going back to the overview, so here you can see that for this profile tolerancing, it applies only to the feature surface and not to the feature of size dimension. And for this, we can use a datum reference. So this can be used to control the form also without the datum reference. So based on the requirement, you can specify the reference or not. So let us go back to our slide here. So here this profile of a line is represented by an arcual element. So it means that a uniform two-dimension zone limited by two parallel zone lines extending along the length of the feature. So whatever length it might be, so that surface, a parallel surface is extruded on the both the sides. So that will define the amount of deviation within which the surface should be lying. So this is the profile of a line variation. So if you see in this feature where we have this curvilinear element, wherein this is applied to this surface with this reference. Okay, so then in this 2D plane, drawing a parallel line between these two, within which this surface should lie in. So this is your profile tolerancing of a line, wherein for surface it is represented by closing the representation. So it can be applied because generally this is allowed for a 3D zone. So this is one of the most powerful GD&T symbols because this encompasses almost all the tolerance zone that we have seen earlier, because it also encompasses the profile of the line, the straightness. So all those things are included in this. So if you can see that for this, when we apply this profile of surface, then it is applied on all the views wherein it's all constrained by this 0.02 dimension. So we are getting a strict profile or the form control of the entire object in its 3D view. So next what we have is the runout tolerancing. So runout tolerance also is a very powerful and also easier way to measure on your end of line. So there are two ways of measuring it. It's either the circular runout, that is on a single axis, or if you consider as a surface, then you can measure the total runout. So it can be applied to the feature surface, also to the feature of size dimension, and it obviously requires the datum reference plane to set the comparison limit. So coming back to our slide here, so this for runout tolerancing, this is going to be a symbol, And so this is a composite tolerance. Why composite? Because it controls one or more features of the part. It's an inclusive one, that is by executing a 360-degree rotation about the datum axis. So what it does is, in order to use this tolerance, this element will be rotated along this axis of rotation, and wherein the runout will be measured. That is, you can see in this example here, for this feature, the runout is controlled on this surface. So it means that the maximum variation is 0.01 with reference to the datum features A and B. So for these two datum axes A and B, the feature is rotated upon it, and we have a circular dial gauge that is fixed onto a single point, and the variation of this circular dial gauge along this axis on the rotation 360 rotation should be within a maximum dimension tolerance of 0.01. So this is your circular runout. So this is all is applicated to all the components that have a rotational mechanism where the rotational surface, the 2D feature, to be controlled, because any undulation might result in a failure of the function. So in those cases, this circular runout is a very powerful tool of controlling the runout tolerance. So then we have a total runout. So here we have one more addition to this line of the circular runout. So what it does is, it's again a composite tolerance wherein the entire surface elements are mapped within that runout zone. So if we apply it to this full zone, so it means that you are running this dial gauge onto the surface along this entire length of the feature. So this entire zone at all the points should lie within this 0.01 dimension tolerance. So this is your runout tolerancing. So next we look into the modifiers that we can apply to the tolerance zones. So first is your regardless of feature size. So what it means is, this is going to be the default condition for all geometric tolerances by rule 2. So this GD&T rule that we'll look into in the next slides, but typically this is the basic tolerancing. It means that if you do not mention any modifier, any symbol to it, then by default it means that the feature is controlled regardless of the feature size. So it simply means that whenever there is this reference, that is, there is no symbol that is referred to here, then the size, this tolerance, is going to be controlled irrespective of the feature size. So it means that this tolerance zone is strictly pertaining to this only tolerance axis. So the actual size is going to vary from 1 to 1.01, and on this the tolerance zone is strictly applied. So simply saying, this is what we have seen in the earlier examples of your form tolerancing, because you do not have the datum references, so it is strictly applied to the size of the dimension without any independent control. So next what we have is the one more thing is that this regardless of feature size is eliminate any additional bonus tolerance that we get when we refer to a datum axis. So this is a very tight method of controlling the datum features. So it is always used for runout, concentricity and symmetry based controls, and also in case of external or internal features, that is a hole or a circular the external a fillet kind of thing, then it is used to control the wall thickness variation with this modifier. That is, you are strictly restricting the maximum boundary that it can exceed. So this is your regardless of feature size. So next what we have is a powerful tool, that is the maximum material condition, that is represented by the symbol M. So here this is a feature of size that contains the maximum amount of material everywhere within the stated limits of size. So it means that the tolerance is at the extreme. So tolerance is applied to the extreme. So in that condition, it would result in a very little material is removed, so that maximum material is retained within the feature. Suppose if the MMC is applied to the internal feature, then it's going to be the smallest allowable size that is removed out of it. In an external feature, it's going to be the largest allowable size. So this maximum material condition, there are restrictions to use it. These are applied to features that are incorporated to the axis or the median plane. So it cannot be applied to a flatness, roundness, cylindricity, profile of a plane, profile of a surface or runout. So this maximum material condition is applied only to those features that incorporate an axis or a median plane. So let's look into this example. So here we have a datum reference of A here with this that is controlling this external feature a maximum of 2.01, and here this surface is of 1 to 1.01, and quotient tolerance is controlled using a maximum material condition and with reference to the surface A. It means that with the actual size of 1 to 1.01, the maximum variations that it can go is this. So for this the maximum is 0.01, whereas for this it can extend until 0.15. So this is the maximum condition that we do. So please refer to your the previous slides where we had looked into the flatness conditions, where the maximum material condition was covered. So this is how you allow the maximum material that is to be retained within your material. So this is applied to your straightness, not to flatness, but this to the straightness. So next, the opposite condition for MMC, we have the least material condition. So this is a feature of size that's going to contain the least amount of material everywhere. So it means that the tolerance will be at the minimum most extreme that would result in a condition with only a large amount of material that's going to be removed from the base feature, so that minimum material is going to get retained. So this LMC will ensure that all the components are prevented being assembled. So it means that much material is cut off, then it prevents the component from assembled. So this LMC symbol condition is always used to assure a minimum amount of machining stock that has to be retained so that it can be comfortably assembled, because beyond this the function of the components does not get satisfied. So this gives the minimum most condition so that the feature can be measured and can be used for the assembly of the components. So this again, with this example in this zone, when applying to the least material condition, so it means that this is getting alternated. So only with the maximum condition is here 1.01, that is where the max tolerance zone is applied, whereas the maximum material condition for a tolerance of 1.01, the tolerance zone is going to be 0.5. So thereby we are controlling the maximum material, whereas here even with the minimum mating envelope of this and with this tolerance, we are assuring the minimum most material that is available for the components to get assembled. So this is your least material condition. So next in modifiers, we'll see the additional 3 modifiers that can be used at our disposal. So first thing is the projected tolerance zone that is represented by the symbol P. So what this does is, so far whatever we have seen applies only to that feature, that is all the modifiers and the symbols apply only to that feature surface, whereas using this projected tolerance zone, in case of mating components, this tolerance zone can be projected onto the other features mating part, creating a virtual zone of tolerance. So this is highly useful for mating features, that is two interacting components. So this is your projected tolerance. So for example, this can be applied to a bolt and a hole or a shaft. So those kind of features, to align those tolerance zones you can do. So this is useful for stack up analysis of your assembly. So next is the unequal tolerance zone represented by U. So all the tolerance that we specify to the form are equally distributed about the true profile, whereas sometimes in some areas where in one end of the profile we need to have a unequal zone, then you can override that control using this modifier. That is, on one end you control on the higher side, on the other end on the lower side within the tolerance zone boundary. That is, you are disposing the tolerance zone unequally. This is done by the command of U. So next what we have is the tangent plane modifier represented by T. So this is an easier way to control the surface, because so normally in any tolerance, so suppose if you consider the flatness or parallelism, then what you are doing is each and every point on that surface have to align to the parallelism tolerance. Whereas if we apply the tangent plane modifier to this, it means that you position a tangential plane to the high points of the surface, so that instead of considering each and every point, the high points of the surface, if that is tangential to the surface, comes within the tolerance zone of parallelism, then you are satisfying it. So this also removes the bonus tolerance that we had seen earlier in the MMC condition, that is with maximum material condition. We have an additional tolerance that can be removed because we are specifying the high point from this surface. So this is the tangent plane modifier. So based on specific manufacturing technique requirements and inspection techniques, you can opt between these modifiers to control the form or profile of your feature. So moving forward now to the rules of GD&T. So this is basically whatever we covered in the earlier slides. So going by one, the first rule is that the individual feature of size or the perfect form at the MMC or the envelope rule condition. So typically what it means that when only a tolerance of size is specified, that is only the maximum tolerance, that is the size of tolerance is specified. Suppose example, dia 50 with a variation of plus or minus 0.001 mm. So it means that only size tolerance has been specified. Then the limits of size of that individual feature prescribe the extent to which the variation in geometric form as well as the sizes are allowed. So simply means to say that suppose if we operate on the maximum material condition with this only size tolerance, that is of 50 mm dia with a maximum tolerance of 0.001. So in that case, it means that at 50.001 condition, that is in your maximum material condition, no more tolerances allowed. That is, we don't have any other modifier in that case. So in that case, for an MMC, it means the external surface is of perfect form without any undulation or without any errors. So this is the rule number 1 of your GD&T. So next rule is that regardless of feature size that we had seen earlier. So it means that unless specified any specific modifier, all the default modifiers are considered to be regardless of feature size. So it means that with respect to the individual tolerance, the datum reference or both of it, where there is no modifying symbol specified. So therefore, we always need to have the MMC or LMC or sufficient modifiers to be included in the drawing. So these rules like hard and fast override the GD&T tolerance zone we are providing. So it means to say that unless we override this using modifiers, whatever feature of size that we are machining will pertain to the perfect form size without any undulation if it's going to be in the maximum material condition or in the regardless of feature size condition. So always we need to consider the manufacturing processes that we have in hand and use these modifiers diligently to ensure that the form, fit and function of the feature gets satisfied. So finally, putting all these whatever we've seen together in the GD&T encoded drawing is your feature control frame, wherein it has different compartments. So the first compartment is the geometric characteristics symbol that we have, either a form tolerancing or orientation tolerancing or a profile tolerancing. So that symbol is drawn first, followed which the tolerance zone descriptor, so that is where does it applies to. So for example, this tolerance, the true position tolerance applies to the diameter of the feature, and followed which what is the tolerance of that location. So here that tolerance is specified, the tolerance zone is specified, followed which the modifier is added. So here we have given the material condition. So it is the maximum material condition or the minimum material condition or the tangent in plane or the unequal tolerance zone. So all those modifier symbols are then placed in this compartment. So next we have compartment based on the requirement. Those are all filled with the primary, secondary and tertiary data planes. So if we have only the primary datum reference, then we can restrict with this compartment itself, or if we go on for other compartment references, then you can add into it. So this is what consolidates all the GD&T symbols, modifiers and applications that will control the overall tolerance of the feature. Finally, what we've seen is we can insert this GD&T tolerance using this feature frame reference. So what we can do in the AutoCAD environment is that we can call upon using the tolerance command. So before that, for ease of understanding, let us just construct a rectangular element. So consider this to be the cross section of a circular shaft. So in that manner, so let us apply a tolerance to this surface. So towards this, we can invoke this by using the tolerance command TOL, followed with we get this dialog box for the geometric tolerance. So here you can see the various compartments that are available to it. The first is the symbol, this GD&T symbol. If we click on this bottom, then you can get all the form, location, runout, and the profile tolerances along with the orientation. So we have all the symbols listed here. Based on requirement, on clicking it, it will get inserted. Next is the tolerance zone specification. So here we have a prefix as well as a suffix. So this text box calls in for the numerical value of the tolerance considering 0.001, and in prefix we can add whether the dimension control symbol is applied to this or not. So clicking on this will enable the diameter control. So as is the position tolerance, then you can use it here, or if it's not required for in other tolerance cases, then you can remove this. So we'll keep this one here. So but right now we are just looking to the flatness, so we are not looking for the position here. So for this tolerance of straightness with 0.001, and then this applies to the which material condition. So consider this to be the maximum material condition. So AutoCAD also refers to the regardless of feature size as material S, but by definition and by latest updates, we do not require to have any symbolic representation for that. So hence you can just go with either the maximum or least, or leave it as it is for regardless of feature size. So assuming let's go for the maximum material condition. Then also we have one more tolerance that we can take it for the unequal tolerance zone conditions, but currently let us not go with it. And next we have the datum reference features plane that can be called upon. So here you can type in the datum reference planes. So suppose we have the datum reference plane A, and additionally the modifiers can be applied to this specific datum. So we have applied this maximum material condition to this datum. So apart from that, we also have this projected tolerance zone available. So this projected tolerance zone contains the symbol of that along with the height and datum identifier. So this height creates a projected tolerance zone value in the feature control frame, and it controls the variation in height of the extended portion of a fixed perpendicular part, and thereby refining the tolerance that is specified to the position tolerance. So this is what is controlled by the height for this projected tolerance. Next, for this projected tolerance, what is going to be the datum identifying symbol. So this is the projected tolerance range, wherein this is your normal feature reference. So just for clarity, we'll just put out a value here to see how it acts upon. So now the next requirement is to position where the tolerance location needs to be held. So here you can see that the feature control frame is neatly positioned with the GD&T symbol, the tolerance zone, the material condition, and the reference zone, as well as here we also have a projected tolerance zone condition with its reference plane. So this is the representation of the tolerance zone, feature frame referencing in here. Feature control. So one more thing is that you can individually apply the leader to this dimension annotation text of tolerance. Alternatively, we can also do the same by using the leader command, invoking the leader. So suppose let's say specifying this point and for this angle, and now we can select the annotation, and in type of the annotation, when clicking on enter, we'll go for the options, and here we can select the tolerance option. So now this again calls for the geometric tolerance input box, wherein you can specify this your conditions so that will get applied onto here with the leader. So this is how the tolerance feature control frame with leader and such is applicated onto your AutoCAD drawing. So welcome to week 8 of this AutoCAD course. So this week we'll focus on various productivity enhancement techniques that AutoCAD allows us to accelerate our drafting process and also to reduce the repetitive action times. So until last week we had looked at different quality assurance techniques, that is GD&T techniques. So now we'll focus on the productivity enhancement techniques. So here this week we'll look into concept of filters to quickly select what is of interest to us, doing different modifications on that. And next we'll see an important concept. We'll dwell a lot into the blocks settings. So we'll look into geometric constraints, dimension constraints that can be applied to the blocks. Then also we'll evaluate what are dynamic blocks all about and how we can manipulate the different actions and parameters to use the same block to serve differently in different instances. So that we'll look into one by one in detail, and also we'll look into functionality called as an attribute definitions to assign certain tags to the block so that it is easily readable and can be easily manipulated based on the requirements. So we'll also look into one more functionality called as a layers. So that will be used to manipulate the drawings in different manners based on the selection parameters. So using these techniques we can enhance the productivity of our drawing, that is to remove the repetitive elements or apply a bulk editing option to certain parameters, certain elements in the drawing without affecting others. So these are the various productivity enhancement techniques that we will be covering this week. And also we'll look into the various shortcuts that are available in AutoCAD. So far we had seen a lot of shortcuts that we have looked into, but here we also have one key shortcuts or toggle keys or alphabetical shortcuts to the different commands so that we can quickly invoke them and work upon. So first of the productivity techniques we are going to look at is the filter command. So before looking into this filter, let's see what are the various requirements we have to select the different objects. So if you could recollect, we had this quick select option that we looked into earlier. So quickly select a component that is of a requirement to us. So we'll quickly look into that command. So what we have to do is we have to type in Q-select. So we'll get this Q-select and we'll get this dialog box. So wherein we apply to this entire drawing or to this different layers that we want to specify, and within that drawing what type of object that needs to be selected. So that is selected by this thing. So typically based on your drawing, the basic objects that are already listed will be here. So it means that this quick select only lists all the objects that are already available in your drawing. So based on that you can make your selection, and based on the selection object type then you have the different options to look into. For each and every properties then you can filter it or select it rather. So suppose if you select the arc, and you can select based on the arc length or the area or based on the different requirements you can go about. So suppose if you go for a multi-leader line, then again you can go to which type it is, whether you make the decision based on the arrowhead size or the leader extension line, or so these kind of individual property based selection is what you do it here. So next what we have here is the operators. So in operators what we can see is based on the selection of the object type and the property, whether it equals to the value or not equal, or based on all the types that are selected. It means that once you go for the select all, it selects all the multi-leaders that are within the drawing, and again it selects like where to apply to, whether it should be included in the new selection state or exclude from the existing selected type. So this, for example, if you once you do it and click on OK, you can see that all the multi-leaders from the drawing alone have been selected. So this is your Q select option that you first looked into for selecting the similar objects that are of interest for us. Suppose if you want to vary the properties together, then instead of selecting one by one in the drawing, based on that property, you have selected using this Q select option. Other way of doing is, you can select the object of interest, right click it, and then use the select similar option that is available. So when you use the select similar object, all the objects that are similar to the selected function get selected. Suppose if you select this rectangular object and then giving quick select, you can see that none of the objects, because it has to select based on the object type. If you select the dimension line and then click on select similar, you can see all the linear dimensions alone have got selected. The arc-weld dimension, the leaders are not selected. So this is also one method of doing it. But rather a faster way of doing it is what is the filter command. So in filter, what you do is, based on the conditions that you have, you can filter out the elements as a grouped command. In this command, it's going to create a list of requirements, all the conditions that an object must meet so as to get included in the selection set. So this filter is going to be extremely useful when you are going to select a set of objects that are going to share one or more common properties. Because earlier in this Q select, what we see is you selecting based on a single property alone, but whereas in filter you can make a combination of those parameters. For example, suppose you can drawing object, you can select the dimensions as well as the object together. Suppose if the object, that is, if you have to select all the circles in an object that is less than 5 mm in radius, and select all the linear dimensions and select all the arc-weld dimensions, that you can do through your filter. That is, you are using multi-set of parameters into a single command. So this is the application of your filter command. So in order to use that filter command, you can invoke it by typing in FI or filter. So once you do on that, you get the object selection filter dialog box. So we'll quickly look into what are the key features in this dialog box. So here you have a list. Currently that list is empty. So in order to occupy the list, the first option what we have is to select the type of filter that you need to do. So here you can see what are the different properties or the object behavior that we have that can be selected from here. And towards the back end of this, we also have different operators that are available. These are all called the Boolean operators, and here we have the Boolean operators of AND, OR, and NOT, and also exclusive OR. So these 4 Boolean operators are prefixed with this some command called as a begin and an end. So we look into that command separately. So now, based on the object type, suppose we were discussing about the dimension. Suppose let's look into the dimension alone. So we have selected this filter, and now we can see that none of the other options get highlighted, because for this filter type, it is straight to the point. So that then you can click on the add to list to add this object selection type to the dimension onto the filter list. This is one way. Or add based on the selected objects, you can pre-populate this command. So before selecting the object, we just look at one more link. Suppose if you go for a line type, then you can select the line type that you want to do. You can select the line type by block definition or by layer definition, or based on the predefined lines that we have with the system. Suppose if you go for a shape, or rather let's go for a point. Or a line. So based on this, you can add in so whatever features that you want to do. This line is, when you do this, it just applies a single command to this. We're just selecting a single line. Alternatively, you can also select an object and then include in it. So in that case, you can add selected object. So once we click on that, the dialog box is going to get temporarily hidden. And suppose if you want to add this arcwell element, so now all the properties associated with that get aligned here. You can see that the object line was the command that we had entered, but based on the selection of that curve arc property, so that object equal to arc is listed, and all the other parameters, that is the arc is from the layer 0, line type has been selected by layer, then the arc center point, x, y and z coordinates have been picked from there, and arc radius. So this denotes the object that we have selected. All the properties corresponding to that object has been selected. So this is what mean by the selection of the filter view. So next what we have is, you can edit the items that are displayed in this list, or delete them, or clear the entire list. So suppose if you do not want to have this, you can click on this edit and say that the z-axis should be 2. Then that will get substituted here. So you can see that the z equal to 1 has been substituted by z equal to 2. So that is how you modify the items here. And next we can save the filters that we have based on this group. Suppose let us say it is a filter 1. So now all the parameters here will be saved as filter 1, so that at any point of time we can refer to this named filters and then execute the filter command together. So this will be very useful for you if you create certain named filters and that you can cross applicate for each and every drawing you have. That is, you can create filters based on the dimensions, or based on the colors, or based on the text properties, so that you can categorize them. So by categorizing them, it will be helpful for you to do the layer based separations that we look subsequently. So this is how we have created this filter layer. In order to apply this filter, then you have to click on the apply feature. And now AutoCAD refers to select the objects within which the filter needs to be applied. And right now we have to apply it to the full object, and then select all the objects that have a dimension property and with arc. So if you use the selection method and do it, you can see that none of the object is getting selected. Let's look into why so. So let us invoke this filter again, and you can see that there are two objects that are called for with different properties. So AutoCAD typically what it does is, it applies an AND operation by default to all the object filter that is applied. It means that it is looking for a dimension and an arc with all these properties. So we do not have an object of that sort here. So that's why it's not getting selected. In order to quickly see like how it can be applied, let us remove the other features except for dimension. Now you can see, now the present object selection criteria is only the dimension. So in that case, let us click on apply again, and now select the entire drawing. Now we can see all the dimensions pertaining to this selection area has been selected. So this is the application of your filter property. So after applying filter, you have to select the objects upon which the current filter has to be used. So this is how the difference between your Q-select and the filter is going to act. In Q-select, you can apply where the filter is going to act on, or in select similar, you can again go for the same manner. But here, you have to select the objects again where you have to apply the filter. So this is the direct method of executing a filter. So we also looked at when more than one condition is added, AutoCAD by default assumes an AND operation to it. So let us see a variation to it. So assuming you want to select the single leader as well as the multi-leader along with this dimension, other dimension that we have, then we can invoke this filter command again. Now let us add those commands. So towards it, what we are going to do is, we are going to add an OR operand. So now let us look into the operands, logical operators one by one. So we have four logical operations. We have AND, OR, NOT, and exclusive OR. So when we are going to use the logical operators, typically the command starts with the starting operator and then you enter on the operands, that is you give out the conditions and then close it out with the ending operator. Suppose if we look at all the text with a text height of 2.5, then how we can do is, so start off with the AND operator. So begin and then click on the next line and now insert the text object, add to list, and then click on the next line, because suppose if you keep on the same line object, then it will be inserted at this point. So you have to give care how is the order of text that is going to be placed. So the text height of 2.5 and then finally we can close it out with the end AND. So what it does is, the command goes like this: a text of object and a text of height 2.5 will be filtered. So this is similar to your block operation, that is you can consider that there is an open braces here and close brace here, that is indicated by your begin and end. So within which individual lines of this filter commands are appended using your AND command. So once you click on apply and then go on to select your objects. So now if there are any text with those height will get selected. So let us create one dummy text to figure it out. So text height of 2.5 and angle of 0. So let's say sample text. So now let us run filter again. So now you can see this has been highlighted because here this satisfies both the conditions of the text as well as the text height. Suppose if you want to go for multi conditions, that is we select all kinds of radius dimensions, that is we want to have an arcual dimension. So you can look at here, we have to have the dimension, a leader and multi-leader. So in that condition, let's look into how we can do it. So instead of AND, we need to replace by an OR operation, because at either one condition is true, then we have to include that in our selection list. So we'll go by this. So we'll select the dimension and then the object of multi-leader and then also the leader, and then close it out with the OR command. So now you can see that the OR operation is applied to the all the dimensions, the leader lines and the multi-leader line. So this is how you execute your filter command. So the other application of the filter you have to be very clear of is that this filter does not work directly with the color condition. Suppose if you want to select the filter of all the red color objects or blue color, so when red color is going to get assigned with your filter command, it does not select through. That is, you assign by this color and then assign the variation. Suppose if you go for the number, say red, so in that case we cannot do it, but rather what we can do is by only either through the layer. So by layer command, okay, cannot directly substitute by that, but if you give on it here, then it would not get selected, but rather you have to get select by the layers only. So here let us say let us modify the properties to the direct command. Okay, so now let us try running this filter properties. Without all this, only this is red. Now it has got selected, but in some cases it is not going to get selected. Then when you set the filter condition by the layer, then it will it's likely to select all the layers. Suppose if it's not working, then you can go by the layer commands to filter it out. So that we look in the next chapter. But typically now we have seen how we can use the filter command and using different combination of operators to select the objects of interest to us, upon which we can perform group edit or group modification options. So next we look into one of the most powerful productivity tools in AutoCAD, that is blocks. So this blocks is something where you group together different objects at various places in the drawing. For example, if you take a mechanical component, that is if you refer to a bolt or a nut, so it has a common terminologies or application, that is each and every bolt is going to be defined by its major diameter and such. So the basic definition is going to be that, and based on that you can have different varieties of it, but these are all dimensions are all standardized using various norms. So this blocks will help us to create one such set of the basic definition of the bolt or nut and then save it for future use. So to put it back together, a block is a collection of objects that we can associate together to form a single object. So this block, what we can do is we can insert, scale it or rotate based on the requirement in the drawing. Also, we can explode a block, that is we can break a block into its constituent objects, then modify them and then put them back together as a new block. So these are all the different features that we can do in the command. So once we have modified an existing block, wherever this block has been called for in the drawing, AutoCAD will replace everything else of it. So this block conceptually will help us to streamline the drawing process. That is, where and all we can use this blocks is to build a standard library of frequently used symbols, components or standard parts. We can insert the same block any number of times instead of recreating the elements one by one. And next, to revise the drawings effectively by inserting, relocating and copying blocks as components rather than individual geometric objects. Also, we can save the disk space, that is the size of the drawing, by storing all the references to the same block as one block definition in the drawing database. We need not create different instances. We can save it as a single block definition. So that every time when we are creating a block or inserting it, a new instance is created. And then for every such block instance, we can scale it, zoom and rotate it. So these are the major functionality of blocks. So that we'll look into step by step now. So the first thing is where you can see in this block is that in your home ribbon, we have this block title where we have this insert block, and then we have this create a block, edit a block, and then edit the attributes that are pertaining to a single block definition. And subsequently we also have the definition of the attributes that we look into. That is, we'll categorize the key features of this block so that can also be showcased in the drawing. So once you define the attributes, you can manage it, and then we can synchronize based on the latest updates, and then we can retain the block attribute definition. And finally, where the base point of the block should be, or the drawing should be, so that from there we can insert the external reference or the blocks with respect to that base point. So this is your universal base point. So this is called from the block from the home ribbon table. Alternatively, in the draw command and in block, you can create a block or insert. Also we have this block palette. So here we have a list of blocks that are already created and how we can push in or modify it. So this is your block palette. So these are the different ways from which you can approach a block. So towards it, first let us create a base component. So what we can do is, we assume that we have to create a block that defines a hexagonal nut. So towards this, you create a polygon, okay, so with the size of 6, and say the center is going to be here, and it is inscribed in a circle. Suppose the radius of the circle is say 8. So these are arbitrary dimensions. Let us just start off with this. So now we have got the polygon here, and now to first the object will be simply chamfered along the edges. So the representation will go by this. So towards this, we'll just plot the geometric center and then draw a circle, because once you chamfer it out, this is how it will be viewed from the top angle. So next we have to draw the internal hole, the threaded hole. So let us draw with a diameter of say 8 mm. So this is some random dimension just to show you out. And then there is going to be an internal pitch, that is a threaded element. So in order to represent that, if this circle is considered as an internal element, then 0.85 times of this 8 mm will be the external hole. So that would be the diameter of 0.85 times of 8 mm would be 6.8. So typically this outer circle is your internal thread. So if you recollect the drawing that we had in week 2, so we'll use a similar command. We'll use the break command. So we'll specify the break. Or something like this. So now this is how you have drawn a hexagonal nut. Okay. So now instead of creating every new instances or just copying or rotating all the things, right now we'll save this hexagonal nut as a individual block. So towards this, we have to invoke the block command, the create block command diagram. So one way is we can go using this definition here, create a block definition. Alternatively, we can call using this command block. So this is the block definition dialog box. So first and foremost, you can type in the name of the block that you are going to create. So let's put in a hex nut. And next we have 3 different columns. The first one is the base point, specifying the base point of the drawing. Either we can specify it on screen, or we can pick the point. So when we specify on the screen, then we can middle, or right now let us use the pick point. Say this is going to be the insertion base point for this block. So that has been defined. And next at the settings, what is the basic unit definition of this block? Because suppose it can be any one of this, but your overall drawing can be of different unit setting. So in order to merge those two, then we refer this unit mentioning here, so that we can later refer to what unit was just created and how it has to be scaled or retained. So next we have this object definition. So either we can specify on the screen or we can go by the select objects. So the specify on screen command, what it does is once we close the object box is one where it will prompt for selection of it. But let us retain the same dialog box and then go for the select objects. So now we have to select this object whatever we have to do. So this is the hexagonal nut with a chamfered shape. So we have an outer circle and an inner circle and one representation denoting the pitch. So these are all the objects of reference to us. Once all have been selected, click on enter. So now you can see that 4 objects has been selected. Alternatively, you can also use this quick select option. Instead of selecting from the screen, we can use the Q select option to select all the parameters that satisfy to the quick select command. So once it's done there, the command has been resetted. So let us go it again. Yeah. So now you can see that 4 objects have been selected. Next we have option what to do with this original element. If we go on to retain, then once this block has been created, this original object will be still stored as individual objects only. That means that the block will be created, but still each and every element will be individual and they won't be associated with the block element. Whereas if we use the convert to block, then all the selected objects will be converted to a single block object. And if you use a delete object, it means that once this object has been created and then stored in the memory of the block, this original drawing will be removed from the base drawing. That is, it will be deleted. So this is your option for the specification of the objects. Next, we have the behavior of the block. So first command is your annotated command. As previous, this will annotate the object, and once you select this, you can also have an option to match the block orientation to the layout, so that in the paper space viewports, whenever we call for it, that and the orientation of this block will get aligned. So this will get highlighted only when the annotative option is selected. Next we have 2 options, whether to scale uniformly or not. So when you select it, the block reference will be allowed to scale only uniformly in all the direction and not ununiform. Also, we have one more option to allow the exploding. That is, this basic block definition will allow the block objects to be broken into its constituent elements. If this is not selected, then we can't break down the individual elements. So this is the exploding command that can be applied to the block or not. So next we have a general description. So always it's better to put in a description that will help you in a later stage or your colleagues, that will help to understand what is that block definition all about. So here typically right now you can just say that hex nut of major dia of 8 mm. Okay, so something like this. So I'm just putting a random text here. So click on OK. And there is one more option here. So we have the, if we click on that, once we click on OK, it will open the block editor object. So now you can see that we have invoked the block editor object, and now we can vary the block properties in it, certain constraints, certain different parameters, all those things, so that we'll look into the later stage. But by this we can use the block editor object in the creation of the block itself. So thereby now we have created a block. So once you click on insert here, you can see that in recent block it has listed out this image. There is a snapshot of this image that has been stored. So we can click this out, and now you can see that this entire object is now referred to as a single block, and you can specify the insertion point at anywhere. Now you can see that the base of the insertion point has been selected with the base that we have mentioned in the during creation of this object. So this is how you insert a block. So this insert we have created using this insertion command. So you can also insert this block by in the insert tab we have this insert block command, or in this block we have the same insert block. So now we can insert the block using this insert command in the home button. So that can also be called by the command insert. So once you click on insert, you will get the palette here, and it will show what is the recent blocks that are available for you. And also we have a dynamic input option. So to specify the insertion options, so we can specify either by the insertion point, also we can specify what scale it has to be, and specify the rotation, and if there has to be a repeat of the placement, then we can use this and explode command. So we'll look into one by one now. So typically the insertion point we are seeing with this the direct insert command here. So next, if you specify the scale, and next again rotation angle. So in scale, let us say in x-axis it has to be 0.25, and y and z let it be the same, and rotation by 45 degrees. So now we can see that based on that definition, now it has been inserted, and we can also specify the scale, because as we have selected the scale point there, we can specify the scaling dynamically. So if we put it at 0.25, now the next option is to rotate it. So by selecting the tick mark, you can specify the requirement directly at this point. Or if you do not wish to say, and if you want to put it globally here, then you have to update this requirement in this angle. So suppose if this is your point, then you can see that the scaling has been done once and rotation has been done in 60 degrees. So let us again maybe modify this 0.25 with 70 degree angle. Now you can see the same. So this is how you can vary the insertion options by either a dynamic or a preset command. Next, by selecting this repeat placement, you can place multi copies of the same block. And then if you click on explode, it means that the latest object that you are going to place. So now these two objects, now you can see that the block elements has been dissociated into its original compounds, whereas the previous blocks that we have inserted will be a singular element. So this is a explode command that we are using. So if you could recollect, as the object is already a uniform scale based on our definition, we have the same command only, so that we can't specify ununiform scaling. So this is about the insertion of the blocks that are being used. So now we have seen how the blocks were created and how they are inserted. So next, what we have to see is the W block command. So this W block is nothing but write the block to a separate drawing. So here the first thing is that we can specify the source of block. So now you can see that the hex nut whatever we created is available as a block. Or we can also save the entire drawing as a block, or select again. See, this is what was available in your create block command. So you can use this write block to dynamically create a new block definition and then store it out. So let us retain with our same source, that is this hex nut, so that all others are disabled because it is already available in the temporary library. So now we can save this as a separate block command. So it is now saved as a hex nut. So now we can specify the option here, the file name and the path. Now you can see that it is going to be saved as AutoCAD drawing itself. So now if you click on OK, now it has been generated as a individual block. So now you can look for blocks from other drawing, and if you click on that, you can see that that drawing is called as for an entire block. So now we can again go for this insert command. Okay, so as we are using this redefine option, now we can see that that drawing itself has been called for as a new block definition. So this is how this write block command is used to write all or the part of a drawing to a new file, so that you can utilize that from the subsequent applications of the block. So next to this block we have this dynamic block, but to understand dynamic blocks, the application better, let us look to one area called as a constraint. So this constraint, what typically it means is you are specifying a relationship between the two or more objects. So to put it in simple terms, imagine the opening and closing of a door. You can see that the motion of the door element is constrained by the axis where you have the latches. So that's how the door is constrained. It cannot go up, it cannot go down, it cannot rotate, but unless otherwise only the axis of the door latches, right? So this is what mean to say that the door has been rotationally constrained with that axis only, and it is not allowed to move in any other axis. So this is an example of constraining the motion. So likewise, we can also give constraints between the objects that are placed into our drawing to ensure that by mistake for any dissociated object, this is a dissociated object and I should not be able to change the shape or modify the relationship. Suppose this, I should not be able to make it like this. It means that this is a chamfer element of this nut. So in that case, it should always be tangential to this border. So this is one type of constraint. So let us see how we can affect this constraint without manually adjusting it. So this is called as a geometric constraint between any two 2D objects or points in an object. So typical examples for geometric constraints is applying a relationship between every endpoint so that they remain coincident with the endpoint of every adjacent object. And next, vertical lines can be constrained as parallel, and then again two lines can be made tangential, or two circles can be made concentric. So those kind of constraints that we have seen earlier also can be applied to here. So let's look into one by one. So our object of interest is this. Okay, so let us remove them all and then click a new object with no rotation, with only one angle. Okay, so this is our object. Now as we had used the explode command, you can see that the objects are individually placed to each other. So this constraint can be clicked by using this. So in order to apply constraints, that you can view in the parametric tab that is available here. So you can see here is the different types of constraints, geometry constraints and then dimension constraints that are available. So we'll just start off with the first one, the geometry constraints. The first feature is the auto constraint, that is based on the given object type itself. When we apply the auto constraint to the object, it will apply the geometry constraints that are already inbuilt into the feature. And next, individually we have these many constraint options. So we have coincident, that is two points will always be coincident to a given point. Then collinear point, that is two lines should always lie on the same infinite line plane. Then we have the concentric. Then this is called a fixed constraint. So it means that we are fixing the all three modes of translation along x, y, z. We do not allow any motion, because in concentric it means that the dia can be different, but only thing is that the all the circles selected should have a common center point. Whereas the collinear also can make sure that the lines can move along the collinear line and it can be positioned anywhere. But this fix, what it does is it frees all degrees of freedom of this object. So next we have the parallel line, the perpendicular. Then we also have this horizontal constraint and vertical constraint. Then a tangent, a smooth constraint. So this is for a spline element. And next we have a symmetric constraint. Then an equal constraint. So these are the various geometric constraints that are available. So typically what we need to say is this inner circle, outer circle and this pitch circle should always be in concentric relation to each other with respect to this center circle. Next, this outer circle should be tangential to all the points. And next, the dimensional size of this hex nut, this faces should always be equal. And next, and in order to reference to all these things, we can fix this center circle as a fixed element, so that this, with respect to this reference, all other dimensions are applied. So this is the typical constraint that we need to set up. So in order to do that, you can click on auto constraint and then select all the objects that we are interested. We can also go for the settings in constraint. Here you can see that we have geometric dimension constraint. We have all the parameters that were looked into here, and we also have the constraint bar, the transparency, that is which displays the constraints bar. And next, similarly, we have the dimensional relationship as the constraint that we look into next. But right now, what we are seeing in auto constraint is that based on all the constraint properties, what are the priorities that are assigned to it? So we can modify that priority. So it means that the coincident is the highest priority, equal is the lowest priority. And then also we can specify the tolerances within which the constraint needs to be applied. We have two tolerances here. One, the distance between the objects. Second is the angle between the objects. So by this we can specify the auto constraint option with it. Alternatively, we can also upgrade or downgrade the priorities based on our requirement. So let's say the concentric should be the highest priority, and then the tangential should be the second highest priority. And next, equal side, we'll also apply that. Okay, so yeah, so with this we can try and close it. So when you click on OK, you can see that the constraints have already been applied to it. So this is what meant by transparency. That is 50% the constraint visibility is transparent. So right now you can see that all the selected constraints and all the applicable constraints have been applicated. So if you just hover on the object, you can see that now this circle is concentric with this central reference point. Likewise, these two circles are concentric to each other. Okay, so this refers to the first circle and this refers to the second circle, followed which we have the outer circle that is again constrained with the inner circle. So next we have tangential constraints for all the points, and next we have parallel constraints that are applied to opposite points, and also equal constraints applied to the dimensional edges. So this is how you apply the constraints. So what's happening here is, once you have applied the constraints, okay, so suppose let's take this, and if you try to modify this, you can see that it just executes the move command, but rather it doesn't, you know, vary the options to it. So why? Because as the constraints are already specified, we are not able to override the dimension. Suppose if we want to move it out, you can see that I'm not able to move the circle, and whenever I move the circle, then the resultant object is a object that satisfies all the given constraints, so that the tangential, equal and parallel constraints are getting satisfied along with the parallel concentric constraint. But this again, you can see that this would not be the requirement of the hex nut. So what we need to do is, we also need to set a constraint between how this dimension can vary, and with reference to this dimension of the circle or the side, we also need to vary the inner circle or the pitch dimension. So that is where we apply the dimensional constraint. So in dimension control, what we are doing is, we are controlling the geometry using mathematical expressions that will include the names of the dimensional constraint, user variables and also functions. So with this dimension constraint that you can observe in the parameter tab, we have different dimension constraints that can be applied. We have the linear dimension, align dimension, angular dimension, radius and diameter, and also we have an option to convert, this symbol is used to convert the existing dimension into a dimensional constraint. So one thing that you have to note is that when you apply a dimension constraint onto an already constrained object, then you might get an error stating that it's going to get over constrained. So for example, if we want to apply this linear constraint for this point, you can see that the AutoCAD throws out an error stating that the current dimension constraint that we'll be applying will be over constraining the geometry. Why? Because we already have other constraints that are applying here. So we can also remove whichever is not applicable to us, or that is, we can create a reference dimension. So the reference dimension is going to be driven dimension, that is, it's not going to modify the object in any way, but it's just used in an expression to control other terms. So it does not constrain the geometry of the object, but that is not intended to us. So for that, let us just remove these dimensions. We'll remove all the dimensions that are linked to it with this thing. You can either click in by this into mark, or right click and then click on delete. So these two ways are how you can eliminate the constraints, because earlier we had used auto constraint. So let us now remove everything and then create dimension constraint as well as geometry constraint that are of clear to you. So first thing is, like, we'll go on with the dimension constraint, that is, we are applicating the edge of this hexagonal nut. This is going to be the first dimension. So this D is going to be the nominal diameter of this bolt. So let us just name this as the as a geometry constraint here. So yeah, so let it be here. Then we can modify it. We can modify it in the parameters manager. But right now, this is the first dimension. So next, we are going to constrain this dimension of the circle, and followed with by the dimension that represents the pitch. So having said that, next we need to correlate. Using this, we can correlate the dimensions. So now we'll apply the equal constraint to all the dimensions, so that whatever this nominal that we have set will get applicated to the all other objects also. So we are going to apply this equal constraint. So now we are doing the manual route. So it means that this polygon shape will be controlled with respect to this dimension. So next we have to constrain this circle. So wherever this dimension is going to update and this polygon is going to update. This circle that represents the chamfer cut needs to get aligned for all. So we have to assign tangent restriction to all the contact points, that is all the edges of the polygon. So the difference between this and the auto constraint is that we are applying the dimensions only that is of critical use to us. So you can see it already shows that it is getting over constrained here. So let us not give that. So next, finally, we have to give a concentric dimension control. So with respect to the inner circle, we will assign these two, and then again with respect to this and this outer circle. So thereby given all the constraints that are required. Now let us look into the parameters manager. So here we have different tabs or the columns that describes the parameters. You can add or delete it by right clicking on here. Right now all of them are selected. So we have the name, expression, then the value that is already there, the type of the dimension constraint, and then description if required. So here you can see that we have D1, dia 1 and dia 2 that are constrained. So you can rename it. So this D1 is going to be the nominal diameter represented by D. And the second dimension, this is dia 2, that is going to be the pitch. It also phenomenologically going to be equal as the same diameter. Sorry, let it be D1. But here what we want to do is we have to keep it equal to D. So it means that D1, that expression is D, so that whatever value we have it here will get reflected here. So simultaneously this diameter, let us name it as D2, this should be 0.85 times of D. So now these are the expressions that we are controlling, that is these are derived dimension based on this base dimension. D1 and D2 are derived based on this base nominal diameter D. So this is how we parameterize the dimensions. Now let us close this out. So now let us see how we can use this. So let me just copy and paste it here. Okay, so now let us see how it goes to vary here. So say let us go for a approximate nominal dimension of 12. So you can see that now this hexagonal nut has got updated accordingly. So all the dimensions that we have here based on the geometric constraints as well as the dynamic constraints have been applicated, and the same has been updated. That is, this diameter and this diameter is going to be the same, whereas this diameter is 0.85 times of this diameter. So this is how you use the dimension constraint and also the parameters manager to apply the different variations. As you can see here, the parameters manager now has got updated with the columns that you have here. So here it has got updated that this D3 dimension is equal to D5 and this D5 is the base dimension, that is D. Okay, so it has the numbering has been made based on the previous dimension that are available. If you could recollect, the base was D and we had selected D1 and D2 to represent the other dimensions, and AutoCAD subsequently allocates the next dimension numbering as a sequential numbering, but all the parameters that are already constrained get applied to this. So this is how you can use the dimension constraint to use it and then save it in the drawing, so that you can modify the drawing based on the different requirements that you have. So this summarizes the dimension constraint that you can apply onto your drawing.
So once you have defined your block, the next step is to write it to a file so that you can reuse it later. So that function is called as a W block, that is, write the block to a file. So the selection of the block is either through the already a referenced block that you have created, or you can store the entire drawing as a separate block, or select the objects as you do in the creation of a block object. So you have similar coordinates here. You have to select the base point, and then the next step is to select the objects and to either retain or convert to block or delete from the drawings. And then finally, the destination address where it has to get stored. So this is how you write a block. So suppose we'll take a block, the hex nut, and then store it as a drawing here. Okay, and then also specify the units to it. Always make sure that you have the correct unit specified, because this reference is later used for you in order to scale the block as required based on the drawing that you have. So based on that, you can click on OK to create a drawing. So here now the block has been written to a separate file so that you can refer it outside this current drawing. That is, if you open up a new drawing, you can still refer to the existing block that has already been created and work upon. So that is the W block function. So next we'll quickly look into how this block, what we have constituted, is going to help us in modifying the text. We had seen already the dimension constraints that will help us to modify the block properties. Okay, so let us look into one more again and look into what is that constraint it talks about. So if we try and insert the block now, so you can see this is the hexagonal nut that we have created. Okay, so even though the reference of this object is the same as here, you can see that you don't have the flexibility to edit the dimension references that you had. And also if you update the dimension references, so what happens is all the block references, that is all the blocks in this drawing that bears the same name, will get updated when you modify this drawing dimension. So in order to avoid that, we have one feature called as a dynamic block settings. So here we can modify the block dynamically using certain key parameters that we wish to look. So we'll go ahead and do it. So what we'll do is we'll edit the block that we have here. So in order to edit the block, we have the block edit command. So it's either bedit or be. So once you do that, it asks for the block that we need to modify it, or you can also create a new block and then edit it. So now the objective step, we have to modify this block so that we are creating a dynamic block reference here. So we select this hex nut and go ahead. Now you can see that we still have the block editor object that we had seen during creation of the block, but with an extension of commands that is available. And we also have a floating palette that is available. This is a block editing palette. So we'll quickly look into what are the different options that are available in this block editor. It's also a specific dynamic ribbon that is open up only during edition of this command. So what we have here is we have the edit block command and then also save the block definition to a file. Then we can also test the block before execution so that it will open the test block on a separate window so that we can see how it looks and how the dynamic commands that we have given will look like. We can do all the variations. Next we have two of the previous use reference, that is we have the geometric references and the dimensional constraints, geometric and dimensional constraints, and also we have one more thing called as a block table. So here we'll define the properties of the parameters that we are looking into. This will create the dynamic input to it. So we'll look into it very detailedly. So next we already had this parameters managers looked at, and additionally we have the authoring palettes that we have, and then we also have one more powerful functionality called as an action parameters. So the action parameter defines how the geometry of the dynamic block reference is going to move or change when the block is modified, so that we can add the actions. Okay, so we have different actions. Those can be assigned to blocks wherein we must associate them with the parameter and the geometry. So this is what the action parameters look like. So we'll look into that in detail. And then also we have the attribute definitions. So this attribute definition is used to specify the properties of the attribute and the prompts that should be displayed when the block is inserted. So it means that it's a label or a tag that's going to get attached itself to the block. So it's a data set that will attach to the block. So that what we can do is we can give additional info to the block. We can assign part numbers or the component specs or prices or comments or what is the creator name, all those things. Those references can be inserted along with this block that is created. So this is the attributes that you are assigning to a given block. So that these can be used as information that can be used to cross-reference, example, your bill of materials and so on and so forth. And also these attributes are only visible for information during your editing or drawing operation, and during plotting it won't be visible, that is, it is invisible to your plotting operation. However, these information is going to store in the file, so we'll look into it again in detail. So next, finally, we have another important functionality that we can use it to our flexibility. That is, we can create visibility states. That is, based on the selection criteria, we can either make block object visible or not. So we look this with an example to get it more clarified. So just put it together. All the functions that we have is here is the block editor is going to be a contextual tab. That is only when we are going into the block editor command, it will open up. And we have the special ribbon wherein we have an option to provide the constraints. We have option to give the parameters. We have options to give an action specified, define the attributes, then manage the visibility states, and also save the block definition. So this is the overview of the block editor that we use to create dynamic blocks. Okay, so now we'll quickly look into what are the different actions that we can do or the functions that we can do to create a dynamic block. So as and always, we have the parameters that we have to define to generate the relations between the object. So even though we had created dynamic constraints earlier, dimension constraints, those are pertaining to the drawing view only. But if you go into the block editor, you can't see those commands. So that you have to create the geometric and the dimension constraints into your block definition. So we'll try and do it again using all the commands that we have. So first thing is like we have to give the equal constraints to all the sides. So having given the equal constraints, so next we also make sure that the sides, the opposite sides of the hexagonal nut are going to be parallel to each other. So in certain cases, you can see that the dimension has been over constrained because with this reference and with this equal signs, the figure gets constrained to each other. So in that case, AutoCAD prompts that the figure is already over constrained. The constraint cannot be applied because it conflicts with an existing constraint. So in that case, we can proceed with the next constraint that we have to do. So the next constraint is constraining these circles, the inner and outer circles, as concentric. So with this, we have applied the basic constraints that we have to look at. So next is we have to apply the dynamic constraints. So we'll go ahead and give the dynamic dimensions here. So we have one linear dimension, and then we have the diameter constraints. Okay, so after applying this, we just have to look into all the constraints that we have already applied and see whether it is possible sufficient. So what we've done is for the sides of the polygon, we have applied equal constraints and also parallel to one of the faces so that the overall structure gets optimized. But then also we have one more constraint we have missed out, That is, we have to make sure that this circle, the outer circle, the chamfer circle is going to get tangent to the sides. So we'll apply that to all the sides. The other way of verifying whether the constraints are sufficient or not is by testing the block, and by varying the parameters you can see whether the constraints are sufficient or you have to assign additional constraints or not. So having said that, having applied all the constraints and having set the dimensions, again we can go into the parameters managers to look into what are the various constraints that we have. So we'll do the same assignment of the constraint as earlier. Yes. So with this, we've applied the constraints to here. So now the next option what we have here is the block table. So this is where we can predefine the the list of options that we have. So once we click on it, it will ask for the position to position the block reference, and next it will also ask how many grips that are need to be placed. So grips are the dynamic editing options. So we are proceeding with a single grip. So we can get the block parameters properties table. So here we'll insert a new properties. So which is the base reference that we need to have. So this D1 is your nominal diameter symbol, the horizontal dimension constraint. So we'll use this. Okay, so here what we can do is we can give a predefined set of parameters. That is, we can say I have the major diameter of 5, 8, 10, 12, 15, and so on and so forth. But let us now consider the 5 major nominal dimensions, and now we can click on OK. So now you can see that the block table reference has been created, and also a dynamic editing grip has been created. So now we can test this block, how it looks like. So when you go ahead and test the block, so here we have the block reference. So now you can select the block, and once selected, you can see that you have a down arrow button that is available here. This is your editing grip. Click on it, you can get the different options that you have. So you can see that the base reference what we created is highlighted with the tick mark to it on the left side, and if you want to modify it, you can see that the object gets modified accordingly, and our constraints are holding good so that these basic reference is withheld. So likewise, what we can do is we can optimize it. But when we go for a lower dimension, you can see that the sides are not getting reduced, but the circles have to get reduced. So it means that our constraints are not sufficient and it's getting rotated. So if we need not have this rotation, give a horizontal constraint to this plane, and also what we can do is we can fix this point so that that reference gets constant, so that with this reference and with this tangential sign we can assign the operation. So now let's test the block again. So now the constraints hold good. So this is how you test the dimension and geometry constraints that you have assigned for various dynamic block references that you have. So this is how you assign the different properties to it. And next we have this attribute definitions. So in this attribute definition, we have different options that you can associate with the block when we are going to insert the block in the drawing. So the first is the invisible setting, so that it specifies that the attribute values are not going to be displayed or printed when we insert the block. So we also have a system variable, that is ATT display, to control this invisible mode. So next we have the constant option. So this gives the attributes a fixed value for block insertions. And next we have verify. So once we selected it, every time it prompts us to verify that the attribute value is correct, so that we can have a checklist kind of thing. So when we insert the block every time. Next we have a preset condition, so that it always sets the attributes to its default value when we insert the block containing a preset attribute. Suppose the preset attribute, say the block reference is going to be of X dimension, that can be set as a preset, and hence every time the block is going to get inserted, only that preset variable will get called upon. So next we have the lock position. So it means that the location of the attribute within the block reference can be locked, and when unlocked, the attribute can be moved relative to the block using the grids that we have. So next we have the multiple lines. So here the attribute value can be specified with containing multiple lines of text. So when this option is selected, we can specify boundary width for the attribute that we are going to define. So next we have the insertion point for the attribute block definition. So that is a given norm. Next we have the attribute definition data. So we have three categories. We have the tag, the prompt, and the default data. So this tag is going to identify each occurrence of an attribute in the drawing. So we can enter the attribute tag using any combination of characters except spaces. So this is going to be the reference, the nameplate to this attribute. So next we have the prompt. So prompt will be displayed when we are going to insert a block. So it means it's a floating definition that helps us to identify the attribute tag that we have. So next is the default value of the attribute that we have to specify. Next we have the text settings. So in text settings, again we can define the justification and the style of the attribute block. So now let us just give the attribute definition as the. So for this material, let us for this component, let us define the tags that are appropriate for it. So this is going to be hexagon and nut. So the tags that can be used can be material, and then the nominal dimension, and then the cost. So let us try and insert these three tags to this block and see how it reflects. So the first tag that we are going to use is the material. So the prompt, what we can give is enter the material of the nut. Okay. So the default material is going to be, say, stainless steel or graded steel. So we'll just give us a rough. This might not be correct, but this is just an idea. Okay, graded steel, and then click on OK. So now AutoCAD prompts us to enter the value, the position of this text attribute. So let's say we are going to paste it here. So this is the first attribute tag. So we'll call upon this second attribute tag again. So now it's going to be the nominal dimension. So there should not be any space between the tag elements. So here we enter the nominal dimension and say the default value is 8 mm, and then click on OK. So the next is the cost of the nut, and say by default it is 50 rupees or so. You can also set this align before previous attribute decision so that it gets aligned automatically instead of inserting it. So now this once it is done, and then click on close block editor, a prompt shows that whether it should be saved to the existing block. So the idea is all the attribute definitions should be linked to this block, and hence yes, save the changes and exit. So now we'll go and insert the block again. So this is the block that we have created. And once we're clicking enter, you can see that the attribute edit option pops up, and you can see that these are the different attributes that we have entered. So these are the prompts, and then what are the values to it is what is displayed here. So suppose if you go ahead with the same default prompt value and then click on OK, you can see that for this hex nut, this is the value that has been displayed. So this, instead of dimensioning or giving out a note, we are linking this block with its default attributes, so that it will help us to edit and associate with the different blocks, the various varieties of the block. We can have different variations but still modify and edit it. So this is the advantage of the attribute definition. So once you double click on this the attribute definition, here again you can see that for each and every attribute, what is the tag, prompt and value, and what block it has associated to it, and what are the textual options, and the again assignment of layer options. So by this we can optimize the view and edit the values of the different blocks. So this is about the attribute definitions. So now just before proceeding to the other block editor functions, you'll also see, suppose if you do not want to display this, then we can go for the attribute display function. So this is a system variable. So with this we can turn on or off the attribute visibility. If you click on off, so the default attributes get hidden. So this is about the attribute display and definition. So let us go back into this block edit. So we had seen the attribute definition function. Now let us see what are the other action parameters that are called for. So we look into the floating tab as well as the action parameters tab and see how it varies. So this constraint we had already covered, and this parameter set is what we are going to look at now. So these parameters will help us to define the custom properties for the block reference. For example, if we are going to add a point parameter or any other parameter of the current dynamic block, then through it we can define different actions on it. So this is all applied to the dynamic block settings, and hence they can be instantly modified as per the requirement using the same block definition. So we have different parameter types. So this is the point type. So when you select the point type, you get a grip as a standard. Once you click in here, you can see this. The position is applied to this point, so that this you can see a square grip applied here. So this is a standard grip. So what are the actions that we can associate it with this is, we can move it or stretch based on this position. That is, we are assigning this point to this block reference so that it can be manipulated for moving or stretching. So likewise, each and every point, every parameter set can be used to add an action to the dynamic block addition. And always we have to associate the action with a parameter, a key point on the parameter on the geometry. So a key point is the point on a parameter that drives its associated action when edited. So it means that this point we have associated to this key position. So this is what is going to control the action of it. So in parameter set, the next is the linear move. So once you click on this linear move, and then suppose we click on here, and then we allow this is the distance that we have keep. So you can see that we have got an arrow option. So with this arrow, we can use it for linear grip movement. That is, we can use this for moving, scaling, stretching, and then also array type. So next here we have the linear array. So what we have done is the move option. Suppose if you want to create an array, then we can set this as the array. So there are two different parameters that we set. One is the linear move and the other is the linear array. So likewise we have the linear stretch pair and then polar move, polar stretch, polar array, polar move array. So this is how we can vary the options. So we have different categories. That is, we have the point category, linear category, polar category. The subcategory will be the move, stretch, array. So based on the different combinations, we can enact the parameters. We'll look into the actions block one by one, and also we have the parameters. So you can see that the parameter sets is a combination of the actions and the parameters. So in parameters, again you have the point, linear, polar, xy coordinate, rotation, flip, visibility, lookup, and the base point. So again in point, it's used to modify it based on move or stretch. Linear, again it can be used to have a global control on the move, scale, stretch or array. Whereas in polar, we can take it in a standard grip type to use it for move, scale, stretch, polar, stretch and array. In XY, again it's a array based one. Here rotation, straightforward rotation and alignment. With this we can modify the alignment parameters to it and then the flipping of it. So now we'll use an example to see the visibility use case, so that might be helpful for us to to apply for different applications. So towards this, let us look into how to create first and third angle project symbols using the visibility parameters. So we'll do one thing. So we'll just draw the first and the second angle parameters. So the first, now let's draw the second using mirror. So now we have drawn the first and the we'll just flip it out. And also we'll draw the center lines. So now we'll move this object and then create an overlap and also we'll move them a little close by. So the idea here is we are going to use either of these images to switch between the first and third angle projections using the visibility command. So that's what we've done. We have duplicated these two images and then overlapped it, and now we're going to create as a separate block so that it can be edited and modified in the block editor. So we'll create a block. So let us consider this as the base point, and entire thing are the objects, and make it annotative. First, third angle projection symbol. That is as a description, and click on OK. So now we have got the editing option here. So now what we are going to do is we're going to use the visibility states in order to assign two visibility states, one for the first angle and second for the third angle. So this visibility state is available here, but in order to make it available, so what we have to do is we have to assign this parameter called as a visibility parameter. So we'll insert this visibility parameter. So let us say that the parameter point, action point, is going to be placed here, and you can see that the visibility point has been inserted. So next you can choose the visibility state option. So here we can insert the visibility states that we want to do. So let us rename the first visibility state as the first angle, and then add a new visibility state as the third angle. So once done, now let us modify it. So now we have selected the first angle as the current state. Now let's select this third angle symbol and then make it invisible. So after selecting these objects, click on this, that is to make them invisible. So you can see that this is going to be the first angle of projection. So likewise, once you select the third angle, now you select the objects that are going to be invisible, that is the first angle of projection symbol should be invisible. So we can save the block and then close the block editor. So upon selecting this symbol, you can see that on this block we have the visibility. So now we can select what is the visibility that we need to do. Okay, so we had left out this inner circle, so let us go and edit it again. So again, in this first angle visibility, this should be invisible. So let us select and make it invisible, and then now in the third angle of projection, this should be invisible. So now we apply the changes and close the block editor. So now you can see that, so this is the first angle projection, and then this is the third angle of projection. So now with this you can quickly insert the different requirements into your block settings directly using the visibility setting. So this is one such example of the dynamic block settings that we can use. So as seen earlier in the dynamic block, we have different options to flip, scale, switch, move, or do an array. All these things can be done using this powerful functionality of the dynamic blocks. So once you have completed all the block settings, block editing, all these things, now you can write this block as a separate drawing files that we have seen earlier. So now this is again a powerful functionality so that we can use it, save it as a separate drawing, and reuse it as many as times that are possible when it's required. So this is about the overall description about the block functionality. So next what we are going to see is the powerful functionality of AutoCAD, that is layers. So layers are heavily useful when you have to group the information in a drawing by either its function or by its characteristics. So that, or the same, this is a 2D drawing. So this is a friction plate slab. So in this drawing, so you can see that there are different types of line properties and info and drawing that are available. So you can store those information in separate layers in the same drawing. So how will it be useful is that you can manipulate the specific layer that you want while you hide out the other. For example, after constructing this drawing and you are passing down this drawing to the next stage of the processing. In that case, suppose if they have to work only on the annotation elements and not on the drawing here, then they can hide this drawing entirely and then look only on the annotation. Suppose if you are modifying the title block, one of the designers have to modify the title block or put in a revision, then he can focus only on that and hide the rest others so that he does not misplace or misenter some information. So these layers is kind of equivalent to the overlays that we will be using in the paper based drawing. It means that we overlay one set of image over the other. So these are going to be the primary organization tool for us in the drawing. So we repeat, this layers is to group information by function and to enforce the line type, color and other standards. So we'll look into how this layers can be used and how it can be categorized. So you can invoke the layer command by typing layer. So once you do that, you'll get a pop-up menu. Here this is the layer properties manager. So you can see that it shows how many layers are already defined and what are the various properties in it. So you can see some symbols here. The first one is to either turn on the layer or not. The next is the freeze the layers, that is, it can be, so layer freezes means it freezes the selected layers in all the viewports that we are using, including the model tab, so that we can freeze the layers so that we can speed up zoom, pan and other operations. We can also improve the object selection performance and also reduce the regeneration time for complex drawing. That is, whatever objects that are going to be in the frozen layers will not be displayed, plotted, hidden, rendered or regenerated. So that taken away from the drawing that you need to do. So the freeze we have to apply to the layers that we want to have it totally invisible for long periods of time. So that will look into the later stage, but this is just a overview, like what is the function of it. And next we have the locking. So if you lock the layer, then you can modify it. The next, plotting. So whether you have to choose the layer for plotting or not. So it means that certain information that are pertaining only to the drawing can be subsequently put in those layers and may not be taken for the plotting. So which type of layers should be taken in for plotting or not. So categorically you can apply different properties to the different layers. So next we have also colors based on the drawing, so that whatever drawing is default specified, you can modify the property as a whole, then the line type and also the line weight. So next is the transparency, that is, instead of hiding a layer, we can make it transparent so that we can still view the information but it does not affect the other operations. So next we have the new VP freeze. So this new VP freeze
freezes the selected layers in new layout viewports. For example, if you freeze the dimension layers that you created, okay, so in all the new viewports, it restricts the display of dimension from that layer, so that any newly created layout viewports will not affect the dimensions layers in the existing viewport. So that is, we can create a viewport later, so that may require the dimensions. We can override the default setting by changing the current viewport setting. So this we can see later, but maybe not in this session. So next we have the description for the entire layer. So this is how it got categorized. Then again we have the other options here to create a new layer, in the VP process that we are seeing now, and delete the layer, and finally select the layer as the current one. So initially what you can see is you have a default layer as 0. So you can't rename it. So this is here going to be the default layer. So after that is all the layers that we can add and customize. So first of all, let us right now try and create a layer that categorizes it into a different property. So here we can split the division. So what we can say is the construction lines that are drawing here. Okay, so this is not going to be used in the final drawing. So first we'll store the final drawing in a separate layer, the construction lines in a separate layer, and then the dimension annotations in a separate layer. So we'll split this entire drawing into 3 layers and see how it can support us. And also maybe we can do one more thing. This final drawing, we'll categorize it. We'll name this holes as a separate layers. This the slot area as a separate one, and the external area as a separate one. This is just for our understanding how to do it. So this again, all the layer is also available here in the layer tab in the home tab ribbon. So here you get all the properties that are available in the tab. So here, so having created this construction lines, so now we'll select the construction lines that we require, right click on it, go to properties, and then assign by what layer that we have to do. So now we have said that all the properties that we have selected, okay, so now we are assigning to the layers of construction zone. So now simply just going back to this original layer, and you can hide this. So now you get a prompt to state whether you have to turn off the current layer or not. So if you turn it off, you can see that the construction line layer has been turned off. This is the first and foremost application of the layers. That is, you can turn on and off the various properties that are not available required to us. But this can also have a consequence on the drawing. So here you can see that there is no referencing that is going. So we have to be extremely careful like how it has to be constructed. So in order to do this, then we have to ideally take an angular dimension radius so that we have all the points referred correctly. So this is just to show you how it varies. So now we'll assign new layers with the dimension properties all listed. So alternatively, you can all do this by the filter command, but right now we are just selecting it manually. Okay, see here we have only these that are available. So we have to create a new layer. So we'll name it as dimensions, and so now we'll make use of this select similar command. Okay, so now we have selected all the dimensions that we want to take. Now we'll assign to the dimension layer that we want to do. So these are all dimensions. So likewise, you can apply a different one. Also, suppose if you want to modify a current layer properties, that is, suppose if you want to modify the dimensions all to be in a different color, then you can do it in a single go by using this modifying of layer property. So this is also a powerful functionality of that is you can control the group properties of that specific layer, and again we can turn whatever layers that we want to initiate printing or not. Okay, the plotting can be adjusted. Then again the line types can be modified. So this typically is the use of the layer dimensions. So you have to make sure that you use the complete functionality of the layer by applicating the different requirements. That is, you categorize them into the base functions in the describing properties. That is, you can group it into the base object, assembly objects, and then reference objects, dimensions, annotations, and so on and so forth. So these all can be construed based on the requirement that you have.
So now we'll look into the different shortcuts that are offered by Autodesk. So here this snap, you can see that in a typical keyboard layout, what are the various one key shortcuts that are available. So on top you have the function keys. So the F1 as usual is the help, but from F2 to F12 is what is going to quickly help you during your drafting process. So F2 will toggle the text screen. So toggle means switching from one mode to the other. So earlier we were looking into the auto mode of toggling. So it means that when you click on F8, it either turns on or off the auto mode. So that's what this toggle means. So you have the toggling for object snap, 3D object snap, isoplane, dynamic UCS plane, toggling the grid mode, ortho mode, snap mode, polar mode, and object snap tracking, and dynamic input mode. So these are all just enabling or disabling the snapping. So if you instead of this shortcuts, then if you have to toggle them, then you have to invoke the command separately. For example, the object snap, then you need to invoke the osnap command and then select the checkbox wherein you have to select the snap should be on or off. Alternatively, in the command bar at the bottom, you have a toggling state, but this is the quick and straightforward method to quickly turn on and off the different modes that are required. So next, we have the QWERTY keyboard layout. So each and every letter can be used for a direct functionality. For example, the C is the shortcut, one key shortcut for circle. The O is for offset, I for insert, and so on and so forth. So you can have a look at all the one key shortcuts that you can quickly invoke the commands instead of typing it in full. For example, the move command, MO will invoke the move, and also AutoCAD will try to autofill the command that you enter, but rather if you type in M only, it will select the move command. So this is the powerful usage of the one key shortcuts. So next, we have the toggles and screen management buttons. So here, using the control options, we have a combination of control plus numerical and control plus alphabets. So based on this, we can toggle using different modes. And for opening up the different screens, that you have the control plus numerical option. For example, if you want to open up the quick calculator, then control plus 8 will help you. And likewise, in order to switch between the different drawings, instead of selecting them manually, you can use the control shift tab, control page up, page down to circulate between the tabs that are available in the drawing. So next, again, the drawing moves that we saw in the one key shortcut, and again in workflow for quick copy paste. So these are all an overall workflow. Inside the drawing, we still have the move option or cut option, undo option, all these things, but still we can use this shortcuts to quickly use the workflow management. So next we have different hotkeys. So right from starting alphabet A to Z, we have different commands that we have looked at. So in this session, we have looked at the command as an attribute definition. So that can be called upon only using the three letter ATT. And likewise for block, we can just use for B for creating a block. For closing, we can use for BC, and for editing BE. And for circle, as we look again is C, for chamfer CHA, and for copy CO, and so forth. So likewise, you have different usage of this, the combination of these hotkeys that can quickly invoke it. So all these are also available on the Autodesk site. You can also download them to have a quick reference. So quickly going through, so in D, we have majority referring to the dimension settings or the dimension options. So D for the dimension styles, and then the arc dimensions, the jog dimensions, and then the dimension text. So these are all in the D command. And in E to K, you have the different options. For example, you have the E for erasing, and then H for hatching, I for inserting the block, or J for joining the objects of different types, and in L is the line, and then we have the for M for move, O for offset, P for pan, PE for polyline edit, and QP for quick properties. So SC for scale, RO for rotate, and so finally in the last section we have X for explode, and then TR for trim, T for multi-line text. So these are the different hotkeys that are available in AutoCAD to quickly invoke the command and work upon. So to conclude on this week's session, so what we had covered was we looked into the different filtering techniques. So how to use the quick select, how to use the select similar commands, and then how to use the filter command to write in custom codes to select all the objects that satisfies the condition that we need and save as a separate filter. And next in blocks, we looked into how to create a block and then how to assign the constraints so that even during editing it doesn't affect the overall the geometric relation between the different features in that object. And then we looked into how to give dimension constraints so that they can be modified based on the different key inputs, and only specifying one or two major inputs by which all other dimensions are relatively constrained to that major input. Then we looked into the dynamic block settings, so how those blocks can be dynamically altered. We looked into different powerful functionality called as the visibility, the move, rotate functions using the parameter sets, actions and parameters. And also we looked into how to create attribute definitions so that it can be used as an display tag for the designer to select or use your block and then look into the attributes and modify it based on their requirements. And next we looked into different altering techniques using layers, so that is assigning separate groups of functions based on the filters that we had already done to assign them as layers so that all the manipulating properties can be cross applied to the layers. So in general practice it's always recommended to have multiple layers so that it can be easily viewed upon and manipulated by all the designers that you have. So typically the drafter who uses single layer is simply viewed as an inexperienced one. And next we looked into different shortcuts techniques that AutoCAD offers us to quickly invoke those menus. So this concludes the different productivity enhancement techniques that we had looked into, and we had one additional technique called as the macro, so that we'll look into detail in the upcoming sessions.
So welcome to week 9 of this AutoCAD course, Collaborate Effectively. So over the past few weeks, we had seen different topics, and particularly last week we have seen several productivity enhancement techniques. And so this week we'll add on to it how we can enhance our productivity further, and also how to use those effectively so as to collaborate within our colleagues, and also to cross applicate the drawing learnings that we have and then use existing drawing material. So towards that, we'll cover these topics. So first and foremost, we'll look into various file management techniques. What is a file? What are the folder structures? Why file version control is required? What are the different naming conventions? So we'll dwell a lot on this file management technique that will help you first and foremost to be a effective, a productive worker or a productive designer, and rather having a system in place will also help you to collaborate effectively within all your colleagues, and then have a good revision document that can explain all the variations that comes into your drawing. So next, we look into X referencing, that is an external referencing, that is taking a different drawing onto your drawing for either reference or to retain in your drawing. So we look into additional command to it, X binding and then explode, to see how it is coinciding with the external references. And next also we'll dwell a lot into the design center that is available in AutoCAD and tool palettes. So we'll see how these two can be used effectively to both use existing designs as well as to be more productive in your workplace. So we'll look into the various file management techniques. So the file is typically the current drawing or the project that you're working on. So why is it being important? Why? Because we encounter and we involve various changes to the drawing or to the project along the project life cycle. So this life cycle means that from the consumption stage, the conception one, and then it goes on to several modifications or changes, and then finally gets released to the drawing. And then again, this is the drawing level. Then it goes to the other production level, quality level, and then finally to the end product. So this is how your project is going to, evolve across various life cycles throughout the journey. So the drawing file will be the start point of this. And when we are going to do this life cycle evolution, we'll be having lot many updations or reversal back to previous versions or modifying a certain parameters and so on. So it's a continuously evolving process. That is, the drawing that you're working on is not a straight line object. It is an iterative and repetitive process. And as we discussed, it has to go through lots of phases of approvals or modification for each and every changes that you're doing. So if certain changes are not approved by the committee and they have to revert it back, then you go back to the previous version and then proceed on from there. So the file typically goes through a lot of modifications to get the final one. So that everything is going to affect the current drawing that you're working on. So this is how important the file is. So next, how to keep a track of them. So that's where this file management comes in. So why to take a track of the files? This is a very important area because typically what we will be saving the drawings as, I'll give you a few scenarios here. So it will be typically a my drawing, or you go ahead and name with the detail, like in the previous examples what we've seen was it's a hexagonal nut with 8 mm major diameter. And the other ways of nomenclature is just go by the default naming, because drawing XX, so the X represent the number, and this is the AutoCAD's default naming nomenclature for drawing 1. And what happens if you modify it? You typically save it as drawing 1 final, so thinking that this is going to be the final one. But what happens is, once you keep on going it will still goes to undergoing a modification, and then you name as final. So this is all some typical examples of what we see in day-to-day life. And again, when you copy this file onto another file, or suppose if you open a read-only drawing file and then the system prompts that it's a read-only file, there are some restrictions to it. So you have to create a new file or copy it in as a different name and then work on. So then Windows do you the honors, it names it as copy of drawing one, and then you keep on working on it. So now obviously you're working on the same file, but within this we have gone through many variations, and those many variations get saved as different versions to it. And if you as you're the person working on, you can quickly look into what are the various changes based on the names. But as time progresses, you do not know what files contain which details, or why a new file was created in place of the old file. So this is where you have to keep a track of all the changes, and a requirement of the file management kicks in. So this is about the file. But generally, even when you have so many variations in the names, you also have one more, critical issue that you face on, that is, where did I keep it? Is it either in the folder X or folder Y or in drive Z or H, or in which IP address I put in if you are working in a collaborative environment? So then all chaos breaks out because you don't know where it is. And typically your boss comes in and says that I require that file right now, and you're not able to find it because it is not indexed and put it in the required location, or you might have moved to a different project and you couldn't recollect on which one. So because these situations, typically what you face is you forget the file name or the project location or both. You do not know how you have saved it, and you use the Windows Explorer, all the search options, advanced search options, everything, it keeps on running, but it does not give back your required files. Or finally, even if you search it, you have spent a lot amount of time to retrieve just a file, but you do not know that that file is the required file or not, because you are just going by the name. Because if your typical naming is of these kinds, then it's again difficult to search in like the required file. So again, now where did I keep it? So that's where your folder management strategy comes in. So we look into typical folder management scenarios. So typically what we have here is you either use the existing folder structure or use the default folder name. It means that you use in whatever drives it is, just go by the nomenclature new folder, and then within the new folder and existing file name. So what you're doing is you're using the default folder nomenclature structure that Windows prompts you. So next is there's no indication to hierarchy. Hierarchy means a logical flow of information within the folder. So it means that the folder name denotes that these are the files within which the folder encompasses. So it means that if you break down the project into different stages, then each and every folder should be named in that case. So we'll look into further in how a hierarchy means it, but right now we can see that there's no hierarchy that is typically goes into the folders that we go into, and hence the files would be available in different folders or drive, and particularly in your local machine or the PC or in a distributed network. So it's not categorized or not saved in a structural format, and there is a high probability that you either delete the file or lose it altogether because you have not indexed it in the proper manner, and you have not allocated certain restrictions, folder restrictions, for modifying them. So those kind of shortcomings can lead to folder deletions or misplacing those folders. So ultimately, you have the risk of losing out your designs as well as the other associated files. So having said that, there are a lot of opportunities for the file or the document or the project folders getting mislocated or getting misplaced or edited by mistake. So all these things we have seen in the previous slide. So what impact does it directly have in the organization? So let us quickly look into some facts and figures. So companies on an average spend typically $20 in labor, that is in manpower cost, to file a document, and close to $120 in manpower to find a misfiled document. Because just $120 or $20, what you mean is the man hours that is spent into the process of finding a file or creating a file. Okay, so this is how you quantify in organization terms. And close to $220 in labor to reproduce a lost document. What he means by saying is to create or filing a document is, has the least amount of cost. But the cost of finding a misfiled document is close to 60 times, whereas it's close to 100 times when you have to rework the entire procedure to recreate the document. And another way of saying is out of 100 documents that you produce, nearly 7.5% of all the documents. So it means that for 100 documents, close to 8 documents get lost and 3 of the remainder get misfiled. So you see, this is not a typical scenario that you would like to place yourself in. It means that you might be the originator of the file, or you might be the person who is responsible for that file. Then you would not like to be in that position to be responsible or be answerable for those misfiled or lost documents. And professionals typically spend 5 to 15% of the time reading the information, but up to 50% looking for it, searching for it. It means that if you're taking a drawing where you want to look into some key dimensions, your 50% of the overall time that you allocate for this work is consumed by looking for the file and retrieving it only. And after retrieving, you find a partly amount of time to look into the required information. So this 50% of the time is a non-value added time because it's not going to help you or the company or the customer. Only the 5 to 15% of the time is the valuable additions that you give to the organization or to the customer because you're inferring something out of it. Whereas the time that is spent in looking into is quite high. Why I'm emphasizing this is to ensure that you understand the criticality behind the file management impact that has on the organizations. Also, one more statistic is close to $24 an average cost to process a single invoice manually, whereas 40% of 1,200 organizations survey indicate disaster recovery planning is not a priority at all. So disaster recovery means in case of certain loss of material or loss of men, or in those scenarios, 40% of the 1,200 organization, they do not prioritize this. So it means that they do not have systems in place that protect their information. And the previous point means that they have to manually process all the informations to locate it or deliver it. It means that they do not have an information system in place. Likewise, one more statistic says that 2 out of 5 companies who experience a disaster, that is, they are a part of the or the victims of a disaster, are out of business in 5 years. Why? Because they do not have the mechanism to retrieve all the processes to them. They have to recreate all the. You look into all the first 3 points. The cost of misfiling or losing a document is very high. So this has a huge impact on the organization. So by this you can understand the gravity behind the situation to have a robust file or a document management process. So there are again different quantifications of the design challenges that are related to data management that we can pull. So this is one representation from Autodesk PDM's tool. So what they say here is nearly 49% of the time, that is 50% of the normal time, is spent in sharing information with other departments because you are working in a collaborative environment, and hence the typical data management process involves sharing those information that you've created or working on to different departments, and that involves close to 50% of the time. And again, as seen in the previous slide, close to 46% is spent on finding the right information or the right file. And then 43% is spent on managing change. Managing change as in there comes an update and you have to incorporate those updates into the current drawing and then get it into a release stage and then propagate the change across the organization so that that change gets reflected in all the work that is being currently carried on. So that is what is change management related to your design process. And next 35% of the time is spent on working on wrong or outdated data. This is linked with the previous point because if you do a change or do an updation to the drawing, it has to get automatically reflected in all the related processes that are downstream. It means that if you're working on a drawing X, from which there are several derivatives that are derived, so then whatever changes you're making on drawing X should get automatically reflected in all the other drawings or other persons that are working upon the drawing. Else, we have the risk of working on a wrong or outdated data, and hence you have to do it all over again. And 29% of the time is spent in reusing the data. It means that you either take in previous drawings or previous blocks or references, whatever we have seen earlier, we are reusing the data that we are already have created. So it also closely relates to, if you're not able to find those data, then typically you have to recreate the data also. But typically the data information means that close to 29% of the data are being reused in the system. So there is being a requirement of data from the previous data that needs to be pulled in. And then around 29% is spent in managing design projects, because those impact the project lifecycle that we have spoken about earlier. And then nearly 26% of the time is spent in collaborating with engineers in different locations. So here what it means that you have to continuously keep a track of the files that are being circulated among the different locations, and then you have to have a solid the IT infrastructure wherein you can save and distribute the data confidentially. And also close to 25% of the time is spent in sharing the info externally. Externally means that you are working on a drawing or a design, and after a particular stage, then you have to release the drawing to your suppliers, to our external auditor, or to other customers who take the drawing to the next stage. So it means that you're going to share information from an internal network to an external network. So these are the different data flow that takes place in a typical organization, and see how much of weightage it is carrying in every stage. So it all boils down to a single file, that is your drawing. So how you are storing it, how you are recording it, and then how you are placing it, it's all going to matter. Because if you are able to categorize, then locate your data effectively, then you're going to be a leader in your area. As a worksman or as a manager, you can ensure that you keep a well-defined process in place within your institution, because there are a lot many PDM, product data management tools, or lifecycle management tools available in big organizations. But they all boil down to the simple fact of maintaining a neat file, neat folder structure, and neat revision structure. We'll look into those basics so that even in your typical training process, you can involve them so that you will be well versed with all the factors that are involved in the file management, so that you can be a master of that. So the first is creating a well-defined or powerful folder strategy. So first and foremost is use a proper folder hierarchy. So what a hierarchy means is you create inside your workstation or your PC, you have different drives. So here it means that you have a hard disk, or you have a CD-ROM, or it can also represent a network drive or a USB drive, or your your organization's IT work. So within that, you maintain well-defined folders. Within that, you also maintain subfolders and files pertaining to those folders only. So typically what means by using hierarchy is that by looking into the folder structures, you can able to identify which file will be where. So those kind of information is what a hierarchy will give you. So looking into detail, what we can do is you can build a hierarchy by using various categories or project stages. So this is a sample of it. So it means that you have a product in place, whereas you have, based on the project stages, you define the folder hierarchy. We have, see, it is well named, by using a numbering and also using a simple name of the folder, and there are subfolders within it. So these subfolders can be also part of the other main folders also. But by based on the folder view, you can categorize where it is. That is, if this design comes into the definition, so it means that it's a part of the concept definition. But if it's this design comes under the development, you can understand that this is a development stage. So likewise, the hierarchy will give you the first cut of information that pertains to the file that you are going to put into. So next, you can also group the folders by date if you want. It means that you're working on, projects that are defined by quarters or by months that are going to be, the start of month or the delivery month. So in those cases, it's a well defined archiving mechanism by which you can categorize by the date of creation. So it means that you can know where to look into. Suppose a project that was executed in 2018, then you can open up the folder in 2018 and then look in. So what you're doing is you are narrowing down the search. You know where to look into. Then you can subject that into separate search structure so that it will help you out. So this is how you categorize the different folders. Also, what you can do is you can create folder templates so that you can use it and reuse it and then duplicate it into other projects also, so that you can quickly invoke it. You do not need to create each and every folders once more. So typically it means that if you name this folder top folder structure as XXX product, and it means that the internal structures are not going to change, but the external structure, that is this product XXX, for example, it's 001 product, so that you maintain a separate file stating that 001 refers to this customer, 002 refers to that customer, and so on. So what means that you can create a well-defined folder template and then duplicate it. So next comes the file naming strategies. So these naming strategies are well-defined principles by which you can deduce a disciplined way of structuring the files. So these file naming and folder naming strategies are not related or not restricted only to your drawing files. I would recommend you all guys to execute this in day-to-day practice. You try and name the files and folders for all the activities, be it music, be it movies, or be it games, or whatever you work on typically. Try to organize them into well-defined folders and also file names. So in that case, you can have very good management principle in practice so that you can cross-applicate into your future requirements. So the first thing, there are plenty number of standard naming or label conventions going on for different applications. We'll look one later. But if you have such naming conventions in place, then it is well appreciated. If not, then you can devise your own naming conventions. So let's look into what are the techniques that you can take into naming conventions. The first thing is keep the file name as short as possible or in integer into your programming language. Those can have, for example, if you have defined as a character, then it can go until 256 characters. And based on the architecture of the system, initial character name is restricted. So it typically goes on to just 32 character spaces. But then as technology progressed, then we had a limit to increase it. I think now it's around 200 characters or so. But it does not mean that you have to exhaust all the 200 characters that is available for the file. You have to be as short as possible so that the file intent is communicated clearly to the user. So how to do it? You can also use descriptive information terminologies built into your file naming strategies. It means that you designate certain terms and then place it into your file name so that you can have a master description list stating that the first two characters demonstrate these type of information and the next two characters these information and so on. So it means that the viewer can understand that this character always refers to this type of information. So those information you can encode within your file. Next, best practices use the date information into your system because typically in the Windows Explorer, when you create a file,
the file timestamp gets updated in the file that is created onto your Windows. But suppose if you open and close it, then the timestamp will get again updated into it as modified. So it means that when you're typically viewing the file on your Windows Explorer screen, even though it was created way back, if you had opened it recently, the latest revision will get updated in the Windows file management as the modified. The original file would not have changed, but Windows has its own way of updating the file references. So it's best practice to also include the dates into your file name. And in dates, typically in India, what you tend to do is you go by date, month, and year. But if you designate it as year, month, and dates, you have a chronological order. The file will get aligned in the date structure, or else it won't get aligned. So you can try it out and see how it will. So typically, you can either use the 4 digit for the year or 2 digits, but the general practice is to use the complete list, that is YYYY, that is 4 digits for your year, 2 digits for your month, and 2 digits for your date. So next, you can also use the numbering techniques to mention the versions of your file. So we'll look into version management in shortly, but instead of naming it as a single digit, in best practice, you can always name it as 2 digits and starting with 01. So it means that you can go until 99. So considering you have so many revisions, but also it's easier for you to look into and edit in the overall folder structure. So it means that the first file will be 01 and the 10th file will be 10 and so on and so forth. So it's easy to look and differentiate between the files revisions. And next, always avoid special characters when you're naming the files. Typically, certain softwares allow you to take special characters, certain do not. But as a general naming convention, do not use special characters like the tilde sign, the exclamatory, the al, at the rate of, pound, dollar, percentage, etc. So those are good for passwords, but not good for files. If we want to, bring in a larger name or differentiate between different information areas within your file, then the best practice is to use either the underscore or hyphen in space of blank spaces. But typically most of the programming languages, they recognize only underscore. So using underscore in place of blank spaces is the best preferred way of naming a file. So quickly we'll look into one of those naming conventions, BS1192. So this naming convention was predominantly followed and used in the United Kingdom. It was introduced in the year 2007, and later it also got adopted as an international standard as ISO 19650 with certain lot of additions. So what this does is BS 1192 typically focuses on organization and digitization of the information about buildings and civil engineering works, including building information modeling. So this pertains to architectural ground, but you can see that the keywords here are that matters. That is, you organize the data and then digitize the data. You can leave out the second part, that is the building, civil engineering works and all. It's a standard derived for the architecture industry, but the purpose is to organize and digitize the information. So this was what we were speaking about earlier. Having a proper folder structure or having a proper file nomenclature so that it can be easily retrieved and easily make sense of. So we can look into what are the different parts of it. So those parts can differentiate within a single file name that what is it, document or a drawing or a model or data files, all encompassed within the single description of the file name. So typically it looks like this. It has a series of alphabets and numbers, and this technique, use both hyphens as well as colons. But this is the exploded view of the entire naming convention that BS1192 uses. It has both an optional and as well as a mandatory one. So typically, those that are highlighted in red boxes are optional one. So first, let us look into the mandatory one. So what are those sections mean? So the first one, starting from the left, is the project number. So typically it can be of 2 to 6 characters in length, and they typically comprise of letters or numbers. And based on the projects that you work on, you can give a unified nomenclature by it. The PR1 internally can refer to project X that you are working on. It might be an individual project or a company based project. So next one, XYZ, is the company name or code that you work on. So this is again drawn from the BS 1192 standards. This is to give you an example of how a naming convention looks like. You can adopt it to your own use and adopt it to your own requirement. And later in your workplace also, if there are no hard and fast rules that are available, I would definitely recommend you to take up the initiative to create such file and folder naming nomenclatures, so that will ensure that your organization moves to a data centric method and have a robust data management system and process. So next is the volume of the system information. So typically if you're working on different subsections of it, this volume, it's a civil terminology, but it means that the overall picture of the project, just as in your books that is in volume 1, 2, 3, 4, so and so, or classify between subsystems. So those kind of information can be captured in here. So next is the levels or locations that you do. So those are 2 characters again with the letters and numbers. So as it is a civil name, it means that 01 means the first floor, and 02 means the second floor, and GF means ground floor, and so on and so forth. But here again, you can also, for a mechanical one, you can modify it, say, on a subsystem, what are the child parts, how the child parts have been categorized, those kind of information you can carry it into it. So next is the type of information that is encompassed within the file. So if it's M3, it means it's a 3D model file. So if it's named as DR, it is a 2D drawing, or if it's a PR, it's a program. So those programs we'll look into later. We'll look into macros and autolist. So we can also use those differentiation of the information within the file. And this file, see why? Because based on the extension, if it's a .dwg, it's a drawing file. If it's .txt, it's a text file. If it's MP4, it's a video file. But all those information cannot be just taken only with the extension, but rather you can also bring those descriptive information into your naming instance. So next is the role of the company. So A typically means that the company is an architectural based and it's creating it. Alternatively, if it's of K, then it means that it's a client company. So what it means that the information of the company name and the company role can go in tandem to describe where the file was created and what is the application or the role of the company that takes up this work. And finally, the 4 digits represents the file number. So typically this is the main info, whereas all others are descriptive info pertaining to that file. So next we'll also look into the extended naming convention. So the first one is a civil engineering term. It's a classification of the type of the architectural terminology. So let us not dwell into it, but this 150515 means that it's a unique class of 2015 revision. The next 2 terminologies can be of use to us. So the S use the suitability status, that is how suitable the drawing is, the file is. So it means that it's named from S0 to S7. It means S0 means it's in the initial status or in a work in progress. So it means that it's a master document index of file that's going to identify the uploaded files into the extranet or the intranet. It typically means that it's the initial status of the file. So S1 and 7, through that it shows the shared files in a non-contractual. These are the terminologies that are available in 1192. But the idea is you can see the various level of suitability. Suppose if it's S1, then it's understood that this file is suitable to be shared for coordination, so that they can be taken and modified for their own use in applicable domains. And likewise in S5 means that this document is suitable for a manufacturing process. Or S4, it means it requires a stage approval. And S7 means that it's in AIM authorization. So whatever is the final level of authorization or so. So alternatively, from the work in progress to publish to any unauthorized or non-contractual use, then you can name it as D series. Then in published documentation, wherein it is approved and accepted, you can use the A series and so on and so forth. So you can adopt those suitability status to your own project based on your project life cycles. You can assign your codes. That is, we are not following BS 1192, but I'm just saying out how these kind of naming conventions you can apply based on a requirement. So finally, the last three digits refers the revision status. That is, you already work on a file. Okay, so that is a unique identifier. And then for that file, you assign the suitability status where it can be used or applied. And then you state in which revision it is. That is, in this file of 001, if the revision is in the preliminary stages, that is, even when it is before launched, you're doing the revision, then you assign the P stages 01, 02. Suppose it's a completed project or a completed product. So it means that it has already gone to the production line or it has gone to the customer or so, and you get a customer feedback. And based on that, you do a minor modification to the file and then send back to the production line. So in that case, you can assign it as in the completed stage, but then you have done a revision to the completed document. So these kind of indications when using a common naming strategy will help everybody in the line to understand what the document means and where to use it. So this is how your naming convention is going to help you. So next is additional to the naming convention, because what we have seen is the file name can hold only so much of information, but there can be many others, or how to find those data. So in those cases, you can use the metadata linking with the file or having suitable documentation to it. So what metadata means is it's a subset to the core data documentation, which will provide additional standardized information that's going to explain what is the purpose of the file, what is the origin of the file, what are the different time references that are built into it, and the geographic location, who is the author of it, and what are the access conditions, what are the access levels, what are the terms of use of those data collection, and so on. So this is the definition of the metadata information from the UK data archive. So putting into simple words, with this metadata information or documentation, what we can ensure is it can be easily searched for and can be quickly retrieved, and it can be understand in the present scenario and also in the future scenario what is the purpose of those data and what has been structured into it. And it can also be properly interpreted because we have the relevant information available within the embedded metadata. So these can be captured in two ways, that is using the Windows Properties tab or in the AutoCAD drawing properties. So in the Windows environment, what you can do is you can look into the additional properties that can be embedded as metadata information. So towards this, you can select the file, right click it and go to properties. So here you can see that in this is your typical name, and then it also denotes what is the size and all. So this is normal information, but additionally you also have a summary information. So here you can give the title of this drawing, title of the drawing of the project, and what data it is subject, what are the author or what are the keywords by which you can search, and what are the comments to that particular file or particular version. And if you want to have any reference to it, then you can also create a hyperlink to this base. And AutoCAD also offers you statistics of it, when it was created, when it was modified. Okay, even opening and closing will also be counted as modified. And who was the user was created, what is the revision number to it, and what is the editing time. Also, you can give custom properties values. So these are custom metadata information that you can fill in. So you can give in the file name, the revision name, or the subassembly reference. All those things can be given as custom metadata information. Then you have the typical security information where you can restrict who can view the file, who can edit the file and those. So it means that you are protecting the editing of the files. Then finally you have the details of it. But the data that of importance to us is the summary tab and the custom tab by which you can enter the metadata information into it. Alternatively, in AutoCAD, for example, in this drawing, what you can do is in File tab, in the drawing properties, you can see it bears almost the same info here, the summary and the custom tab. So here you can add in the metadata information by which you can categorize the information. So next is looking into the controlling of the different versions of your file. So this is in fact a major topic because there are a lot of tools that are available that will help you in controlling the version. But let's look into what is typically version control means. So having a good version control will help us in tracing the document or the file. So what traceability means it a retention of all the drafts and the details of the changes that are made on the file and also the order of the changes so that we can know which is what and when it has been created or modified. Next, also we have the identifiability. We can know that what is the current version that we are working on and who has done what revision and when. And also we can have clarity to it. That is, not only with the revision number versions and the levels, the latest version can be taken and pulled easily, and we can know that this is the current version, this is the previous version, and this is a deleted version, so on and so forth. So we have clarity of the file version that we work on. So next we can helpful in reducing the duplication of it. It means that only the definitive versions that are required for is retained and others can be discarded. And as you have a very strict version control, you can also reduce errors that are built into it. It means that the release version can have only limited access in order to avoid changes. So what we have seen earlier is we have looked into detailing of the versions into your file name nomenclature itself. But what this version control means that you typically work with a single file and then you overwrite the existing versions. That is, you have a single working copy of the file and all the previous versions will be indexed into the version control management so that you have only the current version that is working on and not the previous ones. And only if required, you can pull in the previous ones. So it means that it simplifies the process of your working and the naming. So typically, you can take it in a simplified manner without any tools, and so you can have a version control table wherein you specify the version number, you denote who is the person making the change, and also include what is the purpose of the change or the change detail and date of the change. So what you can do is you can position this information as a text file or simply put a better way is putting as an Excel file into those respective folders that have the drawings in place. So it means that you have a track of all the changes that been made into this file, and hence without opening those files, you can just open this Excel sheet and look into which revision that you want to work on and what are the previous versions and so on. And also it can help you identifying the file that is required for you. So it means that you're bringing all the information, that is you're bringing in your file name, you're bringing in your purpose, you're bringing your metadata information and all those things, and also with the versioning of different modifications so that you bring it all together in a single location to have a well-defined version control in place. So alternatively, you can also use version control tools. There are a lot of ready-made softwares that are available for CAD versioning, that is your design drawing versioning, but typically it all does the same actions. So what it does is, it's a system or software that is going to record the changes that are being done to a single file or a set of files. It means that you always work on a single file and then all the changes that are done need not be created as a separate file or a separate thing. It can be kept as a working copy and all the revisions would be recorded automatically into the system. So any previous versions that we're working on will be stored internally into the version control tool, and hence you can pull it out at any point of time you want. And also the current version can be branched out. Branched out means creating a working copies between the different collaborators. That is, all the persons will work on the same working copies, the same project. Then they can be merged back into the master copy and then continue. So what it means that you are splitting the drawing into the components. That is, you work on this designated areas and then you can pull it back into it. So this kind of merging activity cannot be done in a normal version control tool, but in CAD version management tools that are available in the market, you can do this activity. So it means that it will quickly show in what are the differences that are being done with the previous versions and so. Also, when you're merging back the data, suppose two persons have done modification to the same object. Suppose one person has defined a diameter of 8 mm to the drawing, whereas the second person has defined a diameter of 10 mm to a drawing. When it is merged back, it will show up a conflict option between the version, and hence the manager or the supervisor can decide upon which property to be taken into. That is either 8 mm or the 10 mm to be retained. They can review it and then take it back. So it means that any unauthorized changes are not done to the main drawing. So you can also view the differences between the different versions that we have. In AutoCAD, inside the tool itself, we have the drawing compare option so that we can compare two drawings simultaneously and see what are the differences that are called for. So it means that you can use the custom or the typical free open source tools that are in the market currently for your training purpose. You can see how this version control works. And then in order to dwell deeper into the design changes, then you can use the AutoCAD DWG compare to view the differences. This is how the version management tool looks like. So all the version control tools have a single repository. So this repository means like a folder kind of thing, the main folder, the bank, a locker kind of thing. So wherein for working, you take the copy of the current file, that is the working copy. So this is collaborator 1, 2, 3. So all they take a working copy of that. Okay, so any changes that are being made within, suppose this author, does a change. So what he does is he will commit the change to the repository. So typically first he pulls the data, then he pushes back to the repository. So now the users here, they will get a information automatically saying that the original file with which they have a working copy on has been modified. So then they can update the working copy accordingly. So then they also internally have a conflict. It will show that this property has changed. So they can accept whether they have to work on it or not. So that way they update the drawing and then push it back to the central repository. So typically this is how almost all the version control tools work in. So there are two popular examples in it. SVN, the subversion control, or the JIT. So for SVN, you have the Tortoise SVN, and Git, you have GitHub, that is an online portal. So my recommendation is to use the subversion controlling, have a good grasp of it, how you can control the documents to it, how you can look into the changes. You will have to, check in the document, check out, update, commit, and then look into the different variances. So this is an evolving process. This is a subject altogether on its own, but I would recommend you to use these tools in your normal practice sessions so that you can have a way around it, because whatever product lifecycle management tool that is going to be used in the organizations is all going to be based on this single functionality. So this sums up the different version control tools that are employed in the organizations. So this concludes the different file management techniques that we have looked into. So we have looked into various file nomenclature techniques, folder nomenclature technique, and the version controlling. So please bear it in mind. You have to have all these in place. It is a discipline by which you have to maintain those names and structures, because it will make your life easier. and it will make you more productive.
So now we'll see into what are external references or XREF to be in short in AutoCAD. So external references and blocks are kind of close to each other, but only thing is like when a drawing is going to be inserted as a block, then the block definition and all the associated geometry are going to be stored in the current drawing database. That is, if you're working in this drawing, then whatever block that you're inserting will be pertaining to this drawing only. Whereas the block is not going to be updated if the original drawing changes. But if you are going to use it as an external reference, that is, you insert a drawing as an external reference, then whatever you are doing in this drawing, the external reference will get updated when the original drawing file itself is changed. That means all the latest revisions to the original drawing file will get reflected to the attached reference drawings in the other drawings. So this is the major difference between your blocks and external reference. So typically, to put it short, the drawing that's going to contain your external reference will always have the latest editing of the drawing that you have. Okay, so this is what the external reference is highly used for. So this comes in place when you are working with an assembly drawing where you have multiple persons working on the drawing. It means that each and every subcomponents are being developed by different persons, but later you're bringing all together into the single drawing to produce a output an assembly drawing. And suppose in the due course of the drawing, one subcomponent gets updated, then you need not have to track back and then update in your final assembly drawing, but rather it's all carried forward together. So that is the external reference. So typically what you're doing is you're creating a link between the sub-assembly drawing as well as the assembly drawing through the external references. So this external reference is going to be a variation of the block. So a block that we have done is going to be a collection of geometry that is identified by a unique name and is stored in the symbol table as we had seen earlier in the block. We'll quickly show. So when in the block, you can see that. Okay, let me go in the insert block. So here you can see that it's a collection of this geometry that is going to be stored as a unique name as well as a symbol table, so that when you insert it, it will act as a single entity. However, when we are going to take the blocks, the external references, the geometry associated with the external reference definition will not be stored in the current drawing. It is stored in the original file only. So this sums up the basic definition behind an external reference. We'll quickly jump into how to use an external reference. So towards it, you can see this drawing. This is from the AutoCAD mechanical database. So this is a pump housing. It's an assembly drawing. So here you can see the various distinct elements of this assembly. So we have a long hexagonal socket head cap screw, and then we have the bottom plate. This unit as a bottom plate, and then this plate as the pump cover, and then we have a drive shaft, and then a wheel casing in between, and also a pump wheel in between. So you put these all together along with the deep groove ball bearing elements in these two. So now you get the complete gear pump subassembly. So let's see how to include all the subassembly drawings into a major drawing inside. So towards this, you can call the external reference through either the insert tab and then external reference, or in the insert tab, here in the reference panel, you have the external reference as the attachment here. So these two ways of inserting a external reference. So we'll go with the insert and external reference. So once you do that, we'll get the external reference display manager. The external reference manager, just quickly open it up. So here
we can see the entire details of the drawing. So currently what we have seen is the current drawing that is taken as reference here. And then we have the option to attach a drawing. Okay, so once I click on that, you can see except for this subassembly pump, we have the individual components. So let us go with the first one, say, let us say the pump cover, click on open. Now comes the attach external reference tab. So just like in block, you can see that we have the scaling option, insertion option, and the rotation, the block units, and so on and so forth. Along with it, we also have a preview of it and also a reference type that comes in. That is, you can either external reference as an attachment or an overlay. So overlays are typically used when you need to view another drawing geometry temporarily, but we do not plan to plot using that data. It means that it's kind of a tracing paper that is on top of our current drawing. We're just placing out the new drawing that is taken as an external reference just for a temporary viewing. So in those cases, we use this for overlay. So whereas if we do as an attachment, then it's going to be a single one-time occurrence for this external reference, and that's going to be for permanent use and also can be used for plotting the document view. So the process is all the same, but only the differences is how this nested reference is going to be handled. So that nesting means it's going to occur when an external reference drawing contains a reference to another drawing, so that it is either visible in the current drawing or an overlay to the attached drawing also. So let us quickly see how different it is. Like, let us go ahead with the overlay, click on OK. Now let us click on this insertion point. You can see that. Okay, so let us quickly insert using this command xref the next component using this attach tab. Now let us go for the pump wheel, but this time let us insert as an attachment. So now how it's going to vary is between the attach and the overlay is that when you're saving this document and then using this drawing as a reference to another drawing, then you can see how the attachment or and the overlay is being affected. So to quickly understand it, let's just look into here. So you can see this pump wheel, it has been taken as an attachment, whereas the pump cover, this one has been taken as a overlay. So it means that we are using this pump cover as a overlaid reference only for this drawing, okay, and you do not intend to use this as a part of this drawing when you're saving and then using it again. Whereas this pump wheel has been taken as an attachment, so it will be used as an integral part. So what we can do is we can just quickly save it out, and then we'll create a new drawing. And now let's again call the xref. Okay, so in this drawing, let us open up the drawing 3 that we have created. And now we'll again use it as an overlay only because we do not want to have it as an attachment. We just want to have it as a reference. Okay. So now clicking on OK and clicking the insertion point here. Let me zoom back to the extents. You can see that only the pump wheel has been taken because this is an attachment to this drawing 3. As you could recollect, in drawing 3 we didn't have any drawings that we have construed by ourselves. We had directly attached two external references as an attachment and an overlay, and that difference is called upon when we are referencing this file to an X file. So this is the basic difference between an attaching and as an overlay or an attachment. So to quickly reiterate the functionality of this xref is that we can use this to coordinate our work with the others of others by referencing others' drawings in our drawing, so as to keep up the changes made by other designers. We can also assemble a master drawing, that is the overall assembly drawing with different subcomponent drawings that may not be the final one, but as an interim one using which you can based upon your drawing. So that to simply say, you're working on a part that needs to have the dimension boundaries by a component that is worked upon by a different designer. So in that case, you need not wait until his design gets to process through all the stages. So once that design has crossed the interim stages where the boundaries are defined or the reference points are defined in that drawing, then you can take that as an overlay onto your drawing and then use that for your building on your drawing. So this is the major usage of this external reference. Also, one more thing is when you're construing the final drawing, you can always ensure that the most recent version of the reference drawing will get displayed. So every time we open up the drawing, so what happens is AutoCAD tries to refresh the location. Okay, so it'll go back to this location, refresh the drawing again and again whenever you open this. So whatever the latest update of the individual drawings will get updated to your external reference one. Also, what it does is it will take forward all the layers that are predefined in the existing drawing so that it retains the names of the layers, the dimensioning styles, the text styles and all other elements from the original drawing to your current drawing so that they are not affected. Also, if required, we can bind the attached reference drawing permanently to the drawing when the project is complete and is going to get launched or reviewed. So that we'll look into shortly. So now let us again quickly look into what are the different options that we have here in this external reference table here. So what we have seen is we can attach as a drawing. Also, we can also attach as an image or a PDF file or any point cloud or coordination model. So what it does is it did not need to constrain yourself with a certain file type for creating your drawings. So with a different sorts of requirements, you can pull in and then reference it to it so that you can quickly work on your drawing and collaborate more effectively. Also, you can see that for each drawing that you're loading onto it, it'll show whether it has got loaded or not, what are the size of the individual drawings, and what is the current type of the attachment it is, so either an overlay or an attachment, the date of creation of the drawing, and then what is the location of those drawings. So these all get filed under this file references. So this is how the nesting will happen. Nesting as in like this drawing 3 comprises of pump wheel as an attachment. On the symbol you can see what's the difference is. An attachment bears the drawing symbol so that it's going to carry it over, but an overlay is just kept upon your drawing here. So this is your overlay symbol. Whereas in drawing 6, you have the nested reference here. That is, you have a drawing 3 as well as the pump wheel. So there also runs a certain risk of circular referencing. If you're aware of Excel terminologies, circular references is used when the drawing that refers to a secondary drawing that in turn refers to the primary drawing. So in that case, if you have such kind of dimension, then there is an issue of that. So hence, as an attachment is always not a recommended part of importing if you are using only for reference. So always try and use for an overlay option when you're using the X reference. So once you have imported to this drawing, then again you can also modify the type by right clicking on it and then selecting the XF type as either the attachment or overlay. As you can see, now we are in the drawing 6 and it is in the original drawing 3, and that's why we are not able to modify it. So the explanation also is given here. That is, for nested references that is selected, the pump wheel is a nested reference and hence we cannot change the path and or the name or type. all the modifications have to be done in this drawing, only then it will get updated here. So suppose if we modify this as an overlay and then save this drawing and now get back here. So now we can see that AutoCAD prompts that you need the external reference source file has changed and may require reloading. So once you reload, you can see that that goes off because we have taken as an overlay and hence that is not listed here. So that is the major difference between an attachment and an overlay. So also now we can go ahead and then we can try and detach the drawing from here. So selecting on this, you have an option that is unload reload option. So unloading means the file is still attached to the drawing, but it's not referenced to the drawing internally. So that is the, let me dock it out. Okay, so now what happens is we have unloaded the drawing. However, it is still attached to this as an external reference. Clicking on reload will get it loaded again, but clicking on detach, it will go into totally eliminate or remove the external reference from the drawing. So what it does is AutoCAD will erase all the X reference copies, deletes its definitions, removes all the X reference from the tree and list views. All the information such as layers, line types, everything will get deleted. You can see here now the layer information of that is also getting deleted. So you totally remove all the references of that particular drawing that you have attached from the drawing. So this is what is the detaching of extras. However, in case of nested references, we cannot detach or we cannot detach the top level external reference if it's going to be a nested extra. So you always have to go to the original extra. So nested means this file is getting called onto another file and so on and so forth. So that is the detaching the externals, and also we have seen unloading an external reference. So what happens is it's removed from the display, and also one more thing is like once the job has been completed, that is once we have used this reference, let me say it. So suppose we are drawing a component, okay, so that has to get reference from this point of dimension. So we have considered this component, and now I do not require to load this component each and every time, but still have to have this reference in the memory as in the drawing, so that I can know where this reference comes from. Okay, so in those case I can do the unload operation so that my AutoCAD drawing opens up much faster and also uses lower memory, so that I'm optimizing it here. But the pointer to the reference will always remain here. So by this we can understand where it is used and why. So again, when we want to analyze where it has been a reference for, then you can use the reload option to look back, retrieve all the information that you are using it here. And also suppose if the original drawing has gone to any revision as we seen earlier, you can either reload it here or use the refresh option. So by that you can refresh all the location. Suppose if the referenced file has been moved over to a different location, it is not in here, then AutoCAD returns a prompt error saying that the file is not found. So in that case, you can select and then change the path type, that is make a relative or select a new path, or also go here and to select the path reference. Alternatively, you can also replace this component by a new drawing. Suppose if this pump cover, this references can be replaced with a different path. So this is about linking the address of the reference drawing. So this is about external references. So next is binding these external references to it. So one way of doing it is you right click on this drawing and then click on bind. So now you have two options to it. You either can bind the object or you can insert the object. So when we use the insert object, then all the named objects will be merged into the drawing without any prefixes. So if any duplicate named objects are there, then AutoCAD use the named objects in the drawing. So in certain cases where we do not know whether there are any duplicate objects or there are what are the types of the objects that has been defined in the original extract option, it is always safe to go for the bind option. So in bind, what we are doing is we are making the external reference as a permanent part of the drawing. That is, we are no more going with the term of an external reference, but rather it will get an integral part of the current drawing. So now when we click on this bind, now this drawing, you can see that it becomes an internal part, but now it has got converted into a block definition. So this drawing now gets converted back to a block, so that all the block options that you are going to have seen earlier can be applied here. So this is going to be useful. This binding is going to be useful in two cases. One thing is that once you have frozen all the designs of the subcomponents and then you're proceeding with the final assembly drawing, and then you just have to store it away or archive it in a location, then you can use that. You can take away all the references of the individual drawing and then make it as a single drawing. So in that case, this is useful. Or the other case is if you're integrating all the components of all the designers together and then proceeding on to next stage, and here on you do not want to differentiate between the different parts and you want to retain all those as a single part, single component in the current drawing, then you can use the external reference as a binded reference. So this is about the external reference binding. So with this, you can go on and construct the drawing that we have seen earlier. So here we have seen that this is the intended subassembly drawing with the different parts that we looked into. So you can go on and proceed with this, integrating all these components together. So when you're inserting as an overlay, and then we'll see one more command here. So instead of right clicking here and then clicking on binding, we'll now use the command prompt of way, that is you go for an X bind. So now we'll get the window for external referencing object binding. So here what you can see is you can see all the conditions that you want to bind it to it. So it means that whether you want to insert what properties that you want to have and what needs to be deleted, so that the drawing by default is going to get inserted as a block. So that we can do here. So that by default this block will be an added reference, but then what type of information that do we want to bind to it? So suppose in layers, I just want to take the layer 0 here, and in line type, this line type, randomly selecting it and then clicking on binding. So what happens is only those properties will get binded to here. You can see that the wheel casing 0 and then the dimension cells all have got binded here. You can see that there is the difference of the line properties that you have here. So this is about the X bind and using selective dimensions binding. So alternatively, if you want to bind it as a whole, then click on the bind type and then take the drawing as a whole here. So after binding this, now you might come across a situation where you need to modify this original drawing content so as to suit your current drawing. So in that case, if you see that when you click on the drawing or double click it, even after binding, it's the block element only. Okay, so even if you want to edit it out, if you click on go in the block editor command, then you can edit the individual components separately only inside the block editor command. That means this object is still stored as a block in your drawing, and whatever you're updating has to be done through the block editor command only. But instead, if you want to take into notes of separate elements, then what you can make use of is the explode command. Explode. So typically what you're doing by explode is you're breaking down this compound object or the block into its constituent elements. So this is, once you click on explode, the first requirement is the selection of the objects that you want to explode. Click on enter, and now you get the options of how to getting explode. So the first option is exploding all. So it means that it will set the color, the line type, line weight, layers all as a separate layer, and then assign the properties to it, so that each and every time it will get input is asked from you, and then you have to assign the separate color, layer type, all those things to it. So that is by the all option. Whereas going by the color, sets the color of the objects after we explode them. So this is layer, line type. So we'll look into this one by one. So if you click on explode directly, the whole elements got deleted. So in order to understand it, whether this is the property of the base object, let us quickly undo it. That is, we are retaining back into this original block definition. Now we'll edit this block in place and see how it is referred to. So in this object, you can see that if you click on this hole, that itself is defined as a proxy entity as an AutoCAD block. So it means that it's a block to block itself, and hence these blocks are not getting converted. So for this drawing, when you modify it using the explode command, you can see that all the proxy elements are removed from the original block references. So the same can get happen here with this explode object here. But now let us go by the all option. So what it asks is, it asks separately for the color. So we can go by the either the layer or by the block definition, and the new line type, that's also by block definition. Line weight as the block definition. So whatever we are using in the existing block, let us try and reuse. So what is the new layer name of this exported objects? So let us use the object layer name, retain the same layer 0. And now you can see again the proxy elements of those blocks has been removed. So this is the option of an explode. So this explode can also be done to different block definitions also. That is, we are breaking down the constituent elements into this picture. So one more thing what you can observe here is, after creating the drawing and after creating the several named instances and so on and so forth, so there are several layers that are not utilized for, that have been taken away from the drawing. So in that case, if you want to remove such instances of the named object creations, then you can use the purge command to remove all those unused named object or references. So we can click in either the purge command through here, or so once you click on the purgeable items and select on this, so you can see that all the layers that are not utilized will get displayed. And again, all these ones, the dimension styles and all those things that are not being utilized, can be purged away from the existing drawing definition by clicking on this command. So by purging away all the items, okay, Okay, so only that is retained in here that has a direct reference to it, because once you click on the non-forgeable layers, so this is the defined layers that is called for in the current drawing that has a reference to the current drawing. So in that case, all the others, because basically in your drawing we cannot see any difference, but in other sections we can see the major difference, and thereby we have simplified the drawing views. So this is how the purge command can be used to remove any unreferenced objects. So this can also be taken from file, drawing utilities, and then purge. Also, this is we have an audit facility. So this is a diagnostic tool that is used for examining the current drawing and to check for any errors. So for every error, it's the AutoCAD detects. It recommends a corrective action. So we can click the fix any errors that are detected. So it runs to all the objects that is fine to it. So whatever objects that are present in this, including the header, tables, block definitions, all those things, AutoCAD runs through its own database and see whether it is requiring for any specific editing or not. So this is the function of the audit tool. And suppose if the drawing contains errors that the audit command itself cannot fix it, then we can use the recover command in the drawing utilities. So if the AutoCAD software determines that the drawing that we are opening is damaged or based or changed automatically, then it will show the prompt. So right now what we are saying is this drawing is currently being used. So would you like to open as a file, a read-only file? So suppose if it's a damaged one, so during opening itself, it will try and repair all the errors that are found in the drawing. So this is a quick fix on the drawing utilities that AutoCAD offers us. So this can also be seen in the Manage tab, where it's available in the Cleanup tab, where we can purge the items or remove or checks the integrity of the drawing using audit.
So next is a great addition as apart from the AutoCAD interface. That is called as a design center. So this design center is something that you can use to organize the access to drawings, blocks, hatch, or any other drawing content. So it simply means that you can drag content from any source drawing to the current drawing. So it means that it is a quick reference of all your existing database, all the existing block references, all the existing drawings, so that you can quickly drag and drop to it. So this is like your own personal Jarvis, so that you can quickly invoke whatever you want to this drawing. The source drawings can be on the system that you work on, or on a network location, or a website, or your internal PLM software. So whatever it is, you can take into any drawing that you work on. Even if you have multiple drawings that are open, you can use this design center to streamline the drawing process by copying and pasting one content to other, so that you can take all the layer definitions, the layouts, or the textiles between those drawings. So we'll quickly see that now. So the design center can be invoked by two manners. In the tools menu in palette, you have the design center, or using the command control plus 2, control and 2. So alternatively, you can also go in this view tab, and in this palettes you can find the design center here. So also it is invoked by the command AD center, that is AutoCAD design center. So now this is the design center interface. So here you can see the tree structure, where we have the different folders that you work upon, and what are the current drawings that are already opened upon. So right now we have 3 drawings here, and the other existing drawings, and also you can open upon all the history that you have worked upon. And you can also use this option to search for any drawings with whatever keywords that you have defined, either in the file name, title, subject, or other modifiers that you have, because if you could recollect, we had used several block definitions attributes to define each and every block. So with that, all these individual metadata information, we can either look for drawings or blocks or layers or whatever customized text that you have inside your system or the locations. So also here you can quickly see in the design center that AutoCAD have by default. You can see all the categories of drawings that are available here, and within those drawings, suppose if we take this drawing as fasteners metrics, you can see the different categories of the info that is available. It is describes the blocks, the dimension styles, layers, and so on and so forth. Once you expand it and then click on blocks, then you can see all the blocks that are defined in those drawings. So you can see you have the hex nut on the top view, the side view, the screws, all those things it's there. And likewise in the open drawings, in this you can also see the drawings that we created, the first and third angle of projections. So whenever you want to take these into your drawings, then you can open up those drawings or the blocks that you've created and use it. So this is the major functionality of the design center. That is, you can use this design center to browse the drawing content such as the drawings or symbol libraries within our computer or a network drive or a web page. Also, we can view the definition tables for the named objects such as blocks and all those things and then retrieve, or we can update the drawing definition that is already there by editing it using the block editor command. And we can open the drawings in a new window. So we can copy the block here and then paste it in here, or rather we can directly move it around in here by pasting the clipboard point. So you can see that the object gets moved to the current drawing from an existing drawing. Also, all the predefined objects can also be taken here. So suppose if you want to take it, you can click on the insert block or double click it, and then now you get the block insertion command, and by this you can insert the block that is of reference to it. So this is the major implication or usage of the design center. So here we can, as seen, you can use the search option to go and look into search the metadata information rather quickly. So once having inserted the block into your definition, so now you can see that all the original properties of the block gets written. So here, based on the visibility that we have designed, we can select it out. And so here typically this block doesn't have any dynamic references, so but the drawing that we had created had it, so that you can use those customized drawings into your original drawing. Also, we can find out, we'll go to this design center once more, and within the existing catalog that is available, so here you can see that in the sample section, mechanical samples, you can see all those are already available in it. So certain customized blocks that are required for certain processes can also be pulled from an existing database. So it means that as an organization, you can retrieve all the existing components that were created for projects elsewhere and then reuse into your original drawing. As well as here in the dynamic block setting, you also have the dynamic blocks that we have seen earlier. So here you also have the roller bearings component and then all other components that are of interest to us. You also have the sheet sets tab within the sample folder in AutoCAD, where you have the different sheet sets that are defined in here. Suppose in the cover sheet blocks definition, if you go on, you can see that we have the title block definition here. So thereby you can use the title references, title as a block, and then you can customize it based on the data. So on double clicking it, you can go and edit the block content only to this drawing. So as we seen earlier, the block once inserted does not modify the original content. So based on the requirement, you can modify the application as required. So this sums up the usage of Design Center to utilize previously established blocks and references into your drawing, and taking references between active drawings also. So next, one more variation what we have to this is the tool palettes. So tool palettes is kind of similar to the Design Center, except that is we can custom create the palette that we want to have, just like a painter's palette. We can focus only those components that are interest of to us and then store it in a separate one. So it simply means that we can hide those extra toolbars and extra menu bars, the panels, all those things, and only retain all those are of required to us. So you can see that in this tool palette by default you have the annotation tab, wherein right from the Design Center, whatever annotations you have, the same thing has been called out here. Then you have separate sample for architectural, and then mechanical we have the valves, the metric samples and impedance samples, like waste, so on and so forth. Also we have the tables that can be inserted, and then example for command tools, leaders, specific definition of those leaders wherein we can use, and then the draw commands. So this means that this tool tab palettes or tabbed areas like this within the tool palette window. So these are all custom tools. So that is, it means that if I want to use this R, then I can drag and drop it onto here. So when dragging and dropping it, it will invoke the that command. So likewise, suppose if we want to take a shoulder screw, so I'm then dragging and dropping into it so as to insert the block model to it. So this tool palette we can use to configure several geometric objects that we have seen, like the lines, circles, arc, polylines, and then we can also create dimensions, blocks, hatches, solid fill, gradient fills, raster images or external references. So it means that you are using a quick access panel wherein you are keeping reference all the frequently used thing. For example, you can create any custom object of, say, with a fixed line type and a line reference, and then store it in here. So whenever you're using it, the same thing can be applied. So what you can do here is, on the tool palette, so on right clicking it, it has merged here, but right clicking on this tabs, you can see that you have the customization to move the palette across. So let us undock it to have more clear, and let us close it out, external reference. Yeah. So on properties, clicking on this gear icon on the tool palette, here you can see what are the different properties that are allowing for. So here you have the customize option for the palette or the command, and also we can list out all the palettes that are predefined. So currently all the palettes have been predefined. So we have the annotation and design palette, okay, and then we have the parametric design, architectural, civil, structural, manufacturing, and so on and so forth. Suppose if we click on mechanical, only those that are relevant to mechanical palettes get displayed. So for example, if you go for the visual styles, those that are pertaining to the visual styles are listed. And so if you go for the all palettes, all the palettes that are applicable are shown in here. So this is the overall general settings of this. Alternatively, you can also go for the customized palette. So here you can see what are the different palettes that are available. Suppose in this draw palette, so this draw palette
can be included in any one of these palette groups. So means that suppose if I include a new group here, okay, let me just take it in the, okay, so a new group has been inserted here, and then now we can add the draw to this new group, tables to this new group, hatches and fillets to this new group, and so on. So now when we go and take the annotation and design and then select this new group, so now we can see that we have made a custom palette wherein we have only the draw, tables, and then hatchet fills. So by this we can quickly use this. So we do not need to take the B hatch option to do all this hatching. So we can quickly take this hatch pattern and then apply to this to here. So you can now see the hatch command has been quickly executed with this command in place and then taking it in direct reference. So you do not need to have to call for this command. You do not have to edit these definitions and so on and so forth. So this is the application of a quick reference of the palette. So alternatively, you can modify these commands. Suppose for this that we have inserted, right clicking it and then specifying on the properties by which we can optimize the specific tool properties pertaining to that command. So what we have taken was a hatch command. So we'll get the properties that are pertaining to the hatch. So it can either be a hatch or a gradient, and what are the types it is, what is the pattern name, scaling of it, and then colors, the line type, line style, all those things has been described in it. So likewise, suppose if we want to go for an existing option, suppose if in the rectangle command, then again you can specify what is the colors that you want to go out to it. So by this we can customize the frequently used options that we have using within the tool palette. So also, instead of creating a new group, we can also create a new palette here, and now we can add components to it by customizing it, and alternatively you can also create your own custom course to describe that, say this is an user palette or so on and so forth. So by this we can insert elements to it. Suppose if we want to take this element, so now by dragging and dropping this block that we have already created onto this user palette, so now we can see that this has been inserted, and this palette will get carried across all the drawings that you have. So this is similar to the design center, except to the point that this is a quick reference, quick action palette that you have. So by this you can take across different components that you work on. So in this our custom panel, suppose if you want to include a a rectangle command, then you can go here, or suppose if you want to have the insert block command, then you can right click on it, copy the command, and then paste it in your new palette as required. So but thereby you can create a custom made one. You need not have to shuffle between the different tabs or between the commands. You can go for a quick drag and drop of the commands that you frequently go for. So this is the tool palettes, a powerful functionality, and the design center that we have looked so far. So let's quickly summarize the learnings that we have done today. So we have seen into several file management techniques. What is the requirement of a file to be managed effectively, and how are the various strategies that goes on to name and structure your folders, and then what are the different file nomenclature and naming conventions that you can adopt from BS 1192 standards. And we also have seen what is the importance of a version control document in your product, and the ways wherein you can try out existing version control tools that are available
as in SVN or Git, and I recommend you guys to download them, have a tutorial on it to understand how the version control management works in, so that you have a very good idea of it, and then try to apply it into your day-to-day drawings, and definitely you'll see the usage of it and will get adapted to it. So next we have seen the external references, usage of overlay or attachment. We've seen how the nested references is going to look like, and the differences between your overlay and attachment and when to use which. And then we also looked into Xbind option to bind the drawing effectively into your existing drawing so that you retain them as a part of the drawing itself. And also we looked into the explode option to break down the component into its individual object so that you can work upon. And then we saw a lot of design center methodologies where you can take in the title block references or mechanical components, and also you can use the blocks that you've already created in previous drawings to replicate in other drawings, and then you can also move around the blocks or the different properties that we see in the layers or the line types across drawings based on the design center. And also we looked into the effective usage of the tool palettes, wherein you can use it to customize your own palette based on the current drawing that you work on or the project that you work on. And you can also bring in different elements that across the other drawings that we've seen in design center into this, so as to quickly deliver the content that you intend to do. So these are the various collaborative techniques that are available in AutoCAD that you can use to enhance your productivity and also collaborate effectively amongst your team so as to enhance the productivity of the entire team. So welcome to week 10 of this AutoCAD course. So this is on broadcast die work. So in this week, we will see mostly on what are the topics that are required to project the work or express the work that we have done. So far we have seen like the different tasks of drafting and all, but how to get output of it. So that's where we'll see here. So in this week, we'll focus on what are the different plotting or printing techniques that we can make use, how to position it, how to selectively plot that area that we want to do, then the dimensions of the plotter and all those things that we'll look into. And now again in the part of the broadcast day work, we'll also look into some part of smart working skills as in macros, because this is one area that which will help you to focus more on the actual task and then eliminate any redundant task that you want to do. So thereby you can focus more on the work and then express it in a better way. And finally, we'll also look into what are the different layout management techniques that we have, what is called as a model space, what is paper space, and what is about floating viewports. So that will help us to project our different drawing efforts that we have produced, or based on the requirements of telecasting, you can do it as per the wish that you want. So we'll go into the course now. So in this diagram, let's look about how to plot it out on a sheet of a paper. So we use plotting to take out the physical copy of the electronic drawing that we have done here. So a plotted drawing can contain a single view of the drawing or even more complex arrangement of different views together. So depending on the needs, we can plot one or more viewports or set the options that can determine what is plotted and how the image is going to fit it onto the paper. So let's understand plotting first. So the plotting procedure is similar to the Windows user interface that is going to be used for printing. So the normal printer that we are going to use for A4, A3, A2 sizes can work well for the desktop printers. But in institutions or organizations where you go for large format plotters, Autodesk provides those kind of drivers to achieve the highest quality output as possible. So typically this you might have seen in certain image files, when the resolution is not okay, then it might give a pixelated output. Pixelated as in
the clarity is very low in that, and hence the printed output or your image does not look well. So that is where AutoCAD comes in to provide those drivers for each and every special application devices so as to get the highest quality output as possible. So in AutoCAD, we use two terminologies. The main terminology is the layout tabs. So in layout tab stores the arrangement of the views. So here you have the layout tabs. So this we'll look into the layout management in detail in the next session. But right now typically what we're seeing is in the layout tab, we arrange the different viewports and their views, and also we can organize a page setup that is required for plotting, a plot style table, and then a plotter configuration. Whereas in plot style properties, it will control how objects are plotted. So before jumping onto the features, let us see how we can plot it out. So first in file, we have this plot option, and also you have the plot style manager, plotter manager, and the plot preview. So plot is directly as linked to your print option, Control plus P, whereas you have the plot styling and the plotter manager and so on. So first is to get the plotter manager in place. So we'll look into how the plotter can be added to it. So once you click on this, you can see the different plotters that are available in this. So what you have here is the AutoCAD PDC. All these are AutoCAD plotter configuration files that is created for these specific plotter. So here you have the PDF generation plotters, but we have the general documentation plotter, high quality print, smallest and web and so on. Then we have DWH plotter, then drawing to PDF plotter, then publish to web. In this mode, we have the JPG or a PNG format. Also, we have other plot styles that are listed in here. So these are the typical plot managers that you have. So next is in the plot style manager, you can view what are the different styles that we are seeing here. Okay, so it's either a grayscale pattern or a monochrome pattern or a color pattern, or depending on the screening of it. But all this is included in your plot printer results. So once you click on it in the plot as the model, here you can get the name of the page setup that you need to do. So that will again look like. But right now what we're seeing is the printer or the plotter that is available. So you can see that these are the system, the Windows plotter that is available in my system. But followed with these symbols, the plotter symbols. This refers the plotters that are available, and by here we have the AutoCAD plotter that we know. So we have seen all the definitions here. So it goes by the definition .pc3. Also you can configure new plotters if you have based on a plotter manager device. But right now let us go ahead with the existing plotters. So once selected the plotter, suppose if you want to go to a AutoCAD PDF plotter and with the general documentation. So you can see that this plotter, its name is drawing to PDF. It's by Autodesk. And so then we have these options to generate the PDF. So in here you can see that what is the vector quality? Vector quality as in the line images that are displayed in. What is those DPI, dots per inch, the clarity, the resolution of those things. Then what is the raster image quality as 400 dpi. Then how the lines merge is getting controlled. It's either a lines merge or an overwrite option. Next you have the data layer, that is to include all the layer information into the PDF again, and include the hyperlinks, and also create bookmarks accordingly based on the internal information that you have. Then what about the fonts that are to be displayed? So do you want to use the existing drawing or convert all the text to a geometry type? So this is how you modify the PDF option, but this again pertains to this plotter type. So suppose if we go on to the next one, then its internal configuration gets updated here. As you can see here, the high quality prints increases the vector quality to 2400 dpi and raster image quality to 600. Whereas if you go for a PNG image, then you get a pop-up menu asking for what is the size of the configurator. So here, what is the pixel configuration that is going to be used for the image plotter? Okay, so likewise, you have different options for it. So suppose if this AutoCAD PDF is for a web and mobile application, so then the sizing is being done based on this. So this is how you modify the properties. Also, going on to this properties, you can modify or view the plotter configurations. So what port it is configured to and all that, because typically as this is a PDF plotter, you do not have a port. But suppose if there is a physical device that is connected to, then you can list in the physical port that is available onto your workstation and then configure it. Also, here you can configure the media settings, the graphics settings, and then the custom-made properties of the paper sizes and so on and so forth. So this is a in-depth view of modifying the printer properties. So next what we have here is the paper size. So within this AutoCAD PDF thing, let us go in this way. So here you have the different paper size that are available. You have this ISO full bleed, ARC, ANSI, and then architecture standards that are available. So based on the requirement, you can go for. Suppose if you want to get it printed in a ISO A2 standards, then if you click on that, you can also view the update on it. So now this is in a landscape mode. You can see here the drawing orientation also get changed. But if you want to override it, you can write it in the portrait object. So it means that the drawing orientation will be updated accordingly, whereas the paper size and the paper format will remain the same. So this is the difference between these two options. So next, before going on to this, we can also see here, what is the plot style table? So what type of control table that we need? So this was the plotting style we were looking at. So these plot styles can change the way the objects is going to look in the drawing when you plot. For example, we can plot the same drawing in different ways, emphasizing different elements or phases of construction in the each plot. So typically what it does is this plot style can override the sets for colors, for grayscale, then pen assignments, screening, then line type, and so on and so forth. So this plot style can be assigned to any particular object or layer. So in order to use this plot style, we must define the plot style in this table and then attach the plot style table to the layout or the viewport that are of interest to us. And then, so first we have to attach it and then assign the layers we have to do. So this is the plot style, but let us not dwell deep into it, but you can understand like why it is used to assign, so that you can modify the printing content the way how it looks into. And this is the shaded viewports option, the shaded plot, so how it should be displayed. And this is more relevant to the 3D plots that we use. So for 2D, for us it's not applicable. Next is the area that is of prime importance to us. So this is how controls what is gets to be plotted onto the which area or what. So this is the plot area, what to plot. So here you have plot to the display, plot to the extents, the limits, or the current view or the window. So based on the selection of this, your plot content or the view is going to change. Let us look into one by one. So let us look at this what to plot in the display area. So now let us give in the preview tab. Now you can see that this is how the paper is going. So this is your paper size. So in paper size, the image is going to get aligned in this manner. So this might not be the preferred way of doing it. So what we have done is, what to plot is the display of it. So display typically what means that it does not mean the screen that we are seeing right now. It is the overall display that is available in this current model view space. Whereas if you go for the extents, now it will go for the extent of the preset limit of this entire page. So now this is the extent that gets plotted to. So next is the limits. So limits basically is defined when you start the drawing. So based on this, that will set the plot area to be done. So right now the limits and the extent is almost the same together, so that's why you get the difference. But suppose if your drawing content is to be of a smaller dimension on an area, and if you had not defined the limits or extents properly, then you can very well see that the drawing gets isolated to one part of your paper. It is not spread across. So next case is you can directly plot the area that is of current view now. So this is the current view that we have here. So you can see that only a section of this view has get plotted here. And alternatively, or the best possible way is here again in view we can select the diff view which type of view that we want to do. So based on the view selection we can modify it. Whereas the final and best possible one is selecting the window mode. So in window mode you can specify the drawing corner that you want exactly by specifying the corner of those windows. So now when we give in the preview option, now you can see that it is well placed with all the borders in place. And so this is how you control how the print is going to be distributed. And also if in certain cases where suppose you need to file it and then give out a margin to it, then yeah, you can give the plot offset so that the origin of the printable area can be set. Also, you can give the center of the plot option so as to get the image in the center-fied form. So right now you can see that the margin has been distributed equally for this. So next is the plot scale, how it should be, whether it should be fitted to paper or you scale it to custom levels. So based on the custom level, for example, if you want to have a scale of 1:8, then you can do so. So now you can see that suppose if that is not aligned to this current area, then you'll get an warning message saying that the annotation scale is not equal to the plot scale. So let us continue and see how it is. So you can see that when for the paper size, you're plotting into ratio of 1:8, you have seen a reduced image like this. So based on the requirement, you can optimize with the scale factor to scale your drawing. So next, other plot options what we have is plot in the background so that the plot is processed along with the background. Whereas also we can plot the object line weights, and also in case of transparency in certain objects, this can also be done, but should be used only when those drawings with the transparent object is required to be plotted. Next, to be plotted with the plot styles that are applicable, and then either a watermark stamp needs to be taken in or not. Then whether it has to changes to the layout or so. So in certain cases, in certain designs, when you want to invert it, then you can make sure of this plot upside down in case. So this is your typical print plotting screen, whereas this is your extended screen. So by this we can do the plotting of the different objects that we want to do. So now we look into yet another very powerful functionality in AutoCAD called as a macros. So this macro is existing functionality in the Microsoft environment. If you had earlier used this VBA scripts, that is Visual Basic for environment for application scripts in Excel or Word, you would able to appreciate the powerfulness of this macros. So this macros is nothing but to automate something in a sequential manner. So that is what this macros is all about. It's an integral part of the Windows. AutoCAD also offers that this functionality. So what we'll look now is we'll look at what is all about macros or how to create them, how to modify them, and how to use the custom recording functionality so as to replicate it. And also we'll use how to create a custom made tool palette with our own macros that is enabled in it so that we can quickly drop into it. So a macro can be defined as a way to automate a task that we perform repeatedly with more than one command or a keystroke. So in AutoCAD, these macros will refer to shortcuts to a series of commands that we execute so as to help the process of the design more efficient. So a logical definition goes by it. A macro is a single computer instructions that stands for a sequence of operations. So that's what the definition goes by. So typically, in order to write a macro, we write in the commands in the macro section. So what AutoCAD does is it executes in the logical sequence of the commands that we entered, and based on it, it executes the task. So without any further ado, let's start right away into the recording of a macro using the action recorder. So that is available in the manage ribbon here as an action recorder. So this part is what we are talking about with the recording of macros. So we'll just quickly look into directly by this big round button here, that is recording of the macro. We'll quickly start it. So once you click on this record macro, now the first thing that you observe is that over your crosshair you get a red button that is highlighting, indicating that this session is being recorded. And also we can get here the action tree that lists out all the activities that we are going to do and what are the functions it is that we look into. So but this is the action recorder tree. So what has happened is we have clicked a record option. So as soon as that circular button has been updated to a stop, that is a rectangular button. So right now we'll proceed with a task. So let us invoke a circle command. So as soon as we click on enter, you can see that it has got entered in it, circle. So now the next part of the command is to enter the center point. So let us say the center point of the circle is going to be 100, 100. Clicking on enter next. And the next part is let us go into the diameter and say the diameter of the circle is going to be say 200 units. Okay. So next, what typically we like to do is we can go to a zoom and zoom to extend. And now this is the simple activity of drawing a circle and zooming out to the extents. Now let us stop the macro. So once stopped, you can see that the action macro window that pops up, wherein it asks you for a macro name, and then file name, it's always stored under the extension of ACTM, and then what is the path that is going to use. Next is the description of the macro, because in due course of time you can create n number of macros that you want to do, and you would have given a well-defined command name as we have seen in the earlier session, but those will not still be enough. So suppose that you can name it as a circle macro. In this case, the description will goes like, you can enter n number of text here, but the concept is a circle with center of 100, 100 and with a diameter of 200 mm. So next what you're doing is, next step is zooming to the extents. So these are the actions being executed by this macro. So this is what you're trying to say. So once that is done, you also get a pre-playback view restore option. So we can either enable it when passing for user feedback or once the playback finish. So this is, we'll look into the next step, but right now let us, because this is a part of an extended command. And right now what we've done is we have recorded a macro. We are given suitable command name and also description to it. Now clicking on OK. So now what happens is this macro gets updated in here. So here you can see that it's also listed in the drop down menu what is the macro that is available in this drawing. So also now let us look into the other commands that we have. So first here is the message command, inserts a user message into the action macro. So it typically means that we can add a thing. So say this is a macro prompt. So we are inputting the user message into this macro. You can see that this has got appended into it. Also in the circle macro, we have the next option to select the base point of the reference. So what we have done is we had inserted the base point as the center point as an input to it, but rather we can do it. So but just to park it a while. So let us remove it. Now let us run this macro. So we have selected the circle macro and then click on play. So the first thing is what in this logical sequence what you're getting is the user message, whereas we're saying this is a macro prompt. And once click on close, you can see the action has been completed and pop-up menu says that the playback of the action macro is complete, and you get the final circle with all these parameters that is in it. So this circle is of diameter 200 mm, the center point is of 100, and then also we are zooming to the extent. So in order to showcase the zoom extent properly, so now we have zoomed back. Now we click on play. You can see that it comes to the original requirement that you want. So typically putting together, what we are doing is, even though for recording this macro we have taken a lot of time, but when executing it's a very fast activity based on the commands that we have already plotted to it. So this is the direct and powerful functionality of a macro, wherein we can automate any task that. So it means to say that you do not go ahead and draw a circle every time, but other activities like, applying layers. Suppose in your drawing it's an unlayered drawing that you're importing, then you can assign the layers to the different properties based on its dimension, based on its font color, based on the hidden line types, all those things. Then you can automate it. Or else what you have to do is you have to execute a filter command and then select the components, then assign a layer, and those kind of things, if you're doing on a repeated basis, you can automate it through macros. So that's the basic info behind the recording of a macro. So next part is that after creating a macro, we can go ahead and modify the macro value that we want. So first thing is, you can see that when you can right click on the value and then click on edit, so that you can modify the parameter that you want to do it. So now we'll modify this macro with these parameters. So now after modifying this, now if we click on replay again, now you can see that the updated macro has been executed. So this is the quick way fix of utilizing the macro in AutoCAD, because the basic funda behind macro is you're writing a sequence of steps in order to automate a task, and on the background there involves a coding of the commands and the sequence of execution. However, the action recorder is a quick fix way of doing it, because all you see is a graphical representation of the selection of the activities, and then all the modification again you're doing it the graphical manner. That is, you do no longer go and edit the coding behind these fundamentals. So this is the direct application of your macro action recorder in macro. So other ways of modifying this macro is that once you've created it, what we're seeing is insertion of a user message into the action macro so as to give out a prompt. We can also give out any requirement of user input for passing. So suppose if you see on the command that we selected here, suppose if you want to give a pass and require a user input to be plotted, then you can give the selection based on it and then give out this user input requirement. So what we have done is, now we have selected the user input for this center point as well as the diameter point. So now if we execute the command, you can see that at the point you get a prompt again to specify for a center point of it. So what it means is you are building out a customization into your macro. That is, you are bringing in a dynamic input to it. So thereby you can use the same macro but with different combinations of the command. So this means that after creating a macro, if you want to customize it based on the application that is required, so that you can think of all the dynamic inputs that you can put forward in your macro, so that it can be a common macro that can be used across. So that is where this pause for user input will help you to do it, because there is no point if you in giving all the inputs as a user input, because then you can directly execute that as a command. But you can use this user input pause judiciously, so that with the minimum amount of commands or inputs to the system, you can automate a wide range of tasks. So next you have the preference for the macros. So as you could see that this action recorder panel, should it expand on the playback, expand on the recording, and prompt for action macro name. So this is what the pops up menu that we are getting it. So you can customize based on this. The next thing is this one. So now we are jumping into the actual details behind it. So those who are familiar with the macros in Excel can understand that this is the same dialog box that you get in Excel. So here it lists all the macros that are being available in the current drawing. So now this is the macro that is enabled, and you can see the description that goes into here. And here we have the option to rename a macro or copy and duplicate a macro so that you can create a variant out of it, or modify the macro and delete it out. So next, again, this options is where you can go much deeper into it to see how it affects the recording. So where it is getting stored, and then what are the additional file locations and all those things. So this option, let us hold on a while. We'll look again for the in the deeper coding section of it. But once you click on the selection macro and click on modify, you can get again the commands to it to change this command. So this is what the action macro manager is all about. So now let's look into the background part, how what happens when this action macro is being played. So towards this, let's just invoke this command line, and then now for simplicity's sake we'll remove this editing, and also we'll remove the user inputs. So now we'll click on the play action. So now we have got the macro. So now let's look into the steps that are taken into the macro. So what is the command itself is direct calling of the function. So this name of the macro is a command for execution. So next, once you click on it, then it goes into the logical sequence of it. It is calling a circle command, and then it is entering all the commands that is required for it based on the selection, based on all the action, and then gives out that the action has been completed. So typically what it's doing, you are kind of emancipating a robotic user to repeat a task. So even in the background, the same activities are being taken care of, and none of it is being left out. So this is about your action recorder, a pretty straightforward way of automating a simple macros. Okay, so now we'll look into the coding part of the macro. You have seen that using the recorder, action recorder, it's a direct application of the macro. But what is happening behind? So let's look into each one step by step. So before that, we'll also try to understand what are the syntax and rules for writing the macros. So once we have created a macros, we can use them in whatever conditions we want. In almost all the applications we can do it, because in action recorder we have one limitation, that if there comes any pop-up window wherein you have to specify the properties, then it can be challenging task. But in a macro, when you write them by code, you do not have such restrictions at all. You can go for the pull down menus, the ribbon panels, the toolbars, tool palettes, whatsoever. So to come back to the basic definition of what is a macro. A macro is a text string that combines commands and options that are being heavily used for repeated use. So it's kind of way of taking the command line input, whatever we are using it here, and storing it for later use. So that one click of the mouse can accomplish a drawing task, whereas it would have taken in a normal way by a series of action, list of actions. But instead of on a single click of those invoking the macro command, you can run it out. So let us start with this example again. So how do we invoke the circle? So towards this, let us quickly go to the M text to just have in here how it's going to look into. So the first thing is the command circle that you have to enter for a circle. So it starts by this. It starts by the command of circle. Then as soon as the circle command is done, we'll also try and expand it out. See, once the circle command is executed, in order to go to the next command line, we're clicking the enter button. But in order to make, okay, let me just quickly take this out so that we are on the same line. Okay, so this is the typical way of running the command using the command prompt. So that's the first thing that we're going to do, the circle executing. But next is we have to click on the enter button to go into the command. So the command syntax in macro is that it's executed by a semicolon symbol. So the effect of this with a semicolon is the same as typing it out and pressing out enter in the command line. So next is we want to take in the user input. If you can recollect in the macro action tab, what we had done was we had given a symbol for passing to take in the user input. So because next command is we need to specify the center point as the default. So towards that, we need to execute this slash command. So that will tell AutoCAD to pause for a user input. So next, once that's done, then it goes for the next input. That is, we have specified that once the pass has come, you would have specified the center point, and next is entering the value of the prompt. So now AutoCAD expects us to feed in a radius. So that radius is 50 units for us. So there goes the number 50. So once it's done, we need to come out of this command to execute that. So it's done by pressing the enter and hence semicolon again. So this is how the command looks like. You have the circle, semicolon for enter, slash for user input, and then the radius, and then closing out the command. As you can see here, the command, the normal action points have all been replaced by a single line of code. So this is how macros are written, and this is how they are very quick to execute. But one another thing, this executes a macro, but there might be certain conditions when some other command would have got run before we are executing this macro. So in order to make sure that any existing running commands are cancelled, we prefix this command by using the caret symbol C caret C again. So what it does is this caret C means cancelling. So we are cancelling twice so that it comes out of all the steps that might be in the previous command. And next step is that we also include an underscore between these. That is, you execute two cancel commands, and before executing of this command, you introduced a underscore so as to force the macro to use the English definition by using the underscore. That is, use only the circle definition so that it eliminates any issue. So that this is the basic special characters that are being used in the macros. So to quickly look into, we use the semicolon for we enter, and if there are any requirement for blank space, then you can enter blank space by typing in space. And next, this is for the user input, and next underscore is for translating AutoCAD commands and options that follows this to the English language. Then you have this hyphen arrow, so that will run the command line version of a command. That is, if this command line version is going to be C, then you can replace it by -C. And also we can, repeat the command by putting out a star icon into it. So that is, unless otherwise it is cancelled. Sorry, this star precedes it. So unless otherwise the user cancels the input, you can repeat the macro continuously. That is, you're looping it out. And finally, we have one symbol called as the dollar that is used for decel expression. So this decel is another proprietary language code that translates as direct. Okay, let me just type it out. So this dollar is another programming code that you use for, that is, direct interpretively evaluated string expression language. So this is another language that you can use to code your program codes, but it means that using this symbol as dollar as prefix, you can enter your diesel code into your macro. Also, there's something called as a list. So this list that we'll see in the next session is an acronym for list processing, and it's another high-level computer programming language that's used in artificial intelligence system. So this is also another programming language that can also be used within the macro environment. So, but right now, let us not focus on these and only focus on the basics of this command. So now we have a macro in place. So this is the macro that we want to evaluate, but you cannot directly enter this macro onto your command line. This AutoCAD does not identify this command that is being entered in the command line. It just shows us an error that it is not able to understand the command. So then how it has to be executed? So we need to have a place to execute it. So this macros can be added to any interface element using interface editor called as the Customize User Interface or CUI. So this CUI, Customize User Interface, is a separate topic by itself, but let's see it, the basic bare minimum requirements to key in a new macro command. So as you can see in this interface, we can have a look at all the commands that constitute behind the background or behind the execution of your AutoCAD. So this is what has happened inside. So this is the existing commands, but right now we're going to create a new command. So clicking on this will invoke the new command option. So this is where we get a new command. So first thing, we can give the name of this command. So we'll say custom circle for our understanding. And now this is where we enter our macro. So this is going to be circle colon /50 and the semicolon. So now the name of this macro is custom circle and the macro that is executed is this, and if required we can allocate any image that we want to put in here. So let us just take this as the image that we want to execute. Okay, so now this is got assigned onto your command list in here. You can see that the new command has been created as a custom circle that bears the command as here. In the description, this plots a circle with 50 mm in radius. So now this goes into the description of this command for us easy understanding. So now clicking on OK means that this macro has now been added into the system. You can see that it has got executed in the background and then it's stored in the memory. So now we can go ahead and call the circle. So after saying this macro, one key thing that we have to understand is that even though we have given a command name, this command display name is not of major use to us because we cannot call them from the command line, because even when you call it in here, it won't execute because it is not a command that it can understand. So the first way of using it is in the CUI interface. In the CUI interface, so to use this command, we have all the options of putting this out in the CUI editor itself. So we have the ribbon panels, the toolbars or menus. So what we can do here is we can take this thing to the menu that we want to do. Suppose if in this toolbar we have here the draw toolbar. So in this draw toolbar, we can introduce this by dragging and dropping it. So now this is one way of doing it. That is, within this customization tab, we are updating this tool. So now you can see that. So now we can see that our custom macro has been plotted out in the existing toolbar of draw. So now when we click on it, you can see that the prompt is being displayed for the center point. Once clicking, you are executing the command. So this is the macro using the CUI editor interface. So now what we have done is we have pasted on a toolbar. So alternatively, we can also put this macro onto any menus that we want to place, or in the ribbon panel, or and most conveniently into your palettes. So in the last session, we had seen about the tool palettes. So the tool palettes already, it represents the custom work panel that we have here. So already we had created blocks that are custom made for us. So now we can also use our macros to be placed inside the tool macros, the tool palettes. So this again by dragging and dropping it. So now you can position it into the custom. So what it typically means that is you can use this customized user interface panel to optimize all the workplace, the viewing on the screen to your convenience. So for example, you can modify the double click actions for different commands and how it should work about. So all this has been included in it. And also you can do a chain of activities using these custom macros that we have. We can also invoke in this tool palette, we can give all the custom macro commands that we have along with the other hatching tool, and all the actions that we want to repeat can be taken here. So now we'll see an additional modification of existing commands that we have to suit our own purpose. So we'll see an example of how to change the text case for any text command that we have. So towards this, we'll invoke the CUI menu, and in CUI, when you click on the text, you can see that there's already one that is available. Change the text case. So we'll now drag and drop it to our custom panel that we have here, and right click on it on properties. Here you can see that all the tool properties of that is being listed here. So this is what the command goes in. So we have the tcase command to change the character to the higher thing. But right now, so this is the existing command. So we'll see how this existing command works first, and then looks into how to modify it. So we'll select this text and then click on this change text case. Now we can see that the command prompt opens up, and we have the option to change it entirely to the uppercase or title or lowercase or toggle case, that is switch between the uppercase and lowercase respectively. So this is the existing command that we want. It's already there. But let us now modify it to our thing, that is, we change text case to uppercase. That is, we want this to change the case only to the uppercase. So in that manner, what we're doing is we are modifying it using this two double caret symbol to make sure that it cancels out an existing command twice, and then we'll click out a hyphen here. This hyphen, as we seen earlier, it will suppress the dialog box, because once we click it, we got a dialog box prompting for what case we are in, because we're not going to use that, but rather be driving within the command itself. And next is we have to click in the enter, that is we are suppressing the command, that is we have to go into the tcase command. So taking a semicolon, and then a user input should be prompted, a slash, and then again entering, and then what is being required, because this slash will ask to select the object, and once that is done, this semicolon will terminate it, and then finally what should we choose in? So we need to go for the uppercase character. So we'll give it the U and then close the command by a semicolon. So now we'll click in OK, that we have modified this. So once we click on this, so you can see that the select object appears, and once it's done, so directly we have skipped certain steps in the given macro. That is, we have taken a exist system command and then we have modified it to suit our purpose for a specific task. So this is also a very good example of to see the how powerful the macro can be. Also, what you can do is you can modify it. So this is the system image variable. So indirectly what we can do is we can modify the image of it. If you have an image, you can take it. So likewise, if we want to modify it, then we can paste it as one more thing and then change this to, for example, in the say toggle case. So in that case, you modify it to be and this is how you update your existing codes into custom codes using macros. So now in AutoCAD, we have one more interface for this macro called as the VBA macro, Visual Basic for Applications macro. So actually the functions that we have seen right now with the action recorder and the custom macros for AutoCAD sort of had a basics to this VBA macro. So, but considering the simplicity and the ease of customization, the current macros that we have seen is of prime importance. But for knowledge purpose, let us also quickly look into the heritage macro that we have here in VBA. But catch point here is this VBA is constituted by Microsoft for this Excel application for that uses the Visual Basic as the programming language. So this Visual Basic programming language across different applications. So this is where this VBA comes in, Visual Basic for applications. So it means that you can sync your AutoCAD application along with an Excel application or a Word or whatever you have. You can take data across. That is, you can have a single coding interface that can very well work within different applications. So that is where this VBA macro helps us to do. So let's just quickly see. When you click on this run VBA macro, we'll be getting in the requirement for macro name. So let us go ahead and then plot a circle again and see. So we'll just give it a circle macro and of course VBA. And once we give on the macro name, so we get this option of create highlights. So now we have to attach drawing or the project to the macro. So we'll attach the current drawing that we have here. Once it's done, we'll get in the VBA editor interface where we have the project tree where we can see what are the modules that are being called for, and then we have the watches diagram that will be useful for us to decode the drawing, decode the code, but typically this is where our coding page comes in. So here this is the function. Let us not dwell deep into it but have a small overview. So this is like a typical coding functional wherein you have a function. So this circle macro VBA is a function that is called for with a end sub and end sub, opening and ending of this section. So into it, so typically what we have to do is we have to declare all the variables that we are going to use in this application. So first thing is we have to know how the circle is going to drawn here. So this circle command is the add circle command that is into the VBA code. So it requires a center as well as a radius. So towards this, we'll define the assigned variables and define them. That is, so dimension circle center. So this is the variable name, but we'll create it as array
of 3, that is to x, y and z, and we'll define them as double data type. So likewise, we'll define the circle radius. As you can see here, the variable names and the nomenclatures are highly case sensitive. So typically all the first letters of the word start with a capital letter, whereas the commands also start off with the capital letter. So we need to take due care in ensuring that the system variables are not used as commands and vice versa. So all the coding language care that we take for other applications, for other coding language, be it C or C++, the same thing can be taken here as the understanding. So now we have created two variables to bear the circle center and the circle radius. So now we have to create one variable to hold the circle object in order to draw it. So here we'll define as a circle object variable, and it's going to define as the AutoCAD circle element. So these are all inbuilt object libraries that are within this AutoCAD VB application. So we are using this inbuilt to define how it is. So now let us go ahead and define the values. So circle center, the first variable. So let us say it is of the x is 250 and y is 250 again. And z is 0. So next is we'll assign this circle radius, say 100 units. Now we'll set the circle object. So how it is going to be assigned. So here the function calls that it is attaching to this drawing dot. So dot is a nesting of this function. So here once you click on dot, you can see the requirement. So now we'll go into the model space of our drawing, and within that model space let us go by the command of add a circle. So once you open the parenthesis, you can see that what are the prompts required for it. So first thing is the circle center, and next is the radius. Here you can see what are the data types that has to be declared and what is the object type that needs to be declared. So that is how we have declared the circle radius, circle object and circle center. So now declaring a circle radius, and now clicking on enter. Now this completes our macro codes. So we have a lot of debug options and all here, but right now let us run this macro and see. So now we can zoom out and see, because we have given a different radius here. So here you can see that object has been positioned at a dimension of 200 mm in dia. So you can quickly see that the dia is of 200 with the axis points being at 100, 200 and 200 mm. So this is how we can also draw or execute a function using the VBA macro script. So now we'll discuss about the other topic, that is of layout management or handling layouts without templates, and then what is about model space and what is paper space and what are viewports and all. So typically layout management is something that when we are working on a drawing in the model space, that is this space that we are seeing right now, then from there we can create specific viewports so as to display different views of the same drawing. So it means that I can create multiple viewports of this drawing based on our convenience or based on the requirements. So now we can save and then restore the different viewport configurations that we have created and then edit the model very seamlessly. So once the model is complete, then we can use the layout tab
to prepare them for plotting. What we have seen earlier was plotting the entire drawing, but instead we can use this paper space environment. This is the layout environment, so that we can simulate different sheets of paper. So with this, what we can do is we can set up that this is what is going to get exhibited in this plotting setup, so that we can create separate viewport objects in a specific layout, and then add separate title blocks or something to that layer, and then take that layout for a plotting of paper. So that makes the task all the more simpler, because if it's a simple drawing, then you can use the same model space, export it using the window command and all. But with the paper space, we have a flexibility to control what is going to get printed in the whole drawing. So this is what the overview of the layout management system. So going in detail, in this model drawing is where we'll actually draw all the drafting that we are requiring to do. So once it is done there, for plotting, it is much more effective to see, because see here you have colorful icons that base for our ease of viewing. We have these many layers and colors that we have used here. But in order to print, how to understand how it will be reflected on the paper. So that's where we will be moving over to the viewports to create in the layout tab. So first thing is we have understood that this is the drawing environment in the model space. So here the model is being sketched on a real world units, that is on a scale that is directly required as it 1:1. Next, we can now move over to the viewports by clicking on this layout tab here. So now we can see that this layout tab, now it zooms out to the entire window and then plots to it. But likewise, if you move on to the layout tab here, you can control how so as you could see initially, both this paper layout tabs are one and the same, because it is just replicating whatever you have in the object. So the first understanding is how to differentiate between a paper space and a model space is that in this layout, in the paper space, you can see that we have an icon, so this is in a layout tab. Whereas in model, we have a XY icon here. So this is the first and foremost difference that we have here. So next, in order to, this is the custom layout that we have. So first, let us go out and see how to create a new layout. So towards that, we have this in the tools menu. In wizards, we have this create layout. So in this create layout, it's where we can go through a wizard based layout creation, that it will guide through the steps that you can do it. So first is the title of this layout, and so let us retain the same title. And next is where you attach a printing setup to the layout that you are creating. So suppose you have a different type of plotters that is already available, then you can attach a unique plotter to a unique layout. So this is the first and major advantage of having different layouts, paper space layouts that you have. So suppose let us go ahead with plotting this as a JPEG, that is as a PNG, an image file. Then you can select that and click on next. So based on the selection of the plotter, the size is also determined. So based on the resolution or the configuration that we select, the dimensions are automatically plotted. As it's an image, it is saying that the dimensions are going to be in pixels. And this is what the dimension of your plotter is. So we'll go with the default one. And now we can control how the orientation of the drawing on the paper is going to be. So right now it is in this format, but as you can see the orientation here, suppose if you click on landscape, this is how it will get printed. The view can be same now, but in printing it will get modified there. So let us go with this. And next is the important part. It's the usage of a title block. So if you have a custom made title block, then you can call those blocks as a part of this drawing and then include that in the drawing. But right now we have already a title block defined in the model space itself. But as you could see in the next couple of moments, you can see that where this title block will actually useful when you are calling it in the paper space. So now let us just proceed without any title block.
And next in viewports, this is where we can custom import any viewports that we want to do. But right now, let us proceed with the basic viewport. That is, we are not going to create any viewport. That is a single view alone. Now, then later into the drawing, let's see how we can add different viewports. So we'll click on this none viewport setup and then click on next. You can see that we have skipped one step here in the pick location, because as we have not selected any viewports, it is directly prompting to finish the layout configuration. So once that is done there, the new layout is generated. But as you can see, there is no configuration has been attached to it. That is, the model space is not yet linked to it because we have not created any views. But you can see that as in you are in the layout area, this layout tab has also got introduced here. So now let us go and introduce the different views that we want to do. So one way is doing the preset views that is already there, or let us go and introduce the viewport directly. So that is invoked by the commands viewports, and now you get a dialog box calling for the different views that you have. So this is a single viewport that you can see in preview, and you can also see what is the current view is. So what are the different views that can be mapped to it? Either the current view, this current view refers to the model space view that we have. And again, what is the setup that we have? Right now we are operating on the 2D layout. So we go ahead with this 2D. So suppose assume that we have 3 layouts and we want it to be displayed in this manner. Then you can see that once you click in here, for 3 you have left, right, above or below combination or vertical, horizontal combination. So that is how you can create different views. So now let us just go ahead with this 3 left views and see how it impacts. So now click on OK. And now it is asking for the corners that needs to be specified. So what is the overall views that we want to align? So assuming that this is how, within this is where my 3 views have to be positioned. So once you click that, you can see that the drawing gets aligned very beautifully into the different views. But right now it's all one and the same. So how different it can be is that, supposing this is the main diagram and you want to zoom a particular part. So now what you have to do is you have to select the view that we want to do by double clicking on. By double clicking on it, you can see that you will enter the the kind of a model editing space. Now you are in the paper space only, but now you can edit the component. So in this editing view, now you can use the zoom functionality. I am now using the cursor and also this interactive ribbons. So now you can see that now I am zooming onto the bearing part in this. So clicking on escape to come out of that function. Now I'm just moving on to here, clicking the left button. Now I'm zooming to this part. And here, let me say I'm just zooming into the bill of material part. So this is how you can customize the viewports that you have aligned. So this is one way of doing it. So the other way, now let us create a dummy layout. Okay, so now where we are creating a new layout, the previous properties of the model space gets applicated. So now what we can do alternatively is that in this major view, because as it is already has a title block, because here you can see that at the end of the zoom view we do not have a title block, so it makes the referencing all the more difficult. So now what we can do is we can create a rectangular entry here wherein we are creating the custom viewport, and now on double clicking on it again you can enter into the creation mode. So now this will serve as a detailing to you. So now you can see that the required view is zoomed to it, but you have to take care of like where you are zooming, because now so now click on the outer space so that you can come out to this part. Now if you want to edit again, now clicking on this, but as you can see now this editing is not up. So you just have to use this lock unlock properties so that you can modify the views that we want to do. By selecting the icon here, you can select what is the zoom ratio also from here. So this is one way of using a detailing view that you want to paste into here. And now once in the editing mode, you can also use the other commands for highlighting the section that you have here as a detail view. So this is one application of using the viewports to create custom detailing for specific printout layers only. So this sums up the viewports and model space and paper space layouts that you have to create custom made plotting made easier. So in this session, we saw a lot on what is printing is all about, how to use the window-based printing, how to base the limit-based printing, and what are the different plotter configurations that we can do, and what are the dimensions that we can control, and how to call those things. And that we focused on a little bit on the plotting and printing part. And then we spent a quite amount of time to view what are macros all about, how to record the steps and then project it out, how to create your own custom macros and then paste it in tool palettes. Those kind of exciting things that we have seen. And also we looked into a little bit on the visual a VB editor for this macros. So hope you'd have got a gist out of it. So I would implore you to explore a lot on this macros, because in due course of time, even though it might seem a little bit complex in the beginning, towards the end you will find yourself very comfortable with working around with macros. And again, in the next session, we'll also look into an added part of it to create our own custom codes. For macros, we are looking at only system variables, how we can tweak the system variables. But in the next part, we'll see how to use our own functions, create our own commands within the AutoCAD environment. So this macros is a little bit overview of the programming side of AutoCAD that you can use to automate things, automate redundant things that you have are being doing. So next also we looked into the layout management part, where we saw what is all about paper space and then how to create different viewports that are of interest and then attach different printing settings to different layouts. So we looked into usage of both the wizards and also creating a generic layout manually. So with this we conclude week 10 of this course.
Today we are going to see what is AutoList about and how it can help us to be a smart worker in the AutoCAD environment. So let us go on first. So far we have seen so many techniques that are pertaining to AutoCAD drafting, editing, and publishing, all those things we have seen. And in the last week we had seen a special section on macros. That is how to use inbuilt AutoCAD commands, but in a differentiated way that we want to do. But in this week, we'll see how to use the inbuilt AutoCAD commands, but also build on your own codes. That is, build on your own command. It's not a generic AutoCAD command, but rather it's your own code that you can make AutoCAD to run so as to give the necessary output that you want. So we'll look into that specifically in this session. So we'll touch upon a little bit on what is all about programming is, what is the basics of it, and how it is correlated to this auto list. So first and foremost, we have to understand that programming is nothing but seeing things in an algorithmic way. That is a sequence of steps which will help you to replicate the actual process. So to simply put, if you want to boil a milk, then the simple way is to take a can, take a vessel, pour the milk into it, and then start the stove, burn it out, and then keep the vessel on it, wait until it froths out, right? So this is the step-by-step procedure to boil a milk. So depending on the utensil that you have, or depending on the type of vessel, the type of burner that you have, it's a automatic burner or a manual burner. So the steps can vary. So typically what you're doing is, you're quantifying the actual process that is happening in a day-to-day life and then try to replicate that in a sequence of codes or representations that is also called as an algorithm. So algorithmic way of dealing and actual things in a systematic way is basically what programming is, to put it very crudely. So this programming can be applicated in different styles by different programming languages to use. But at the end of the day, all target the same output. Suppose if you want to, take the previous example of the milk, or rather in a better way, if you want to, print out a sequence of steps on a paper, so you can process the same steps of printing some stuff on a paper through different programming languages in different styles and different methods, but still the output is the same, still going to get printed on the paper. So the various programming language based on its structure and architecture will process the set of instructions in different ways, but it still will lead to the same output that you are wanting to. And next is as said earlier, now from programming language to other, the inputs, the coding style, and the algorithms can vary between one another. That is, one might be more efficient to perform on a given platform when the other can be very efficient, suppose if it's taken in a mobile platform, whereas another programming language is efficient in a distributed computing platform. So their input, their style and algorithms can vary based on the application that they have, but please do understand that at the overlay, the concept is all the same. You're still looking at algorithms of how things process from one step to another. So the whole concept of this is going back to the first step. It wants to make life easier. This programming does not want to make your life harder. So the first overwhelming thing that you look into programming is that we'll get bogged down by the complexity of the coding. But please always do remember the basis of it. You always are trying to replicate the actual process of what you're doing it in a programmatic way. So always keep the end target in mind so that it will always help you to program better in a good way. So having a little bit touch up on this programming will go into, so having a basis of all this programming will go into why this kind of programming is required in AutoCAD. So we have seen in the previous week itself, there are certain tasks that are very mundane in nature and heavily repetitive. So time is a very valuable resource that we do not offer to waste. So in certain cases where you keep on doing the same activity over and over and again, and it is worthwhile to explore certain techniques that will help you to reduce those times. So that is one primary requirement that we have in AutoCAD, so as to eliminate the mundane and repetitive actions. And also, there are certain tasks, they might not be mundane and repetitive in itself, but they are non-value added. So value additions are something that, can turn as real value, a tangible benefit to the customer, or an intangible benefit to the customer. So something like that is a value addition process. But suppose if those tasks are not value added in nature, then it is nowhere going to help either you, your organization, or the end customer. To put it simply, the task of drafting is a value added activity, but the task of moving the files, searching them, indexing them, renaming them, and those kind of file management activities can be considered as a non-value addition, because the name of the file or the name of the part drawing is neither way going to help the end customer nor the people in the organization after you. They might be interested in the revisions, but they do not bother about where it is located in. So the time that you spend on in categorizing them and analyzing them can be a non-value added activity, unless otherwise you try to cut it down. So next is, certain tasks require certain additional or custom commands that are required by you. So it is not covered in the AutoCAD dictionary. So it means that you want to design your own custom codes or custom commands that you want to work out with. So this is the primary requirement. So here you can see that there are three major activities that you might always encounter in your day-to-day interactions. So that the first one is certain tasks that might be mundane or repetitive in action, certain tasks or non-value added action, and then certain tasks require additional or custom commands to be executed. So these three primary requirements will call for a custom coding within the AutoCAD interface so that you can fiddle with. So this is why programming is required in AutoCAD. So that's where the AutoList coding comes in. So what is AutoList about? So list is something called as a list processor. It was introduced somewhere around in the 1950s, primarily as an artificial intelligence language. So this artificial intelligence in that, again, as the name suggests, it wanted to make the computers to think better for themselves. But that is the crude way of putting in artificial intelligence too. But currently, AI means that you figure out some way of automation into the things that can replicate certain tasks that humans do. That is identifying clusters of images, identify whether an image is a dog or a cat. So those kind of algorithms are constituting AI currently. But this list was constituted initially to help out with the artificial intelligence languages. So then this list programming, it got built into the AutoCAD environment itself. See, fundamentally, we have to understand that AutoCAD itself is a programming interface. That is, all the commands that we execute, be it a circle, be it a spline or all, it's all constituted by underlying commands that execute in the GUI, that is the graphical user interface that you see on the screen, is interpreted as a computer coding language that will make the computer to understand that the user is requiring a circle to be plotted. The user is requiring a spline of these parameters to be plotted, so and so. So this is the CAD, computer aided designing. So obviously program is the background of all these things. So this AutoList was built as an addition to the existing AutoCAD platform as an inbuilt procedural programming language. So this was introduced in the year 1986 in AutoCAD. So with this, what people were able to do is they were able to customize their own commands built in along with AutoCAD commands so that they can create their own codes using this AutoList functionality. So that is where this AutoList started getting very famous. So this AutoList is typically an interpreter that is embedded into the AutoCAD software. It means to say that you do not need to download or install anything specifically. This package is embedded into the AutoCAD software, but it is something called as an interpreter. Interpreter in the coding language means that based on the commands that we have executed, it will interpret the meaning one by one. Whereas in certain coding languages, you might have come across a word called as a compiler. A compiler, what it does is the high level machine language, it compiles into the machine language part and then it try to give out the code. So what a compiler usually is useful for is to debug the code. But in an interpreter based environment, debugging is kind of difficult. So we'll look into the debugging part later, but you have to understand that the AutoCAD AutoList feature is an interpreter based that is embedded into the AutoCAD software. And finally, AutoCAD do not have an IDE. So IDE means an integrated development environment. So what integrated development environment means is that you can write in the code in the IDE, write the code, execute it, compile it, or interpret it in whatever way you want, debug it, and then finally give an output, all in the same environment. So that is what an IDE means. That is, it's a one-step solution for all your activities. But AutoCAD is not an IDE and it do not have it. It just have one visual editor that we'll see in the upcoming slides. But as we do not have an IDE, so typically what we use is we use a text editor, something like a Notepad or a Notepad++ to write in the codes and then port it over to the AutoList editor. So this is the another major difference in AutoCAD, that this AutoList is not an IDE based environment here in AutoCAD. So we'll look into a few fundamentals of AutoList, and please bear in mind that this fundamental is going to be almost the same for all the programming languages, basically speaking. but there might be very lot of differences when we go on in depth. But typically, all the programming language has to get something a base to build on. So likewise, in AutoList also, we have something called as a list. As we had said earlier, this list, what we have spoken about list, auto list, stands for a list processing. So typically means that auto list process a list of activities. So this is the first and foremost funda of auto list language. So we look into one by one now, but this is the first one. Second is, as in all other programming languages, we have something called as the data types. So we define something as attach a property to a variable or a function saying that it is of this nature. So please do not worry, we'll look into each and one in very detail. But as we've seen earlier, the first is the list that are unique in the auto list environment. And next we have the data types. And next we have functions. Functions are something, sequence of activities that have to be executed that is taking precedence. So this is called as a function that makes use of list and data types. So inside the functions, you need to pass something, a variable or an argument saying that you have to do first this and then this. So this and that, what does it represent? So that is where your arguments will come in. Your data types define those arguments. So this is the fourth type fundamental that we have in AutoList. And finally, the major one and the most useful one in this programming environment is the comments. So comments are nothing but user readable text that are not processed by this interpreter, by this AutoCAD interpreter. So what it means that AutoCAD interpreter leaves those sections that are highlighted as comments and do not process them. So in a coding environment, always the best practice is to ensure that you properly comment all the processes that you do, the start and end of a function, the purpose of the function, and then maybe a logical introduction to the the sequence of codes that you have. Because programming is something like a set of modules. It means that kind of a plug and play device. So typically, a good program is the best plug and play device. It means that when someone else uses this piece of code that you have developed into their main work environment, it should be useful very seamlessly, and all the operations that you are doing, suppose some bit of code, if they are required, they can easily call for and execute it and then modify upon them. So those kind of readability is incorporated into the coding using comments. So they form a very important and integral part of any programming language. So this is basically the funda about all the AutoList programming sequences. So to put it simply, we'll start off with list. So this list can be defined as anything that is enclosed within parentheses. It can be defined as any number of data, but all are enclosed within parentheses. So this is how it will go. So a normal sequence, you can see that we have function and arguments, but in order to AutoList to understand that it is a coding or that it should interpret, it should always begin and end with a parenthesis that is highlighted here. So how it does it, let's look at some examples. So here within parameters, we have three variables x, y, and z. We have to notice the sequence of text here. Now these variables have all be separated from each other by a space. So this is how the basic structure of a list is going to be. That is, each item in the list should always be separated from other items by a space. So this is the first example. Secondly, within the parameters, now we have a system variable called as a print c. So print c, something what it does is whatever follows that in double quotes can be printed out onto the screen or as per requirement. That is, it is giving an output onto the GUI screen. So this is a system variable. We are not defining the x, y, and z are our own variables, whereas print c is a system variable that is defined already into the programming language. So we are calling that system defined function so as to do a task, but still it is listed within parentheses. And finally here function called as a set q space x space 1. So we are setting the variable x as 1 in this expression. So the point to be noted here in this list is that all the format of this auto list expression is always enclosed within open and close parentheses. So this is what the list is all about. So next, going with what are the different data types that we can use for. So data type is something that you're assigning. That previous slide we have seen that we have different variables as x, y and z, but the interpreter needs to understand which is what. So we assign the variables suitable data types so that AutoCAD will understand it and process it accordingly. So typically, the first example what we have here is the real numbers. So real numbers bear decimal variations to it. As you can see here, suppose this 2.74, it means that numbers with a decimal point, and again if it's a 0.5, then it should always be preceded by a 0. So with assigning certain variables as real numbers, so now auto list distinguishes between these real numbers and other type of data type, and hence it can process these data types individually and associatively. That is, real numbers and integers when they treated upon which algorithm to be taken which. So we'll see it next, but the first thing is like if we are defining them as 2 point something, that is you use numbers with a decimal point, they are treated as real numbers. If you do not use a decimal point, then they are treated as integers. So integers are going to be whole numbers without these decimal points. They can also be positive or negative. It means that suppose you have -10, it means that this is a negative integer. Likewise, the real numbers can also be negative. Suppose -0.5, it means a negative real integer. But always bear in mind that the distinction feature between these two are always the decimal points. So in calculations, when you use real numbers and integers together, the output will always be a real number. The real number data type will take precedence over integer. So let me repeat it back again. So in a mathematical expression where we have only integer arguments, the result is always an integer. In the mathematical expression, if only real numbers are used, the output is always real number. But if you use a combination of integers and real numbers together, the output will always be real number. That is, the real numbers will take precedence to integers. So in the next slides, when we look into the operators, we'll look into how using a practical example. So next what we have here is the strings. Strings are sequence of alphabets or characters that denote something that has to be expressed. So they do not mean anything, but in order to auto list to understand that it's a list of characters that need not be processed and has to be executed the same way that it is displayed, that is where this string data type will come in. So all those that are expressed within the double quotes are taken as strings. So here we have a command that we are all very familiar with, the circle command. As it is listed within the double quotes, AutoList takes it directly. It does not try to interpret it in any way other than string. Likewise, if you are defining a number within double quotes, then also it is taken as a string format only and it is not processed upon. That is, the 5 is just taken for AutoList is all concerned about is just an image that is showing as a 5. So it will not process it. It will not interpret it. So all within the double quotes are not interpreted, and only that is outside of it, it is taken in direct notation. So finally what we have seen earlier is the list, that is using all those that is listed within the parenthesis. So here you can see that we have a integer and also string together, but we have something called as a dot in between. So this is called as a dotted pair list. So we'll see about dotted pair list shortly, but prominently these are the data types that you are working on. And finally, the useful, it is not a data type. to put it simply, but it's a function wherein it performs a certain set of activity, and these are inbuilt system functions. So that's why you can also consider as a data type. So those set of characters that are already been built into the system library will be taken as a system data type function, and hence it will process it as per the definition that is has. So that is called as a sub or functions. So here an example is a set q, that is a system variable function. So that is executed as per its inbuilt library. So we'll shortly look into how arithmetic functions are defined in Autolisk environment and how it affects the calculations. So we'll look into one by one. So first and foremost, we have the addition that is represented by the symbol plus, and next the subtraction by minus, multiplication by into, and division by slash. So likewise, we have function. So square root of variable x is expressed as a list within parentheses. So this expression will return a square root of x. And next, exponential x raised to y is represented by this function. And next, log of x again is represented as this. And finally, conversion of one or force assignment of given variable into a data type is being done by using this. For example, if the x what you have defined is, say it is 2, that is an integer, but when you're assigning a data type to it, if you say it is a float, then the x is overridden from its integer to a float data type. So that is the arithmetic function here. So next is, suppose you are performing a angular operation to it, for example a tan x or something. So what Autolisk always does is, the angles that is expressed is always in radians that we need to take care of. So this is a summation of a basic overview of what these arithmetic functions are described in it. We have lot more arithmetic functions. So this is just to scratch the surface. This video is more about making you to understand what is Autolisk about and how powerful it is and how it can be explored. So this is a topic on a whole that needs to be separately addressed and analyzed. But there are several resources and AutoCAD guides that are available that you can explore to analyze and get more info about what are the different opportunities that we have for fast execution or custom mode commands. So we'll look only into the basics of the Autolisk functions here so that you can understand the overall gist of it. So having understood what are the arithmetic functions on, let us move on to the string part. So in strings, what it's doing is, so as we said earlier, it's basically a text that is not interpreted in any manner. It is just taken it as it is. So it's always expressed within double quotes, and spaces can also be taken between those things, and those spaces also will be taken care as a separate character only. So it's a space character. So it will also get processed and displayed directly. And as said earlier, if you are bringing a number or an integer within double quotes, it's going to be a string and not an integer. So finally, in functions, what are basically it's the Autolisk environment understands that something has to be executed when a function is called in. So this function always leads the operation and it will prefix the notation. So looked about a list that is going to be executed, and in that list we'll be having an operation and something variable to work upon. So here what you're doing is, this list is going to execute something. So that's what you are expressing in parentheses, right? So but in Autolisk environment, this function, the executing method, means that it's going to lead the operation upon which it has to perform, and it means that it is a prefix notation. So we'll take it up with an example. This is a command to execute an arithmetic sum of 1 and 2. So here you can see that we are directly defining two integers 1 and 2 and subjecting upon an arithmetic function of addition plus, and enclosing within parentheses make AutoCAD understand that it is a list in a code and hence it has to be executed, and this function is an addition function plus. So as we said earlier, these functions will always precede the operation. So plus space 1 space 2 enclosed within parenthesis will execute a command that is equal to 1 plus 2. Likewise, if you have open parenthesis minus space 5 space 3 close parenthesis, means that this negation operation is performed between the first variable 5 and the second variable 3. So it is interpreted as 5 minus 3. Likewise, set q x is 3 means the function set q is means kind of an assignment. The set q is a system variable. It assigns x the value of 3. So the first is the operand on which it is happening, and second variable is the operation that is takes carried on to the operand. So that is 2 is added to 1, 3 is subtracted from 5, 3 is assigned to x. So this is how the variables are taking place. So next is arguments that we have to look on. So in arguments, it means that those are the values that are passed into the function. So as in previous example, where we have seen that we are performing an arithmetic operation. So in this case, it is a division operation. So you can see that the arguments passed on to this division function are 25 and 5. So here they are the arguments that are passed into this function. So next is, as we've seen earlier, one more function was the setQ function. We'll dwell little bit here. So this setQ is a system function that is used to assign variables to a preset value. So setQ x and 1 means that x is assigned to the value of 1. So here the setQ is the function, x is the variable name, whereas 1 is the value. So it is as simple as that. You can see that it is pretty straightforward. This is what the function of the interpreter is also, to directly view this whatever we are typing in a sequence of its understanding so that it can execute it. So this is how Autolisp is going to process the instructions that we are sending on to it. So next, finally, we have the variable names. So it can be alphanumeric. So it can be a combination of alphabets and number together, and that should not be any spaces between them. That is, you can go ahead and assign a variable name of say x1, meaning x1 is an alphanumeric, so it is accepted, but it should not be any space. X and 1 should go together. If you're bringing out a space in between, AutoCAD treats that as the next line of its command, so it will not process. Your 1 will be taken in its face value directly. So also these variable names should not use any system variable names. This is x, y are all accepted. But suppose if you're calling a system variable, suppose this set q and all those things is already a system function, that you cannot obviously assign as a variable's name, because what you're doing is it's making the Autolisp interpreter to get confused. So which is what? So by that, by normal definition, you cannot assign any variable names that are already associated with system variable. Finally, if any variable is not assigned to any specific value, be it a text or a numerical value, then it will always be linked as a nil variable. That is, it do not bear any value into it. So this is how variable names are treated in the Lisp environment. So let us put it all together, whatever we have seen so far. So what we've seen is, for every open parenthesis, there always must be an associated parenthesis, close parenthesis. So that will make Autolisp interpreter to understand that it has to process something within those parentheses. So that is how the Lisp environment is carried out. And second is, for always any open quotes, double quotes, there should be always a double quote. So it means that always the functions that you're using, that the double quotes and the parentheses should be associated with it. because Autolist keeps on looking into this. Whenever it encounters an open parenthesis and open quotes, it always looks for the next part where it gets closed, and then it process the content that is present within those things. So typically what it means that when there are multiple open and closes braces, what we'll do is we'll try to find the innermost content of that open and close parenthesis, that is innermost list function, and then it will try to execute it from inside to the outside. So the codes will be executed one by one from the internal layer to the outer layer within your single Autolist command. So what means that you are putting out sequence of commands within itself, that is you're nesting those functions into a single function, but Autolist takes care of the nesting by understanding that it will decode that, putting away function by function from the internal side to the external. Let us look by an example. So here you can see that we have two sets of functions. So here functions operation, one is a multiplication, the other is a subtraction. And again we have two sets of open and close parentheses. So now AutoCAD Autolist environment understands that this is the internal function, that because for this open it will associate this open, the outermost closed is associated to the outermost open. So this is an outer function. Whereas for this open and close, Autolist understand that this is an internal function. So it will try to execute this first and then move on to others. So what happens is, in a human readable format, we can decode this saying that 5 minus 3, and this output is multiplied by 3 as in this. So this is how Autolist will understand, interpret the commands that we are executing. And finally, as we put earlier, for all the coding environment, as comments is an integral part of it, Autolist understands that whatever is followed by double semicolon are treated as commands. That is, they will not be interpreted at all. It will be left as it is. So this commands is a very important and a powerful part of your programming language to make yourself to understand what it is, because you executed this code for a specific reason. But later point of time, that is say 6 months, 1 year later, and suppose you have moved to a different function altogether, you're no longer working on that project. But when you're looking back, sometimes we ourselves might not be able to recollect what was the purpose of the code that was put into, what was the output that is expected, what are the inputs that are expected, and what is the function that is expected to do. So comments or kind of tags or nodes that are attached within the coding language to give it a more readable and more interpretable form to the human mind. So always use comments within your coding language, however be simple it is, to make sure that it will help you and all the users of this code so that it can be modular in approach and can be easily used upon. Because if your code is very wonderful, but if none of the people can make sense of it, then it can go in the gutter. That is, it may not be used as it is intended to use. So now we'll quickly look into how AutoCAD treats this commands that we have. A short example of it. So as we seen, anything with an open and close parenthesis is treated as a list. That is, AutoCAD interprets that as a sequence of code that needs to be executed. So we'll quickly type in it. So now we are giving a open parenthesis here in the command prompt, command line, stating that I'm going to execute a list. So suppose let us consider that you're going to perform a multiplication operation upon the operands, that is 2 space 5, and then close the parenthesis, click on enter. You can see that Autolist executes that as 2 times 5 is 10. So this is how you are executing this command in the command line of AutoCAD. So likewise, suppose if we go for the variable set q, x as 1, Now you can see that X has been assigned to the value 1, that is what is listed here. However, if you go on and call X, you can see that it will always try to invoke the system variable that is already assigned to it. So always do remember that whatever has to be executed has to come within the parenthesis only, and in this command line it will show that it is executed immediately in this way. So instead, if we want to call the command that we already executed in a Lisp environment, then we have to precede that with an exclamatory mark here. So exclamatory mark followed by the variable that we have assigned is X. Clicking on enter will return the Lisp variable of that. So this is the application of the exclamatory mark to execute any AutoLisp variable in the command line of AutoCAD. Now let's come back to the popular example that we have, construction of a circle, because we have seen earlier how to do it also in a macro. Now let's see how it can be executed as a visual Lisp command. So as you very well know, the circle command is executed by calling the function C or circle as a whole. So that will invoke the AutoCAD circle command, followed which it will ask for the center point of the circle. And once you have entered this or specified the center point on the screen or specified the coordinates, then next it will prompt for directly enter the radius, or you can override it by specifying the diameter using D symbol and then proceed on to give the numerical command to that, and then you come out of the command by clicking the enter button. So this is the sequence of the command that you execute in a circle command. So earlier in macro we have seen that we use underscore command to invoke the circle command, and followed with ~C to invoke the double cancel operation and then execute this macro. Let us see how it is done in the list. But this is to just to make you recall the steps that are involved in building a circle. So always whatever you're replicating, as we talked about very well in the earlier of the session, we spoke that we are replicating the steps that are doing in a normal way in a programmatic, in an algorithmic way. So that is what we are doing it here. So the first command is we want to set up a variable that we want to call. So here we are saying that we'll first assign set q the variable x as 1. Now when we click on the command as exclamatory x, we can see that the output is as 1. So now the command is what we have to call is a circle. So this is what we expect. The first is the specifying the center point and then specifying the radius of it. So now what we can do is we can call for that radius. Instead of typing it, what we have done is we have assigned value to the variable x. So when we are calling for that as an exclamatory x, now it will result in a radius of x for this point. Also, you can recollect that whatever is inside the angular bracket is the predefined command here. So this x is assigned as a radius to the circle that we have here. So this is how you can call for the input, a numerical input, by a pre-stored value using AutoList function. So now let us go and see how we can use AutoCAD commands by itself. So command function is used to access the AutoCAD command that is built within the system. So for example, when you use this total text command space double quotes circle space will invoke the AutoCAD command of circle. Likewise, command trim will invoke the AutoCAD command of trim function. So likewise, what we have to understand is in certain functions where it invokes a dialog box. So in AutoLisp, particularly in Visual Lisp environment that we are seeing here, there won't be any dialog box that will be displayed in here. So in order to force AutoLisp to showcase the dialog box to us, to force display of it, we have to use the function init dia before the command so that the dialog box will get forced. So this is one tidbit we like to introduce it here. So next, suppose if we want to pause for any user input, then that command is the pause command here. So in the circle command, we have to pause a step to get the input of here, because likewise in macro, we had used the same similar pause command to get an user input. So likewise here, it is directly a textual representation that if you type in the word pause, AutoCAD understands that it has to wait for an user command. And likewise, when you type in command within parentheses, AutoCAD understands that it has to come out of the previous command that is within it. So these are the basic AutoCAD commands that we are looking at. That is, first putting any variable name preceded by command understands that all the textual characters that are following has to be treated as AutoCAD commands and it has to look within its library to execute. So that is the function of command space double quotes and the AutoCAD command within. So likewise, when we are invoking any AutoCAD commands, if there's a dialog box involved within it, AutoList visual list does not display it, and hence in order to force those display of the command window, the dialog window, we have to use the init dia command. And during the execution of this commands, AutoList command that involve any user input that is required, then that can be called forward by using the string characters pause that will identify the interpreter that it has to wait for the user input. And finally, command within parentheses, this sequence of characters will make AutoCAD AutoList interpreter to understand that it has to cancel the previous operation that is it executing. So finally, the double quotes open and close without any space translates that AutoList has to give the enter command. Enter as in the our keyboard enter command, the new line command that we are doing, right? So that is translated using the double quotes open and close command that AutoList interprets. So this is the usage of AutoCAD commands within your AutoList environment. So let's look into some examples. So this command here, you can see that we have two arguments that are passed into this command. So the first argument itself is an AutoCAD command, that is, as it is preceded by the variable command. So AutoCAD understands that it has to execute an AutoCAD command. That is, it will now start looking into the next sequence of characters within the double quotes. So it understands that it has to perform its zoom operation. Next, followed by a space and followed by a, it will understand that it has to zoom to all. So this is the command that will execute here. So likewise, if you want to erase all this thing, then the command erase, once it's invoked, then the next sequence of command that we are giving is the character L, and in order to execute it, that is after selecting the objects, and then you have to press in enter to close this erase command. So that is why it is followed by the double quotes command. Likewise, for executing a circle with radius 1, you can see that command space circle within double quotes space pause. So now here, once this circle command is executed, now AutoList waits for the user to give the input of the center point. So it is pause for that input. Once the user input is obtained, then it will go for the next sequence of that. It is to specify the radius. So now the radius is specified as 1, and followed by it, we have a double quotes indicating that we are coming out of this command. And finally, by just typing in simple command without any arguments, it will cancel whatever existing command it is within. So these are some examples involving AutoCAD commands. So now we look into the most interesting part here, how to create our own custom commands. So it means that we are no longer calling any AutoCAD command, but rather we are invoking, we are typing it out our own requirements, and then feeding it into the AutoCAD library, and using these AutoCAD functions we are able to make our own application or requirement. So this is how it's been done. So we define the custom command by using the function name defun. So this binds a set of expressions to a variable and it executes it. For example, defun C:"test. So now here test is the custom command that you are executing. You can see that the parameters or variables to this command test is the innermost set of open and curly parentheses or close parentheses, whereas the defun function assigns this variable test here. So let us look into what are the different parts to it. So the command here is test as indicated, but the defun is the function that we are expressing, and C it's a AutoCAD command that is we are saying that whatever following that is the command that needs to be bind as a function. So the next the text is the custom command name followed which the arguments. So currently within the parameters we have not given any arguments or variables that are passed within it. But based on the structure of this custom command, we can pass any number of arguments or variables that you want to do. So for example, let us see this command. So here we are calling it defun C:"test as a no input command. So that is once we call in the test function custom command, it will go into the sub commands that is have here. So once this function is called upon, it will execute these commands one by one. So now you can see that we are performing more than one action together. When this function is called upon, the first line what it executes is it will zoom to all of the extents, and next it will draw a circle with the user input of the center point, and then it will pass the argument as 1 for the radius and then come out of it, and then cancel out the whatever command it is within and then exit. So this is the system, this the user command that we are executing here using this name called as test and assigning it as a user command using this function defun. So this is a simple overview of how you can create your own custom command. Likewise, one more example is it's a very popular one that we can use. So if you could recollect, in the circle command itself, we have the tangent radius command that do not bear any system variable. That is, you cannot call it directly. You have to go it in a sequence of way to specify explicitly using the GUI interface stating that it's going to be a tangent radius. Whereas we can use this custom command using this autolist environment to create your own variable called as a TTR that is going to be a function. So you can define this, and when executed this TTR, it means that it will automatically goes into that. See what happens is this is the function name TTR that you're calling. But once you call it, the sequence of command that is happening is it will execute the command circle and then it types TTR as a string variable into its selection option. So if you remember, this TTR has to be selected here. It is no longer a system command. You cannot call it. So likewise, it is passing as a string variable. It is not passing as an argument or a numerical integer. So it's directly passing out here. And then we have 3 inputs. So one is the first object to which the circle should be a tangent, the second object, and finally the radius that has to be specified, that also is get as a user input. And finally it comes out. As a general practice, it's always good to put out cancel command within your sequence of code so that any leftover operation that is pending can be executed as a cancel and then come out. So these are some basic examples by which you can control the flow of the drafting that you want, and any custom codes, a sequence of codes that can be put in here. So we have seen what are codes all about and how to do it. So typically the codes can be written directly in the function line as we have seen it. But apart from that, they predominantly are written in a text-based editor. Example as a notepad or a notepad++. That's the first way of doing them. And the second way is using the visual lisp editor that is already available within the AutoCAD interface. And third is using of word processors, that is Microsoft Word or something, and then creating them. So those are the methodologies where we can write them. So as you can recollect, we said during the earlier of the session is that AutoCAD is not an integrated development environment. That is, Visual Lisp is not an integrated development environment. You have to have a textual editor on your own where you have to write in the code, and AutoLisp just interprets the code. So that's where the creation of the code first comes in, because only if it's a simple direct code, you can directly call from your command line in the AutoCAD interface. But all those multi-line commands, then you have to call it as a separate file only. So here you can save them either as a AXI text file or all with a .lsp Lisp extension. So also, if you use the AutoCAD doc LSP, then it will make sure that this list function will get loaded in every drawing. Whereas if it's a normal AutoCAD.list, it can also be saved, that is only when AutoCAD fires. So based on the method of calling, you can make sure it's only used when AutoCAD is used, or to be called upon in all the drawings, or called upon only when it is required as a single function. So this is how you save those AutoList programs, indicate that AutoCAD that this is a list function. So how do we load them up? So the first example what we've seen is to call it directly on the command line. Second is to load the text file that is containing the code. And the third way of doing it is to load the function in the Visual Lisp editor. So we'll look into one by one now. So first in the command line, what we have to do is we have to type the list program that we want to call using the command line itself. Or we can copy or paste the code that we have onto the command line.
So first off, let us see and call the command directly in the command line. So let us go ahead and then type the command for drawing a circle with a user input for the center point and then a radius of say 50 mm in diameter. So the command goes like this. First, always you have to open it up with the parenthesis. You have to be very clear on it that. Next, you're calling in a system command. So you precede that with a command column. Then with the open and close quotes, within that you call the system command that you want to do, that is the circle space. Please have a note on the space that we gave in between. So calling the space, then we have to pause for the user input for the center point. So let us give a pause command space. Once the pause has come, then now to the circle radius. So 50 is what we want, and then space, close it out, that is giving an enter key by using the double quotes, and then close it with enter. Now click on enter. Now you can see that now the circle command has been executed. You can see here the command is circle. Okay, so and it has been called for, and now as the input is of pause, now AutoCAD prompts for specification of the center point. So once you specify the center point, now the rest of the commands, the remaining radius and then entering has been executed using the Lisp routine. So thereby you can see that now the circle of 50 mm diameter has been drawn in it. So the other way of doing it is copy paste this command line. That is, if you have any other textual editor and then you want to move it over, copy and then paste it on the command line and click on enter. That will also execute this. So now the difference that you have to see is this method of calling the command from the command line is straightforward and simple for very basic commands that are of single lines. But suppose if we have functions that run through a lot of lines, then command line methodology won't be proper for us. So in that case, we have to go over to the next one, that is writing on a textual editor. So now let us look into that part. So now we have opened up a plain notepad, and now let's start writing the function. So for ease of understanding,
let us do it this way. So what we're doing is, one moment, let me just increase. Let me just increase the font size so that it will be easy for us to read it out. So to start off with, our understanding is that always the list protein should start off with a open and close parenthesis. So right now we'll try to emulate a zoom function as well as a circle draw function and assign that as a function name as test. This example that we had seen in the earlier slides, but let us construct it back one by one in this notepad editor. So let us first directly go into the command that we want to express. So as we've seen in the previous slide, so the initial command is for zooming, we have in double quotes and calling before as a command line because we are calling a system command, and then this is the command. So first we have to zoom to all the extents and then close it out. So this is the first command in our execution, and in the next command what we have to do here is we want to execute a circle with a user input for the center point and then a radius, let us assume it as 200, and then exit it using an enter. And if there are any transient command lines, then let us click in a command to execute that one. And also for ease of readability, we'll introduce a comment section here. So this line zooms to all. This line plots a circle with user specified center and a radius of 200. Okay, so this is the comment lines that we have exhibited here. So that is followed by a double quotes for safety, double semicolon. Okay, so now this is the body of the command that you want to execute. But we have to assign a user comment for, because even though they are AutoCAD commands, we cannot call it directly because we have to define it under a function and then call it. So for function definition, we declare it as defun C colon, that is after the C colon is what is your function name. So let us say our function name is test, and for this function name, what are the inputs parameters to it? But right now we are not receiving any inputs, so we just keep it as it is. So now always we have to see here is all the double quotes open should have a double quotes close, and all the parentheses open should have a parenthesis close, and with that order of precedence is how it gets executed. So this is our initial basic list code that we have written. So now let us go ahead and then save it as. So towards saving, what we have to do is we'll save them as a test.lsp, but we have to make sure that this save as file type should be in all files so that it will save at a LSP file, because only when it is a LSP file, then AutoCAD itself can understand that it's a list protein file. So now we'll go ahead and save. So that's it. So we have done. So we have now created the code on a textual editor and then saved it as a LSP routine. So now let's recall and see what are the different methods that we can call within the function. So we have two methods within the command line to call the function. The first is the load methodology, where we have call it by load command followed by the path of the command. We have to explicitly type the path. And second one is using an app load functionality, wherein you get a dialog box kind of environment where you can locate the file that is of interest to us. So let us first start off with the basic command. So that again, as we know, all the list routine starts with the open and close parenthesis. Now we call the function. This is the function name, load. So next is we have to call the path within this double quotes. So here we cannot directly call the path because AutoCAD itself will have to refer to a path from which it has to search a file. Only if it is present within its library, then you can call the file name directly. But as you could recollect, the textual file that we have created is located in our desktop. So for that, you have to call the entire address of it. So towards taking the address, let us see that this is the file that we have created, test file. Okay. So in this manner, for understanding the address, we can go for the properties and you can see that this is where the file location is. So let us copy it. Let us copy this address. Now let's go back to this path. Now click it onto here and followed by the file name. So this is our file name, test.lsp. So LSP is not required because this load automatically goes and look for this file. So even it's not explicitly mentioned, it should not be a problem. So once we click on this, you can see that it prompts us that the load has failed. Why? Because you can see a clue here. In this command line, you can see that once this backslash is prompted, but now this backslash is not visible and it is available only here. So this is what the clue to is. AutoCAD, when calling for load option, it cannot treat this slash symbol. So we have to explicitly specify 2 slashes to indicate the path of it. So now once executed now it clearly takes in the location. As it is a user-based list file, now AutoCAD says that the publisher details cannot be verified, should we load or not. So let us go once, always load. So now you can see that the file has been successfully loaded, and as a notification of that, you can observe that the C:(test) has returned. So this is a successful example of saying that the file has got loaded. So now let us go ahead and call this function. So in order to call this function, you just have to type in directly. So you can see that once it is executed, your zoom has executed, it has zoomed to all, and now the next prompting for the center point of the circle. So now upon clicking it, now the command is completely executed. So this is one simple example of how to use an autolift routine to quickly make sure you execute the task, this set of tasks, because right now you have done your own function. As you can see, when you call the test, it is available with the rest of the commands that are available. That is, you have defined your own function into the AutoCAD environment. So this is the powerful functionality of an autolift to define your own custom commands. So congrats to you. So now this is your first autolift routine. So now we can see how well we can explore this. But before this, we'll also see the other functionality of using this app load. So this is an application load functionality wherein you can get a user interface kind of thing where you can specify what are the functions that you want to load and unload. So as you can see here, what are the already existing loaded functionalities that are within this thing. So you can see this function test that we have loaded from the desktop is already loaded here. Likewise, there are several other list routines that have been loaded. So this is one way of selecting it. So now what we can do is we can directly go to the location that we want to do and then click on it and then click on load. So now we can see that this test.lsp successfully loaded info from the menu. So with this you can load a sequence of list routines continuously, and then once you have loaded everything, then you can close it out. Also, one more advantage what we have here is using this app load functionality, you can also configure that to load it as a part of your AutoCAD startup itself. So that means that you can add all the list routines that are of frequent use to you as a part of this startup functionality, so that once you open AutoCAD, all the lists that are displayed here will get loaded automatically. So this is how you will call using this list routine itself. So now we look into what is this visual list editor is about and how we can use it. So actually that is the most preferred way of doing it. Suppose if you are developing the list coding for the first time or want to run it through different iterations to finalize it. So Notepad editor is a good thing if you are very clear about how you are going to proceed about and then do it. But as we said earlier, this is not an IDE based environment, this Autolist. That is, it do not have a single setup where you can do all the operations together. But close to something like that is your visual list editor, wherein you can start typing in it and then look into how your code progresses step by step. That is one sort of, not a complete debugging in terms of software coding language, but at least you can see how your coding proceeds from one step to other so that you can take informed decisions on it. So this visual list editor is available in your manage ribbon and here in applications as visual list editor. Also in tools, we have this auto list. Here we have the visual list editor. So in order to go there, you just click on this visual list editor and you can see that what are the different consoles what we have here. So let us just okay, let me just open it up fresh. So one thing is that what you can see here is the overall operation pane. We have the toolbars here and we have three major segments. We have the console here. We have the console where we can execute the course directly. You can see that it's preceded by a dollar symbol here. And also we have a functionality called as a trace that it can look into the background functionalities. And next is the functions where you type in the code, the list text file. So this is how it is structured. So you can right away use this console to see how it is executed by this function. Suppose if we have to execute these two commands, you can see that instead of going to the AutoCAD environment, the execution can be witnessed here. So this is what this console is all about. So it's typically a replication of the command line that you have there. So next is, let us go ahead and then now try using a new file that we want to create and see how it is executed. So let us type in the code again, the fundamental code that we have seen. So we'll use dfun C:, test1, let us name it that way. And I'm just quickly typing out the commands here, but have a note on the color icons that are being visible here. You can see that there are different colors that are being taken care. So you can see it here now. We'll also introduce one command line. This is a comment and then closing out. So this is the major advantage that you use in a visual list editor, wherein we can visualize see how the different type of data characters that you're using, whether it's a system variable or a string or an integer or a user defined function, all is being showcased by the differential of the icons or the color font that you have. So as you can see here, system commands are all highlighted by blue color here. The text is in blue color for all system based commands. So this command dfun is all a system variable. Whereas user defined function variables here you can see that it is in black color. And all open and closed braces are in red and strings are in pink and integers are in green color. So this is one type of differentiation what you can see during your coding operation so that you can categorize them easily. And also you can see that once you start typing and editing your command, the indenting will happen automatically so that as it enters a function, you can see that it has got intended in this manner. That is, it has moved. There are empty spaces automatically assigned to it so that it improves the readability of the text. Whereas in a notepad or in a custom text editor, you have to manually put in all those specifications. So this is one thing that can come out of this Visual Lisp editor. So now, having created that, you can save it using this Control S option. So now, as you could see, it automatically lists the save as a Lisp source file. So let us say that it is a test1 again, test1 Lisp that is stored in desktop. So now you can see that it is stored here. And once you click on this text file, you can see that there are some icons that are highlighted here. Let us look into one by one now. So we'll just take this menu first. You can see that this is the tools menu. And next we have here is the view menu or the view toolbar. And here is we have the debug toolbar. And this is a search toolbar. And this is our normal edit toolbar. Standard toolbar here available. So these are the different toolbars that are available. So when you take it out, you can see it clearly. So now on clicking onto this list window, you can see that the tools is highlighted. Whereas if you move over to the Visual Lisp console, you can see only the view icons are highlighted and search are highlighted. And again, the debug is not highlighted here. So this is how the functionality of different windows will is highlighted based on the selection. So now we can see that once we have selected this Lisp file, first off, we can see in the tools function, we can see that this is the load of the file, load the active Visual Lisp onto this thing. So once you click on it, you can see that this has got loaded into the Visual Lisp. So, and next thing is, we can see that this is the loading the selection. Right now it is just loaded onto the console. Right now if you click on it, this file will get loaded onto your console directly. So next is, this is the to checking the whether the load is being the output is okay or not. So this again is an interpreter. It just looks into whether it's all the commands lines are okay or not. Whereas if you go for a proper folder, then you have to compile it, then it will run all the checking and then do it. So this is just an overall check parameters. Whereas if you click on this, so what you see here was, when we click this icon, the entire Lisp program will get loaded onto here. Whereas we can load only one specific line for the selections that we want by highlighting, selecting them, and then click on this icon. Load only selection. So only this line has got loaded. So by that you can load or unload whatever group of functions you want. Suppose if you are nesting function within a different function, then you can use this selection option loading to particularly load a part of the program, not the entire program, and then run only that. And again, you can run whether the checking of the verification of the program by a single line. Suppose if you want to check only this line, then you can click on that selection and then click on whether it is okay or not. Suppose let us say we have made a mistake like this and then click on the selection here test. You can see that an error has thrown and it shows that a malformed string on input is highlighted. So by this way, this is an indirect method of debugging the code. So let's see how this debugging can be actually taking place inside this coding environment to check whether the written code is okay or not. So towards debugging, it's what you have in this debug icon. So here you can see that the highlighted icons are the watch, the add breakpoint, and then stop icon. So towards this, you can also see it here. You can see the add watch, toggle the breakpoint, and then continue. So here we'll put a toggle breakpoint here. That is the F9 button, adding a breakpoint. So for now, let us get back all this command button here and then now see one by one. So to ease of you, we'll just keep it in this way so that let us see now what happens first. So in order to execute it, we'll run this code. So now this file has got loaded. Going back, clicking on here and then click on test one. Let us call the function. Now it has zoom all and then now it is asking for the center point and then executing. Well, this is how it has executed. So now, but it has happened rather faster. So that's where your breakpoint will help you to look into what is happening. So let us just give 2 breakpoints to these activities here. Okay, so now let us load it back and maybe move it to somewhere here and now execute the code again. So now you can see that the cursor now stops at this point. So it is stopping at this command line and waiting for the next step to happen. So now we'll go into step 2. Now you can see that it is zooming into the overall extent. Now it is going back to the screen what we have here, and see the command is coming to the end of the parenthesis there. That is, this command has got executed. So now let us go into the next step. Now this is the step that has to get executed. Going back into again. Now it is pausing for the user input. So now let us say this is the center point that we have, and now this command has got executed. So now going back again to the next step is what the complete command has got executed. So this is the straightforward way of doing a debug action. So to catch it still further, so you can see what other methodologies that we can do is we have something called as a watch function here. So this is useful to see what user defined variables are assigned to, what are the characters that are assigned. Suppose let us, instead of waiting for a user input here, let us say that instead of pausing for it, let us define a center point. Okay. So and for analysis purpose, we just keep it as 50 here. So now we will use the system variable setQ space, and then what is the variable name is center, and towards that you for setting this variable you get a point, you call in a system variable function. So we'll again toggle a breakpoint here and see what's happening. So now let us put this code fully, and now let us step into it. Yeah, so towards it we'll just call for let us just that's done. So let us quickly come out of this breakpoint. So let us exit this. So now let us run it here. Okay, so back again. So now it is going into the breakpoint mode. Let us come back. So now, as we call for, it is going into this step mode. Now let us go to the next part, and it is zooming on and stepping into again. Now it is asking for a center point. It is going for this line. Let us step into again. Now it is where it is expecting the get point variable. So now let us step into here. It is asking for a center point. So now that center point was obtained, and now let us go to the next command, and next command. So this is how it is. But currently we are not sure of what was the center point, right? So towards this is what we can, select this out and then click this glasses icon. So this is the watch. So once you click on it, you can see that variable, what was the previous value to that variable is that. So it means that you can see also the last value. So when we first defined this, its value was in nil, and next once we click on it, the value was updated to 430. So right now let us do it once more. We'll call this variable function again. Come out of the debug mode and now let us call the function. So it is getting into the first signal. So now let us skip this step. And second point, so it is going into the set point. Now you can see that the prompt has come here, and let us say this is the command. You just have a note on what is the previous value here. So now let us say this is what the value is, and you can very well see that the watch function now updates the coordinates that we have here, and going on to next, we are finally coming out of this code. So this is the functionality that you can get out of this watch command. So this is in short putting together the functionality of the list console to systematically verify each part of your code one by one using this debug command, watch command, and toggle breakpoint command, and also that you can thoroughly investigate what are the problematic steps that you are facing. And going by again, suppose if we have some error, suppose if we have missed out one point here, and this very well, once you run this, you can see that that's an error that is showing out here. So this can also help you to quickly analyze what is happening, but by adding breakpoint to certain set of modules, you can verify at which point it is getting stuck. Because generally you are saying that you can see that this error malformed list on input is shown here. When execution, it will exactly show with breakpoints, it will show which is where. So this is where this visual list is a value addition to your list programming, because you can keep on building small modules, test them right away in your Autodesk environment here, and then once you are done with it, then you can save it as a whole, and next you can directly, once you build on it, you can use this Epilogue functionality that you have here to call those functions one by one. Then also, as said earlier, using the startup menu, you can configure which are the list functions that you are using over and over again, so that you can configure it totally. So this is a summation of the list coding what we have here, and this list, visual list environment might look a little bit old. That's right, because initially it was a very powerful functionality that builds over the auto list. This visual list builds over the auto list function, so that you can develop your own complex modules. But then as a part of, from the 2000 onwards, the development activity stopped. So that's why you can also see that it's pretty much, kind of a vintage version that is looking at it. But still, the functionalities, the background functionalities are still there. So this is how you can use the visual list to, create user-defined functionalities. So with this, we'll conclude this part of AutoCAD and see you in the next video. Thank you.
Hello folks, welcome to this week's course on project management. So we'll look into what is project is all about and why do we need to manage it, and what are the different methodologies of management. So towards this, we'll use all the guidelines that are listed in the PMBOK guide. So we'll look into what this PMBOK means shortly. So now let us go into the course. So first thing, what is a project? There are different user-defined definitions for this project. Let us go by the standard definition. What do you intend to deliver in a project or intend to achieve in a project? Because this project is a widespread term that we keep on hearing on from different places and different circumstances.
that you are working on or supporting on. So we need to have a very clear understanding of what encompasses a project and what activities are not. So that clarity is what we'll try to build in now. So a project typically means a temporary endeavor undertaken so as to create unique products, services, or results. So you can see a lot of emphasis have been given on the word temporary, unique products, services, or result. So it means this project is not a continual one. It is a temporary activity that has been undertaken so as to obtain a specific set of targets. Those are either to create new products or a service or any target result. So that is what you call as a project. So as we see why this unique products or service or result is required. So there are many drivers to it. The first and foremost is the market demand to that service or a product. If the market calls for, because based on a demand, you are going to supply it. So whatever organization you placed in, you might be an electronics based organization or a mechanical based or an automotive based or a pharma based or even a banking based. So each and every sector caters to the market. It caters to the consumer who is going to generate the supply for that unique product. So your market demand is the first one that is going to drive this project. So always we must be very clear on what are the drivers of our project so that our project must cater to them, not to our individual requirements. Likewise, the next major demand is from the customer because the customer are the king in this current scenario. So you should not build a product that is good for you. You should build a product that is good for the customer and what he wants, not what we design. So this project should be focused on the customer request and whether the customer will get satisfied by that product or not. Next is the legal requirement that binds the development of a product. Suppose there might be a separate rule stating that a given product should cater a set of conditions so that it can be marketed and sold. Very good example that you all might be aware of in the automotive industry is that the emission norms that have been floating around. So it is a mass product change demanded by the legislation for which all the automotive industry and supplier ancillary industries have to adhere to. So by variation of this legal requirement, it calls for variation of products and that again will constitute a separate project on its own. So next, any specific organization need. The second point that we have, suppose based on the customer request that I've already mapped, internally to your organization, you want to deliver a differentiated product. So that is terms of product. But there can also be situations that can demand an internal service requirement. So within an organization, which might not have a direct impact on the customer or the market or the legal, but for an internal effectiveness or functioning of the organization, you have to launch a new project. So that project can target a service or a result. So that can be termed as an organization need for a project. So based on these needs, now we have to understand what this project is versus an operation, because typically people will get confused between these two terms or they are being used interchangeably between each other, but they have very clear demarcation between them. So first and foremost, the operation is going to be used to sustain the business. So it means that all the activities that are being performed on a day-to-day basis in case of repetitive activity or all those things that are used as a normal business functionality will be termed as an operation. So it means that it is a continuous cycle. Whereas a project is one that is created to attain its specific objective, and once that objective is attained, it will get terminated and then it will move on to the operation stage. So for example, if you have created a product, say let it be a cell phone. So the project objective is that to create a cell phone of say 5.5 inch with so many specs and catering to a particular market, say the G market or the millennium market. That is the people who are going to use the cell phone. So you have launched the project internally with that specific objective in mind, that is to deliver a millennium targeting cellular phone. So for that you have made the design, you have made the drawings and all those things, and then now it gets processed to the manufacturing team. The manufacturing team now operates on this design and keeps on producing them. So that will serve as the business revenue stream for you. So this is the operational part of the project. Next is it requires a semi-permanent charter, organization and goals for an operation. The detailing of charter will look slowly in the upcoming slides. But to put it simple, those are some terms and regulations that are being understood and agreed upon by the stakeholders with defined targets and the responsibilities, and this also have to be put in for an operation in place, but they are kind of semi-permanent because they tend to get modified based on the operational needs. But whereas for a project, it is unique. The charter is unique for different projects and for different goals and for different organization. So this will touch upon in the charter segment when we touch upon, but the main objective is that for an operation, it is kind of a semi-permanent. That is, it won't change unless it is needed for. Suppose only if there are any major operational organization changes that call for it, you will modify the charter. But apart from that, it's going to stay good until the product stays on the line. Whereas a project, for individual project, there's going to be individual unique customized charter for a specific target or goals. So that is how it's going to be different in terms of the goal settings. Next, an operation will try to maintain a status quo. As said in the previous 2 points, it's not going to change much. It's going to stay active and a continual process. Whereas a project will drive the change. It will act as a catalyst for the change, because this will ensure that you're not no longer heading the same direction, but you're either taking a strategical redirection or a new path. So this project is going to be a catalyst for that change. So next, an operation is going to operate upon a standard or a delivered product or services. So that is an established line upon which you have to work upon. So that is going to get an operation. Whereas in project, you create those unique product or services. So that's the difference between slow. So by this understanding, you need to differentiate between the various tasks that you see on a day-to-day basis. See, suppose if you're going to cook, and the everyday cooking will term as an operation for you. Even the buying the materials, all those things are a repetitive task periodically. So that is an operation. Whereas if you're preparing some seasonal delicate such as an cake or something, so that can be termed as a project because you have a specific goal. You're not cooking for one of the duration. That is, you're not going to cook either for a breakfast or something, but you're going to take it as a delicacy, so that you have to focus on separately apart from the general operation. So maybe you can say that I don't want to have breakfast today, but let me focus on this. So what you're doing is you're setting aside a separate target that you have to bake a cake, and towards that you buy specific ingredients to it, because normally we won't be using much of the ingredients on a day-to-day basis. So for creating the cake, you have to set out a project charter. That's an internal charter, because you will decide that you need to buy these things, you need to do these things in activity, and maybe you might not have tried it at all. So this is your first time. So you have to formulate the sequence of activities that you have to do. You have to do a lot of research, going into so many YouTube videos or so, and then build it out and get the final thing that you want. Maybe once you are very familiar with it and you're going to do it on a daily basis or a weekly basis, then that established project will become an operation. So I hope you can differentiate between these two terminologies. And next thing is, for an operation, the team members consisted will be targeting almost similar line of work. So it means that they are homogeneous in nature. There are no differences or unique skill sets required in the majority of the operation. So they all constitute a single team targeting for a single objective. Whereas a project is going to be heterogeneous. You bring in personnel from different strata. You bring in from finance, you bring in from product management, you bring in from service, you bring in from production. You bring all these stakeholders together to drive the project to fruition. So this is the heterogeneous team formation document. So this is an obvious mandatory requirement to have a successful project. You need to make sure that your team stays heterogeneous. It should contain different flavors so that you can make sure that all the key factors behind the project objectives can be catered to. And finally, an operation, as said earlier, is going to be an ongoing continual process, whereas a project is going to have a linear operation. That is, it has a well-defined start and a well-defined end within which it will get completed. Between the process, there can be several iterational one, but we have a clear start and an end date which opens and closes the project and sign it off completely. So this is the major difference between a project and an operation that we all need to be very clear of. So next we look into what is project management. So managing a project has different requirements to it. It's not a single faced object and it's a role altogether. So we'll see what are the drivers of this project management are. The first thing is it is the application of the processes, knowledge, skills, and experience so as to achieve the project objectives. So let us look into the keywords very clearly. The application of the processes that call for managing the project and specific knowledge sets that are applied for this and several skill sets or tools that are required to apply so as to continue the project objectives and the different experiences that we have gained in the previous projects to carry over here or different risks that we need to take on those in terms of risk management and all those things, those kind of experience that we need to cater so that we can achieve the project objective. So this is what a project management is all about. It might look very simple, very direct, but it has very deep meaning to it. So a project success will depend on whether you have met the scope of the project, its timeline, and also its cost goals. Because almost most of the projects will exceed your scope of the project. That is, it might not be able to meet the preset targets that was kept, or it might not be able to meet the timelines. It might get extended, or it might overshoot the cost of the project. So these are several day-to-day project happenings that I have occurring. So this is where a project manager will be very useful in critical in making sure that the project stays successful in meeting the scope, time, and the cost goals. And also, the project success can also be attributed how well your customer is going to satisfy. Because a happy customer is will make sure that your pockets will stay full. The company will get revenue out of your customers only because even though you have a wonderful product, if the customers are not willing to buy it, then there's no use in having a product. So the project must ensure that it sticks to its scope, time, and cost goals so that it gets delivered to customer at the prompt time, beating the market competition, and also staying as cheap as possible so that the customer will get a good return on investment. So once decide on this project and the management scope, there are several project constraints that you'll face in during the course of the project. So we'll see what are those. So there are three pillars to it. So as we saw earlier, we have the scope constraint, the cost constraint, and the time constraint. But within which you have to balance the quality of the project, the resources that you have in hand, and the risk that might come in. So by balancing all these, you have to deliver the design target objectives. So this is what the project will call for. So next, having spoken about a project, there is the next terminology that comes in, that is a program. So what a program does is it groups related projects, subsidiary programs, and program activities that can be managed in a coordinated way so that the benefits and control can be available together and instead of managing them individually. So put it in simple terms, the related set of projects and activities can be grouped together so that one learning can be taken forward to other, or one resources can be shared with the other project on similar kind of workplace, so that the benefits and control can be strictly maintained to all the related projects and it may not be wasted upon by focusing them individually. So that is what this program means. So to put it in another classical example, you are a biscuit manufacturing company and the program of putting out printed biscuits, that is with shapes, that can be driven as a combination of different projects, but this have to have its own differentiation. A program means it is related project. So you cannot take a normal biscuit and a cream biscuit together in your program stream. So typically saying that as it calls for differentiated process and differentiated learnings, it might not be prudent to keep those together. But whereas if we have the same baking machine and the same packing machine that can be used for two different products, then you can group it as a separate program. So that is what this calls for. A program will go for related projects wherein they can be managed together and all the benefits that are available by managing them on a whole that can be taken is called as a program. And this program management will focus on the interdependency of the project and always try to describe and attain the best approach so as to achieve the program objectives. So this program will ensure that we have sufficient interdependencies to leverage so that they can be targeted together to attain the program objectives. So next comes the portfolio. So in portfolio, what we do is we have a collection of the projects, programs, subsidiary portfolios, and operations managed together to achieve strategic objectives. So, quoting the earlier example of the biscuit manufacturing company, now the business manufacturing as a whole is a portfolio that needs to be managed by the top management, where they have to foresee different projects. They have to foresee the manufacturing, the packaging, the designing, the marketing, everything, all are separate projects and programs that needs to be put together in a single umbrella, and that is called as a portfolio, so that your overall strategic objectives are met. So that is the portfolio. So what we are seeing as a project, programs, and portfolio means that we are clearly defining or breaking down the bigger picture into intermediate and smaller picture so that they can be managed. So speaking about management, we can see what are the different varied categories that have to be looked into within a project, a program, or a portfolios. So in terms of scope, when we are seeing projects on the smaller level, they have defined objectives and the scope will get modified or updated based on the activities that are carried out in the project life cycle. In a program, as we said, it's having a larger scope than the project because it encompasses similar interdependent projects and it will deliver major benefits rather than handling a project individually. The combined benefit is always greater than the sum benefits of the individual projects. Whereas in portfolios, they have a broader, even broader scope in a business level scope, so that whatever small strategic redirection that are taking place in the portfolio levels will obviously affect all the scopes that are defined in a project. So to put it in other words, you're in a project that targets to a specific customer and specific area that you're working on. Suppose if the top management takes a decision that, okay, so this is not an area that we need to be considering the current scenarios or the current marketing. So it's better to take a risk and come out of this so that we can focus on our core area. So that can be a strategic realignment in the portfolio level that will call for modification of the project or scrapping it off fully. So why we are speaking about all this is that we have to have a very clear understanding of where our work lies in, what are the dependencies of our work and the impact of our work. So obviously, if you are a part of a project that can have a very high impact on the functioning of your organization, then that will get traveled upon in either all of the programs or the portfolio. So obviously all the projects are important, but your company can drive a lot from your projects. So always the basement represented by the projects is going to help the continual sustenance of a organization on a whole. Likewise, if the top level decisions are sporadic or or turbulent, then it can also have a very great impact on the project level scope also. So there are very high dependencies between these. Likewise, the major area is the change. That is, the project management can expect and implement the change in the processes so that all the change management are monitored and controlled. Whereas in program management, what he have to expect is he has to expect the change that is being driven from internal level, that is from the project level, also the external level. Whereas in the portfolio level, they always see a broader picture. They always see how the entire industry is going on, how the market is going on. So they have to take the decisions and direct the change accordingly in that way. Whereas in terms of planning, the project managers, they plan elaborately in with very high detailing of each and every activity that has to get executed in that project so that the objective is completed. Whereas in the program managers, they also develop a very detailed plan on a macro level so that those projects are getting executed. So their high level planning will be to guide these detailed project planning in fruition so that they can get executed at the component level. Whereas in a portfolio level, the portfolio managers will create and maintain the necessary structure or the communication methodology or the basic backbone of the organization that can help and execute the planning, because basically the portfolio manager will establish the positive environment that are required to ensure that the projects and the programs get executed properly. Likewise, in terms of management, the project managers maintain and manage the project team directly, whereas the program managers manage the project managers and also the program staff. So they give kind of a vision and an overall leadership. Whereas the portfolio managers, they have control of the individual program managers and also indirectly the project managers. So the success of these project programs and portfolios will depend upon the basic targets that we have defined for them. So for a project, it's defined by the product and the project quality, the timelines that you have stick to, and the cost compliance, and also the customer satisfaction as seen earlier. Whereas in a program, the success is going to be measured by which the program has satisfied the needs and the extra benefits that we have reaped out of a combined project methodology. Whereas in portfolios, how well all these programs adhere together to deliver a successful and cost effective output that is taken. So finally, the process of monitoring in a project, managers are going to monitor and control the work that is of producing the product, services or result. And whereas in programs, they monitor different progress of the program components so that again the targets are met, whereas portfolio managers, they monitor on an overall level, wherein they see the overall performance and indicators towards the business objectives. So these are how the various targets of the different organization will get split into so that they can be directed upon. Now putting all together, as we see, we have seen project management, a program management and a portfolio management to make sure all work in tandem together and the communication is sent across, we have something called as a Program Management Office, in short, a PMO. So this project management office, they work upon the projects and operation. Whereas a program management office, they can execute between different programs, but the main importance is of handling different projects that can communicated and executed. So this is the role of the project management office that establish the sync between the projects, program, and the portfolio. So the role of the program management office is to centralize the management of the projects, and the roles can be split as either deliver the project support in terms of providing project management guidelines to specifically to the project managers, or give in a project management process or a methodology so that they give the backbone on a structured way of approaching it, certain guidelines, certain standards and process with which it has to follow, so that based on your organization you devise your own guideline. So the PMO can also focus on this activity, that is setting up the process or methodology that needs to be followed, and it can also impart training across the different levels on the various skill sets that are required, various tools that are required to be implemented. So those can be targeted either internally or also externally. So this is the role of the program management. So you can see that how well all the information gets taken within. You take it in a project level, a program level, a portfolio level, put it together, and then, but for all these things, the end objective is the same. As a company, you are expected to deliver a quality product that can get sold and return revenues to it, and with proper customer satisfaction and proper services, you ensure that you expand your service base, customer base, and thereby more revenue. So that is the overall objective. That's not going to change. We're just splitting that into well-defined processes and then focusing on each and every one so that the end objective, the overall company objective is still met. So during this course of all the activities, we are going to have a say on a lot of important data and information. So that can be categorized as three ways. So one thing is the work performance data. The next categorization is work performance information, and finally work performance reports. So what do they mean? Is that for data what you're doing is the recording of all the raw observations and measurements that are identified during the activities performed to carry out the project work. So those are the raw information that you're collecting. So that is the data. In computer terminology, all the raw and unprocessed measurements or observations that are termed as the data. So all your project, throughout your project, you will have to undergo a lot of data collection. So once you have collected data, you process them into different context and then integrate them based on the different requirements or relationships, and you piece it together to give some meaningful inference. So that you call as a work performance information. Whereas finally, you put it together in a physical or an electronic way of representation for this project as a recorded and a readable format. Now that becomes a report. So typically what you do is, in a project, day by day, you work on and collect data, and during review activities that we'll see in the next step, you will process those data and try to deliver inference for immediate consumption by converting it to information. But once then, after taking informed decisions and informed actions, you collate all those uh, occurrences, learnings, and all those things in a proper report, so that they are signed off in a project or a program level or a portfolio level, agreed upon and closed off. So your report will serve as suitable authentication so that the project activity has been carried out successfully. So these are how the project management data and information is handled along the project lifecycle. So next, now we'll come on to the key terminologies that are governed by PMI and PMP for this project management. So this PMI is nothing but Project Management Institute. So that is a global organization that is a project management professional association that encompasses more than 2.9 million professionals as on date. So this PMI, it was first constituted in 1969 and it has a global presence in almost all the countries, and it's a not-for-profit organization because it does not derive revenues out of it, but it is constituted entirely so that the knowledge of handling a project, managing it, is structured, streamlined, and communicated to all the professionals around the world in a streamlined manner. And it offers a certification called as a project management professional, PMP, so that it recognizes the demonstrated knowledge and skills of that particular person in leading and directing the project teams, and it's an assurance that all the person that have the PMP certificate is an assured way of understanding that they will deliver the project results within the constraints of the schedule, budget, and resource. So this is an accreditation given to the personnel who have cleared this rigorous certification methodology. So that is the PMP. So in order to do this, it is a very rigorous examination, and this certificate is widely recognized, and there are greater than 10 lakh PMP certification holders available worldwide. So now we'll come in to the terminology that we used in the start of the slide, PMBOK. So that is called as the standard for project management and the guide to the project management body of knowledge. So this project management body of knowledge is the PMBOK, and this guide serves as the standard for this project management because this basically put together all the structured knowledge that have been gathered, tested, and proven upon in various project streamlines, and this guide is the fundamental for all the PMP executives out there. And this is what we'll try to cover in this session, basically the various the fundamental objectives, so that you can have an informed way of understanding how this project management works, so that you can incorporate into your day-to-day activities, so that you can differentiate yourself from the rest of the team, and also you can strive to get this PMP certification done. So now let's go into the project management process. So this project management process has been defined as separate groups into the process by the PMB. Okay. The first thing is initiating the process. Next is the planning process, executing process, monitoring and control process. Final is the closing process. So these are the groups of the project management processes. So it can be put in a graphical manner, saying that we have an initiating phase and the closing phase. And in the execution phase, we have the executing process, a planning process that goes in an iterative way, and it is governed by a monitoring and controlling process. So once the project reaches a maturity based on the defined scope, then it moves on to the closing stage. We'll look into each and every one stage very closely. So first is the initiating process. So theoretically what it means is, the initiating process is a process performed to define a new project or a new phase of an existing project by obtaining authorization to start the project or phase. So we have to be very clear on the different terminologies that are taken within this definition. So this initiating process is performed on a new project or a new phase of an existing project by obtaining authorization to start the project or phase. So this is important. We have to obtain suitable authorizations that recognizes that yes, this project is required for the organization, and hence it is officially sanctioned and commissioned. So that is a very, very important requirement for you also to understand that what project you are working on and what state it is and how it has been authorized. And so going on, the defining the initial scope is by defining the scope and then getting the understanding of the initial financial resources that you have, and then understanding who are your internal and external stakeholders. The stakeholders we'll see in the next stage, but during initiation itself we have to understand your internal and external stakeholders. So with this is what you will be initiating a project. So next, once initiated, you go on to the planning stage. In the planning process, what you do is you establish the overall scope of the effort required, the objectives are defined and redefined, and also develop the course of action that are required to attain those objectives. So this is the planning stage of your process. So this stage also involves development of the project management plan and the project documents that will be used to carry out the project. So next is, once you have planned it out, you have to execute it. In the execution process, what you're doing is we are completing the work defined in the project management plan step by step so that the project specifications are met. So that is your executing stage. So during this project execution stage, results may be required so that the plan gets updates and the base requirements, if required, can be updated. So as we saw earlier in this graph, it is a repetitive process that is controlled by this monitoring and controlling process. So what it does is the executing process has to be tracked, reviewed, and improved upon based on the progress and performance. So this monitoring and control process is uses to govern that. So finally, you close the project. So in this stage, what you do is you conclude upon all the activities that you have conducted in the different phases so that you formally complete the project and conclude all the contractual obligations that you have in and sign off the project and close it off. So this is the closing process. So this constitutes basically what are the different stages that are involved in the project. So now this guide shows in that for handling all these project stages, we need to have a strong understanding on several knowledge areas. So these knowledge areas means that complete set of concepts, items and activities that will make up a professional field, project management field or area of specialization for you. So these constitute the knowledge areas that we intend to acquire over this project management phase or intend to demonstrate during this phase. So there are a total of 47 project management processes that are identified in the guide. So that are grouped into 10 different knowledge areas. So the knowledge areas are starting from the top: integration, scope, time, cost, quality, human resource, communications, risk, procurement, and stakeholders. So these are the 10 different knowledge areas. So reiterating, these knowledge areas are the complete set of concepts, items, and activities that make up a professional field, project management field, or an area of specialization. So we look into one by one very closely. So this knowledge area, first thing is as an integration. Now we'll put that knowledge area into different project management processes stages and assign the different skills that are required to or the processes that are involved in the knowledge areas. That is, in the initiating process, the project management process required is to develop a project charter. And in planning stage, you need to develop a project management plan. In execution, you are required to direct and manage a project work. Whereas in monitoring and control, you monitor and control the project work, and as required, you have to perform an integrated change control. And in the closing phase, you have to close the project or phase. So here the knowledge area applied is the integration of different activities that you carried out in each and every process and then deliver the different items that are listed here. So in the next stage, in terms of scope, it is applicable. This knowledge area is applicable for the planning and the monitoring and control phase. So in planning process, what you do is, so you plan the scope of the management, you collect the requirements, you define the scope and create a WBS structure. Whereas in monitoring and control phase, you validate the scope that is defined and then control the scope. So next, in the time, what you're doing is it's again applied to the planning and the monitoring and control process. So here, you plan the schedule management, define the activities, you sequence those activities, estimate the resources that are required for this activity, and estimate the durations that are consumed or are required for those activities, and develop a detailed schedule to execute all these activities. So here you're incorporating the time functionality into it. Likewise, this is applicated in the control schedule also during the monitoring and control phase. So next, in the cost knowledge area, we had to plan the cost management, estimate cost, and determine budgets during the planning phase. In monitoring and control phase, you have to control the costs. So in quality, that is applicable for the planning, executing, and the monitoring control process, wherein you plan for the quality management, you execute quality assurance, and control quality. In the human resource area, you plan the human resource management, and in execution phase, you acquire the project team and then develop them and manage them. And in communication knowledge area, what you do is during planning segment, you plan on the communication management and then execute the management of the communications and then control the communication that have happened. And in terms of risk, during planning, you plan for the risk management, you identify the various risks, perform qualitative risk analysis and quantitative, and also plan for the risk responses. And in the monitoring phase, you control the risks that have been identified and monitored upon. Procurement. In procurement phase, you plan the procurement management, conduct the procurements, that is execute the procurements, and then control them, and finally close them using the closing phase. And in stakeholders, you identify the stakeholders in the initiating process, plan for the management in planning stage, manage the stakeholder engagement activities in the execution phase, and control the stakeholder engagement in monitoring and control phase. So now we have quickly moved upon all the different knowledge areas and the different sectors, but now let us focus on each and every one of them one by one along the project life cycle. So let us start off with the project initiation process first. So going back to the definition of the initiating process once more. So the initiating process is a process performed to define a new project or a new phase of an existing project by obtaining authorization to start the project or phase. So we will be defining the initial scope, the financial resources that are required, and the internal and external stakeholders. So looking back into the knowledge area, so what is applicable here is developing a project starter and identifying the various stakeholders that are involved in it. So this is what we call for in the initiating process. So let's go by and now define what is a project charter is all about. So project charter is going to be a formal document that authorizes the existence of a project and provides the project manager with the authority to apply organization resources to the commissioned project activities. So let us look into the keywords. So first of all, it's a formal document because it is agreed upon and signed off by the management, so that will give the authority of the team members and the project manager to consume the various organization resource to those activities, because now nobody can stop you in demanding a resource, because that is all agreed upon in this project charter. Because once it is done and executed, nobody else can come and say that no, you can't use this resource. So now this is where this project charter will help us, because it is an authorization document that authorizes and acknowledges the existence of this project in the organization, and this provides the project manager to use the activities and also support the team members to consume those resources. Also, this project charter will have these contents within it. First thing is the purpose or the justification of the project charter. Why this project has been taken upon? What is the use of it? So this is what comes into the purpose or justification part of the project charter. Next is what is the objective of the project and how this project is going to be evaluated. So what is the success criteria of this project? So that is also fed into this charter. Next is all the high level requirement of the project are mapped into it. That means, suppose what are the major resources that are required, what be it the human resources or be it technological resources, what is required, and what are the project requirements are. So those kind of high level requirements are discussed upon and then fed into the project charter. Next, also a high level project description is given to it, because this project charter, as discussed, it is a formal document. So when taking upon and reading this project charter, should give the user an understanding of what this project is all about. So that is what the project description will help you to give in. And also in the charter itself, you will map the high level risk that you are into the project by undertaking it. So this is also included in the project charter. Next is summary of the milestone schedule that we look at, because now here giving a overview of the time constraints that you are looking at. Time commitments of this project is captured in this summary of milestone schedule. And next, a summary of the budget in terms of cost is also included here, and all the project approval requirements. Suppose it has to be signed by the project manager, program manager at the portfolio level, the head of the department, or all those approval requirements are also captured within the charter. And who is the authority of this project, who is the owner of this project, so that assignment is also done in this project charter. And who is the sponsor of this project, that is, this project is going to be consumed or useful by whom, so that person is going to be called as a sponsor of this project. So his or her name and authority is also included in the project charter. So as you can see in the various contents that are included in a project charter, you can see that almost all high level data of this project is going to be captured in this formal document. So typically for a project charter, it's a one-page document that encompasses almost all the information in brief. So next is the identification of the stakeholders. So stakeholders mean a person or a group of people who have a vested interest in the success of an organization and the environment in which the organization operates. To put simply, in the stock market, you are interested in buying a share because you are interested in the growth of the company. You want the company to perform well, so that you are putting out your hard-earned money into it, so that the company utilizes the resources, that is in a first term buyout and saying in that example. So the company will get your resource, that is the money, and then put it in a positive feasible route. So you are vesting your interest on the company. So now you have become a stakeholder of the company by purchasing a share. So that is a generic description of a stakeholders. There can be several stakeholders in the organization. So first it can be a customer, and customers are two different. They can either be an internal customer or an external customer. So internal customer means that suppose you are working in a finance department and you take care of all the costing segment, all those things. But service executive, he comes in for clearing of a warranty issue. So he now becomes an internal customer to your finance position, because in no direct way you will be linking with the processes of a service executive. But only if you clear the outstanding settlement for the warranty, then he can process the warranty claim and then issue it back to the external customer, that is the end customer. So now there is an internal transaction that is happening. So you have to identify your internal stakeholders as well. That is, if you are not executing a task, then the internal functioning will also get disrupted, and that's why you have to ensure that your internal stakeholders are catered to, so that your external customers will get catered automatically. So next is the suppliers to your organization is also an important stakeholders, because they are an active part of the success of the organization. Next is your dealers. So the suppliers will constitute the back facing of your industry. So if you are in a manufacturing industry, your suppliers will give you the raw materials and the sub-assembly parts if you're OEM, so that you put it all together and then give it out to your next stakeholder, that is the dealer. So they will take it to the final customer. So you have two facing stakeholders, one in the back end and one in the front end in terms of customer interaction. So next is the shareholders that we were speaking about earlier, because those shareholders have invested in your firm or organization, believing and hoping and entrusting that you will go on a positive route in terms of both financial and in a growth trajectory, so that they can stay invested in your organization, believing that you can give benefits or profit to them. So the shareholders are also stakeholders to you. So next is the project planning phase. So the definition of the planning stage goes that this is a process performed to establish the total scope of the effort, the definition and redefinition of the objectives, and develop the course of action required to attain those objectives. So here we'll be targeting on developing of the project management plan and the various project documents that will be used to carry out the project. So here we'll see what are the knowledge areas that we have. As you could recollect, during this planning process with different knowledge areas, what we are going to see now first is you have to develop a project management plan, and next you have to plan the scope management, then collect the requirements, then define the scope, create a WBS, plan the schedule management, plan the cost management, then develop a schedule for it, estimate the activity durations, estimate activity resources, sequence those activities, define these activities, next estimate the costs, then determine the budget, then in terms of quality, you plan for the quality management, then you plan for the human resource management, then the communication management, plan the risk management, plan stakeholder management, plan procurement management, plan the risk responses, perform quantitative risk analysis and also qualitative risk analysis, and then identify various risks. So you can see that we have a very dense overlap of several planning activities. So it means that in this stage, we have to do all these activities in tandem. These different subsets of the several knowledge areas that we are seeing will help you ensure that the planning stage itself will account for most of the project requirements and helps you to ensure smooth sailing of the project. Because typically the main objective of making you go through all this understanding of all these things is that you can cross applicate these learnings in your day-to-day exposure of the industry, so that you can identify which task falls in where, and suppose if one of the tasks are being missed out, you can work on it so that in a later stage you need not worry about. So this is how the planning processes calls for different knowledge areas. So here now let us focus on the project management plan. So what it does is it focuses on three baselines. So the first one, it going to define on the scope, next is the time and cost. So what we are doing is we are splitting down this complex interaction into subsequent sections where you can identify and question them. So here the three baselines can be applicated to 9 basic plans. That is, first as the scope management, next you manage for the schedule, next the cost, the quality, human resource, communication, risk, stakeholder, and procurement. So this is the major focus areas that you have to build on the three baselines and the 9 basic plans that you have to take care during this project management plan. So next is we'll see what are called as a project risk. So this is an important area that we need to understand. This is a part of the risk management. So what is called as a risk? So risk is an uncertain event or condition that, if at all it occurs, has a positive or a negative effect on the project objective. So you need to note that this is an uncertain event. It means that it might or might not happen. So in the case that is going to happen, it can have two possible reactions that can either have a positive effect or a negative effect on the project objective. So those kind of risks have to be quantified and included as a part of your risk management plan. So this risk can also be a combination of the probability of a defined threat or opportunity and the magnitude of the consequences of the occurrence is taken as a risk index. So by terming an event as a risk, you bring in the probability of it happening and then impact of it, how frequently it can happen, what is the probability of it actually happening, and based on that you can define a index that quantifies the risk. So we can next quantify how this risk is going to impact our project. So this threat is defined on a scope. If this threat is carried out to scope, then it will result in a very poor quality product. Or if a threat to the schedule will impact the delivery of the project, and a threat to the cost will impact the cost schedules. That is, it can intend to overspend or taking in extra money or budget. So these are the different threats to the three critical areas that we had seen earlier on: scope, schedule, and cost. So this is why we need to have a very clear understanding of all the risk involved in various stages. They are clearly mapped upon and navigated around so that we can safely navigate around these risks. So that is a very important part of the project, that is the risk management. So here in this risk management, as seen earlier, what we are doing is we are identifying the risk, assess the likelihood and the impact of the risk that is quantified, and then rank them and prioritize them so that which should be attacked and which should be left off or deprioritized, and then define various risk management approaches and actions so that those risks can be managed and controlled. So that is being done by implementing those actions that you deem to contain the risks, and finally monitor and review them. So these are part of the risk management process. So this is what you intend to do in your project so that the risks are accounted and managed. So in this risk management, some of the key points that you need to consider are: you have to make the management of the risk integral in a way that the project can be managed. It should not get blown out of proportions. So next is, risks are always there in the project. So even in those cases, you have to ensure that the cost and time backups or the contingencies are consistent that are identified with the risk. So it means that all the backup options that you are taking up should get aligned with the risk management that you have, and so that they still stay within the project charter. Because as said earlier, in the project charter itself, you try to identify those risks and you try to accommodate them within the given structure. So this risk management ensures that even during occurrence of the risk, by proper management and mapping of them, you are able to overcome it with the backup plans that you have in place. Next is, always focus on the significant few and do not try to manage all the risks together. So there is an interesting law called as a Pareto law, Pareto principle. So what Mr. Pareto says is that if you have 100 issues in hand, typically only 20% of the issues will cause 80% of the problems. It means that we do not need to focus on all the 100 problems. The critical few, the significant few, are typically close to 20% of the overall issues. So it means that once you attack those 20% issues, 80% of your problems will get solved automatically. So that you can focus your effort only on those 20% of the significant issues so that 80% of the risks are managed. So that is a key point that you have to take on. So simply means that you're prioritizing onto the major risk that can impact on your project. The next is always be vigilant and proactive, so that because the risk can happen at any time, at any form, and through any persons also. So we always need to be vigilant. So one assumption of the risk might not be the same the next part. So we need to be proactive in identifying an upcoming risk, taking necessary course of steering so that they can be avoided even if not mapped in the early stage. That is, you're dynamically able to identify and avoid those risks. So next stage, now we look at the project execution stage. So as in management stage, this in project execution phase, what you're doing is all the processes that are going to be performed to complete the work defined in the project management plan so that the project specifications are satisfied. Then again in the project execution, we have to produce results, and these results may require planning and updates of the base action. So here in execution process, the different knowledge areas that are called for are direction and management of the project work, performing quality assurance and acquiring a project team, developing of the project team, managing all the stakeholders, conduct all the different procurements based on your budget and time, manage the communication between your stakeholders, be it internal or external, and also manage the project team. So typically, having planned all those things, so this, even though the knowledge areas are of low in quantity, this can be a lengthy process because this is the actual process where the actual work, actual timelines get applicated on. So in this execution process, the most critical part is acquiring and developing a project team and then managing it. So now we'll look into various stages of team formation and planning. So this is to get you acquainted to how the team evolves. So we have two axes here. So the first, on the x-axis we have the functions wherein you get oriented to the task and then move to a stage where you go into effective problem solving. Whereas in the y-axis you have personal relationship between the group managers and group members and how it goes from various stages and final to the output. So this is a Tuckman's model of the various stages of team development. So first we'll focus on the first stage. So the first stage is the forming of the group or the team. So what happens once you put together a project, a fresh project, a group of heterogeneous people come together as we've seen in the earlier slide. So this heterogeneous people, they can be master of their own trade, but still as a group, they do not have the proper cohesion. They are still an immature group. So during the stage of the team formation, what happens is there is a lot of confusion, there's an uncertainty, and then people, tend to close off to themselves. They try to assess the situation wherein how the team is, how the other persons are, and they try to test what is the people's capabilities. Some people will say, decide that, okay, let me stay for within myself, let me analyze. Some people will be more excited. They'll try to try new things. They'll try to, project themselves out. And so here what happens is the other people will try to test out others. And then as a part of the team, then they'll try to bring in their own goals, try to define their own goals, and then they'll try to get acquainted between each other. Then there might be certain groups that are forming up within the team, some focus groups or something. And then finally, they also try to establish rules within themselves. So this is the first stage of the team. So I think you can correlate within yourself when you first get into a gang or into a friendship circle. This is what happens. You try to understand the situation where you are in. You try to get into grasp of what is happening around you and the people outside you. Because at this stage, you have not yet worked intensively on a common objective. Because at this stage, you're still trying to figure out what the objectives are. So that is where you have a high level of dependency requirement between the group members. So you need to understand like what is what and who is who. So next stage, what you're doing is in the task functions where you organize for a task so that you understand that this is the task that is need to be executed. So this stage is called as a storming stage. So wherein you'll try to target towards a single activity. So what happens during the storming phase is that there will arise a lot of disagreement over the current priorities. So one group will say one task need to be prioritized over the others because see, obviously you're all working on the same project, but still the task might get different priorities. So what we have is the group is not still together. There are different factions to it. So and within the faction there also be a struggle for the leadership unless otherwise there's a actual team leader or a project leader assigned, but still the project leader also is a part of the group. Please bear in mind. So this team leader himself will try to ascertain his leadership over the others, and the team members also will try to test his leadership capabilities. And so this kind of situation will lead to a lot of tension, hostility, and information withheld during this stage as the fraction group. So typically in here, the personal relationship is more of in a conflict situation. And in the next stage where you get a little bit of, maturing, that is called as a norming phase, wherein you have a central leader. That is now the leader will get, accepted within the team. All the members will get to a common understanding. So now people get to trust each other. They used to believe each other. They can understand the various skill sets. They'll set their own working standards and then also establish, some stable rules. That is, they'll identify, okay, I'll do this, you do that, so that we together can achieve this objective. And now there will be a cooperation between the team members and the project. So this is where we'll actually start to see some meaningful work coming out of the team. So this can take any time frame that is can be. It can be either within a week or a month, or might not even go in this stage. But typically, all the teams will go typically in this route. This is the team model that is developed. So in this, what you're doing is you still work on, you start to deliver some sort of result. There is some sort of information that is going into the team. And here what happens is you try to work together. So there's a cohesion that happens within the group. So you become a sharing group. The information gets shared freely. So in the next stage, so here is where you'll start to perform. So this where even the leadership structure, the hierarchical structure is kind of broken and you become interdependent with all other. There is uninterrupted stream of information, stream of flow that is happening within the team. You know who to go and how to support each other. You know that this person has this capability, maybe we have to support them in this. So you have this general understanding. You are open to each other. You will outrightly helpful it. You take away all the illusions. You take away all the misunderstandings and have an acceptance towards each other. So what will do is it will help that one person will be helpful, will be flexible to the others because you become more understanding to each other. So suppose if one of the team members say has a personal commitment or so, then you can fill in their shoes. They said, okay, you go ahead, I'll take care of this. Because now the objective is not to project oneself, but to that of the team as a whole. So you share the responsibilities based on the trust that you have built in the previous stage, in the norming stage. So now you become an effective team. So now you start to deliver real results. So this is where you have a very strong interdependence between your team members, and also you have a strong focus on only solving the problem, because you do not need to have to ensure that the information is proper, the tasks are well defined and all those things. So this is where the group is highly effective. That is, you perform towards the necessary action. So finally, so this is the final stage. That is, we'll see in the later part, that is closing of the project. So during the closing of the project, the original project objectives attained, and hence we go about and disband the group. So what happens is you break the group as the project objectives are met, and in that part there is a disengagement of the current activities that are going about. Now these people will become a part of the change that is going to be happen here, because once they have disbanded from the current project, they have to be taken in for a different project or a program. What happens is you naturally get to tend to stick with the previous team. You have an anxiety about getting separated, and ending the positive relationship that you have. You have to end all this positive feeling that you had towards the team member and the trust that you had developed, and you might have developed a very good bonding with your leader, and now you go into a self-evaluation period. So this is a cyclical process of a team building activity. So this is the later part of the team stage that is not much talked about. So this understanding will be useful for you when you are either a part of a new team member. So maybe at that part, maybe if the team is already performing, then you will feel as an odd man out in that situation. So then you have to understand these various factors that play into a team, so that you can take everything in a positive spirit and try to interact between the people much, and always try to be in this position. And also, if you're a team manager, you have to be clear of these influencing factors. You do not have to be carried upon by emotions. Keep those emotional intelligence parameters high and work towards, common understanding of the team. Eliminate all the differences that you have amongst the members. Be supportive. Try to attain this norming and performing stage as quick as possible. Suppose if there is a lot of friction in this stage, and then even though there may be a pseudo norming stage, but finally it might bring out the downfall of the project. So always the project leader should strive to understand the team member's strength. The team member's support has to be garnered by the team leader. He has to prove his leadership in a positive way. There are different styles of leadership that we'll see in the next slide. So you need to exhibit all those leadership styles. So this does not apply only to the team leader, but each and every member has to demonstrate those leadership traits, so that you can all work towards the common objective and attain the targets in a well systematic and a smooth manner. So this affiliative leadership style is to try and bring in all people together. So he'll try to support you more. He'll try to ensure that there's a lot of trust built into the system. He'll try to support in each and every manner it works, so that the main focus is that the team should be a singular one. So whatever it required for, the leader will try to do it. So that is the affiliative type of leadership. He'll try to bring in people together. In the democratic leadership, what is that? An equal opportunity will be given to all the people in the team, so that they can voice out of their concerns equally. So that is the democratic setup. So each and every person has a say on the decision that's going to be taken. So there's going to be equal participation on the rules. The leader will push the team members to voice out all their concerns in without any restrictions, so that all the critical feedbacks are caught into the system. Whereas the pace setting leader, what he does by example. He will lead all the projects together. So he'll try to take all the initiatives together. But sometimes what he'll do is he might not take people in turn. So he can be a little bit of opposite to the affiliative type of leadership, because he will try to demonstrate all the activities by himself or herself. So that is the pace setting type of leadership. And finally, we have the commanding or the autocratic type of leadership, wherein all the decisions are taken by the leader only, and none of the decisions are questioned or commented against. So that is the commanding type of leadership. So typically, a good leader is one who can effectively switch between all the six leadership styles as the situation demands. For example, in certain situations where genuine concerns has to be voiced out, then he has to be democratic, and he has to be affiliative in the sense that he can build cohesion within the team by supporting them. And also he has to be a pace setting leader demonstrating by example and leading by example. He can show that this is how it has to be done, but then it is up to you how to do. So in that case, a pace setting leader can also be a coaching leader saying that, see, this is my way of doing it and the organization expects you to do it. So you do, and if there are any issues, please let me know. I'll help you out. I'll coach you. I'll mentor you all this thing. So this is how you can change the face of your demonstration. And a leader should be a very good visionary because he must not look into the short term, but rather a long term. Always see the big picture, how your small project is going to impact the organization, or how you can turn out this project in a better way so that this project can lead to a set of different new project initiatives that can be beneficial to the organization. And finally, in certain cases where the conflicts rises out of hand, then the leader should be in a commanding position. He should be in a respectable way wherein he can command those activities that can have to be taken care by the team members. So a good leader should have a mix of all these 6 leadership qualities that have to be cultivated during this course of project. So when you're involving yourself in a project, which all of you would be, so try to focus on the various leadership styles and try to develop them by yourself. And also please do remember that you need to have an excellent emotional intelligence also in place. That is, emotional intelligence means you do not react to circumstances. You do not react emotionally, because in a project, the end objective is just to deliver the project objectives. You do not take things personally. Please leave out emotions out of your decision making process. Do not take issues directly at heart. They are just directed at the task that has been done. So if you keep your emotions in check, then you can be an effective team leader as well as a team member. So with this, we'll go to the next part, that is the project monitoring and controlling process. So now let's get back to the project management scope. So here in this monitoring and control process, the definition, if you could recollect, it is the process that is required to track, review, and orchestrate the progress and performance of the project. So what we typically do here, the knowledge areas that are looked into is we monitor and control the project work, perform integrated change control, validate scope, control schedule, control the costs, control stakeholder engagement, control the procurements, control risks, and control communications. Finally, also control the quality. So what we are seeing here is we're seeing the different, almost all the knowledge areas. We are monitoring, managing, and controlling the processes that are involved here. So typically what during this phase, we need to have different inputs and outputs and tools and techniques that are used to do them. So the inputs to this phase, because this constitute most of our activities. So here we should have the project management plan from the previous stage, and we need to have all these project documents in hand so that you monitor at various stages where are we against the recorded project documents. So where are we in terms of the cost, in terms of the milestone, in terms of quality, risk, and also schedule other forecasts that are being considered. So it all been listed in the documents that we have already prepared in the previous stages. So we monitor each and every one of the criteria here against the current actual one and take control of it. And also we look at the agreements that we have made and work performance information that we have collected in the previous stages, and EEF and OPA. So this EEF and OPA or project management terminologies, let us not worry about it in much in detail, but let me just give you a simple overview of it. EEF means enterprise environmental factor, whereas OPA means organization process asset. So simply terming is that this enterprise environmental factor, EEF, is the governing conditions for the project or the organization as a whole. So it means that you do not have any control over it. So all your project has to adhere within this EEF functionality. This EEF can be internal or external. For example, internal means your organization culture, the rules and the regulations that are already in place in the organization, because you cannot overcome them. So your project has to get constrained within this EEF constraint that you already have. So those are our internal constraints. External are sometimes there is a major political policy change that is coming in, or based on a law that is coming in, so or existing laws that are available. So those are the guidelines within which your project has to work on. So those are the environmental factors that is influencing your project. So these EEF you cannot control over them. So this monitoring and control process again has to get guided or constrained within what is already permitted within your EEF. Whereas this OPA, organization process assets, typically comes out from the previous experiences or the internal project related processes that you put in place. So, for example, based on the previous process or previous projects, you constitute a change in the process or templates that you follow so that you can have or cannot or need not follow based on your requirement. For example, for the current project, you deem that the existing, for example, the project charter template is not applicable for the current project that you're handling. So then you can modify this OPA assets to suit to your current project requirement. So this EEF and OPA goes way back during our planning stage itself. So based on the planned EEF and OPA resources and how do you control them in this phase. So this is what it's all about for this inputs. So next, going into the tools and techniques that are available to involve in this process. So what you're doing is you have to have a frequent review meetings with expert panel, be it your HOD or other department experts who can comment on the monitoring process that you have here and control process so that they can review on how the project is going on. So towards this, what you have to do in terms of consolidating the data is that you have to perform an alternative analysis, then do a cost benefit analysis, and then perform an earned value analysis for your cost benefits, and then root cause analysis in terms of risk or failures, and then go for a trend analysis for forecasting, and then variance analysis to evaluate what are the difference in the quality of your product. So these are the different data analysis tools that you have under your disposal. So if you're interested, you can go and investigate into each and every one of these tools. But towards the end of the lecture, we'll also quickly go through the basic project management tools that will help you to navigate. So finally, using this data analysis tools and the expert panel, you end up at a decision to either to change the course of the project or not. So finally, the outputs what you get in this process is that any change request, that is the current activity has to be modified in a certain manner based on the either the change input requirement or during the process you deem that this direction is not suitable, you have to move in the next step. So those kind of changes have to be tracked and monitored. And next is all the work performance reports have to be generated as we have seen earlier with the work performance data and the information. You process them and then build in reports, and the project management plan will get updated based on the current activities that you are performing, and these updates will also get reflected in the project documents that you have taken up. So this is the monitoring and controlling process. So finally, going on to the project closing phase. So in this closing process, to go back to the definition, so this is a process performed to conclude all the activities across all the project management processes to formally complete the project phase or contractual obligations. So if you could recollect in the first stage, what we did is we started off with the project starter. So what we're doing is in this closing stage, we close all the project commitments, we close all the procurements. So typically what we do here is we take in all the inputs, that is we start from the project starter, then take in the management plan, then the project documents, and consider all the accepted deliverables that we have figured out in the execution phase, and take in all the agreements. Again, look into all the OPA documents that we have, take in all the procurement documentation, consolidate all the business documents. So with these inputs, then you move over to the expert panel, wherein you verify all the documents, you perform how you fare against the given target and what is the actual. this is done all through meetings, and then finally what you do is you conclude this by specifying the final product or the service or the result transition from one stage to other, so that you deliver, you conclude that you have attained on the given target. And then if required, you update your organization process assets based on your learnings and findings, and then prepare a final report and attach them with all the updated project documents. So with this final consolidation of the information, you close the project. So this is how you go about the general project management process. So to put it simply, considering all the activities that we are seeing here, a project manager has to have these roles and responsibilities. So what he does is, a good project manager should take ownership of the whole project. So again, we're trying to emphasize is that you do not need to have a project manager title to you in order to exhibit these skills. As we had seen earlier in the team skills and the project leadership skills, you have to take ownership irrespective of the title that you have. You have to take the ownership of the whole project. So next is, the project manager should be proactive and should not be reactive. So proactive in terms of attending all the risks, attending the requirements, and not reactive is you do not wait for those situations to get happened and then only react. And also he must be emotionally prudent. So the project manager also plans his or her activity adequately, including all the dimensions of the planning into it. You think forward, you think with the previous examples that you have, so that all the dimensions are brought into the planning stage itself of the project, and is authoritative, as we said in the leadership style. That is, you are able to take leadership, take ownership, and take informed decisions, but not an authoritarian, because you do not want to be taken as a person who just blindly commands. Okay, so you have to be authoritative in each and every part of your activity, but not an authoritarian response. And you should be decisive in taking the decision. So that means that you take all the decisions based on the data that you have taken. So by that data, you have to be confident and presentable in those data information. That is, you're decisive up to the point. And you should be a very good communicator. See, all the activities or tasks that you're doing is expressed only based on the communication that you have. So this communication is two front. One is a verbal communication and a non-verbal communication. So please take a due care on all the verbal communication that you have, and also the non-verbal communication based on your expressions, your body language, and also the type of presentations, your reports that you have. You need to have a complete command over all these features. So you need to be a very good communicator of the ideas that you want to communicate. It should be clear and crisp. So next is, you have to manage by data and facts and not going by gut feeling or by uninformed optimism. That is, you do not take it to your feelings. All the decisions, as spoken about earlier, always have to be backed by hard facts and figures, so that it will help the other team members also to take an informed decision. They are no longer swayed by their own decisions. So always, as said earlier, you have to be leading by example. You have to set the pace of your team. You have to lead, showing that this is how it has to be done. And also, you have to have a very clear judgment of how to take it. So this sound judgment means that you're not biased and you're always leading by example, and always have strong and hard facts that have backing your judgment. And always have to be a motivator. As we seen earlier, you have to be a coaching type of leader, wherein you can motivate all others to go get in the same wagon, to try and improve their own skill sets, so that they can improve as a person and also can contribute a lot to the team. And also should be very diplomatic. Obviously during the course of a project, we'll encounter a lot of issues between, be it interpersonal or any other thing. So you need to be very diplomatic, handling all the issues, making sure the team gets bonded very strongly, and you have a very strong dependence level within you, within your team, so that you can achieve the project guidelines in a focused manner. And finally, you also need to be able to delegate the activities that you need to do. For example, delegation is just not simply redirecting it. You still take ownership of certain activities, but certain other activities, you direct them to suitable persons in your team and take it to completion. You monitor them and encourage them to get completed. So it means that, suppose you're a part of a team, you're not a leader, you're not a project manager, but you're a part of a team, and some activity comes in, and you have the flexibility to do it. And if you understand that maybe that activity you cannot take up now, and you feel that this activity can be taken care by another person, then you can of course delegate them. You can pass out this activity to the next person, maybe he who can have take it, do it more effectively and in a shorter time, and also maybe he is not loaded that much. So this again has to be taken in a diplomatic manner. If you're leader, then you can delegate directly, but if you're a team member and if you're delegating, it has to be properly communicated. It has to be make sure your team leader and your colleague also understands that it is not a activity of passing responsibility around, but taking an informed decision, taking delegating the task so that it is done effectively and correctly. So before concluding, we'll look into the various project management tools in brief, so that you can try to implement in the whatever activities that you're doing in a small manner, so that it can help you out. Even if it's a small task, even if you're not involved in a project, it will help you out to take it up in a structured manner. So the first thing is the project charter. So this is one such example. As we discussed, it includes what is the project name, who is the sponsor, who is the manager, and when it is starting, what is the description of the project, what is the scope of it, where this project is going to get impacted, what are the different constraints in terms of the time, budget, scope, or quality, and what are the project deliverables that you have. And by taking up this project, what are the benefits that you're looking at? What are the KPI? KPI means key performance indicators. So by which you give out these specific targets. What is the current baseline that is now, and what you intend to do based on this project? And then who are the stakeholders and what are the risks that are involved in it? So it might not be detailed if you are not in a a structured project, but still for every activity that you're doing it, try to conceptualize these factors so that it will help you to plan effectively. And this is an example of the risk rating, where you quantify the activity against the likelihood of the risk, again, and the severity of the risk. So this rating index will quantify where you have to take it. Suppose if an activity falls in the catastrophic region of say 20 to 25, in that range, then it needs that the project has to be stopped at that point, because continuing on will impact the overall project itself. So you have to look back into the documents that you have to look back into the process, so that identifying the risk earlier and then attacking them will help you to stay on track. So this is one such example of risk rating, wherein you quantify the likelihood and severity of the risk. And the next and most foremost frequently used part of this project management that everybody should be aware of is the Gantt chart. It is nothing but it can be also done on Excel. A lot many tools available online. So even if you're doing a simple drawing, AutoCAD drawing, you can still quantify it in Gantt chart, stating that the first process is to open it up. Suppose there are 6 different parts in drawing, you can constitute one part of the other as a sequence of activities. So typically what you do is, this is one such example taken from projectmanagement.com. So here what we're doing is, the tasks are split down into major and micro levels, and then each are identified a separate timestamp, and then dependencies between the tasks are being done, and milestones have been defined, so that you'll get to understand the flow of the project, where you are, and if any delay will how it is impacting on the overall time plan of the project. So this is where this Gantt chart is going to be of heavy use to us. So I would request you to make yourself familiar with the usage of this Gantt chart so that you can apply it on almost every activity that you happen to do, so that your activities get more streamlined and you can still focus on the major activity, while any disturbance in the timeline will alert you by looking at this directly. So on concluding remarks, so in this session, what we had seen was basically all about project management techniques. So we were looking simply at this. In order to execute the project, we need to take a note of the scope, the cost, and the time that is involved in the project, and also manage the quality, resources, and risk in time so that you deliver the project as expected. So towards this, we have followed processes, that is, you initiate the project process and then plan it out, execute them, monitor and control it, and finally close it out. So this is all about project management that I would like to talk to you about today. So now this brings us to the closing remarks of this AutoCAD session that we had for the past 12 weeks. So this is the epilogue section for this course. So what we are seeing is, from beginning we saw what is the AutoCAD draft, typically what is drafting is all about, and where AutoCAD features in, and what are the different basic drawing techniques that starts from line, arc, circles, and oops, erase, and then we moved on to the different editing techniques that help us in terms of break, offset, move, copy, array, and trim. So next we also see how to manipulate the views in 2D that we have using pan, zoom, and we also looked into different steering wheels that are available as commands, so that to quickly move through the segments that we had. And also we looked at the various selection techniques we had, and in week 4 we were looking at the different editing techniques in this MN section, specifically on this text commands, multi-line text, styles, color, line types, and then editing such as stretch, scale, extension, joining, lengthen. So we had seen a lot of techniques on those. And then in week 5, in manufacturability, we were focusing on the internal section demonstration using the hatches, and then curving off the edges using chamfer command, fillet commands, and also we looked into several inquiry techniques such as list, distance, radius, angle, and particularly area. And in week 6 and 7, we were focusing a lot on the GD&T techniques. What are the theory behind those things? And also, we had looked into the dimensioning techniques in AutoCAD along with the tolerance specifications. And in the week 8, we were looking at the various productivity enhancement techniques. That is, we are looking at the blocks, geometric constraints, layers, and also typically into the one key shortcuts. So typically from week 8 onwards, we focus more on the actual usage of the drawing, demonstrating of the drawings, how to do it faster, how to do it quicker, how to propagate them. That's in week 9. We were looking into in collaborate effectively. We were looking at using external drawings as extras, and then using the functionality of Xbind. We looked into tool palace and design center, how we can use it to our requirements. And then in week 10 particularly, we were looking at how to do different type of plotting, particularly in terms of PDF or in terms of drawing, and setting up plotter configurations, and all those things we had looked in week 10. And also we had looked into a powerful technique called as macros that can quickly go about the task in a straightforward way. And also we had used those macros in our own custom tool palettes so that we can customize the application the way we want. And week 11, we looked into creating our own commands. Instead of using AutoCAD commands, we created our own commands to do a set of activities using this auto list techniques. And then in this week, we had looked into project management techniques that we need to be aware of. What are the skills required for a good leader, and what are the different project management tools that you can use. And also, we had also looked into various file management techniques, how to name the files, how to name the folders, and what are the different version control tools that are available and how you can do them yourself. So we believe the techniques that are being covered over the past 12 weeks would really help you out in mastering AutoCAD, and also, take up these skills onto actual organization situations where you can effectively demonstrate them, adding value to both personally as well as the organization. And so wish you all a very good luck in your personal and professional career. Thank you.